Good morning, good afternoon, and good evening, everyone. We're so glad to finally be here. I mean, we've been working on this for months and months, and we're building up the tension, and wow, finally it's here. Our annual .NET Core Summer event, our last event before the vacation starts, and usually we do this in person. Well, as everybody knows, things change nowadays, so we're going to do this thing online. Of course, that means that we can only have more people joining us, people from all over the world right now. So we're very excited to get this whole thing started. Now, before we get started, I'd like to thank the team for all the hard work that they did, especially you, Edwin. He's been working, well, 24/7, I think, last couple of weeks to get this thing going. Thank you for all this. Let's not forget our sponsors, especially Info Support, who made this whole thing possible. It's amazing how they always are ready to support the community. So thank you for this. And of course, all the speakers who are willing to donate their time to prepare a good session for you guys and girls, and to learn something new, to teach you something new. So we're eager to get started. So speaking of speakers, let me introduce our first speaker of the day, Ronald Guijt. Ronald Guijt is a frequent speaker. Good morning, Roland. Frequent speaker at our user group. He's a very well-known Pluralsight trainer as well, and overall a great guy. He's also about twice as tall as I am. Whenever I'm standing next to him, he's straining my neck because I have to look up all the way. So Roland, tell me, looking forward to the day?
Oh yes, so this is always so. It's been a tradition, right? It's the third time now.
Yeah.
So I think I was there in all three editions now, and I really enjoyed every single second of them.
Well, it's an honor to have you again, and it's an honor to have you as our first speaker, because tension is building, and we can't wait to hear what you're going to tell us. So, Roland, the floor is yours. Everybody have a great day, and I'll talk to you later. Roland, take it away.
Thank you. So, good morning, everyone. Today I want to talk about Blazor Components. My name is Ronald Guijt, and I'm a trainer, like Dennis said. I'm also doing consultancy and also classroom training, by the way, in the Netherlands. Today I have a really full schedule, so I think I have about 50 minutes, and I want to tell you a lot about Blazor Components. So for that reason, I am asking you to keep questions until the end. I don't have time to answer them in session, but afterwards I will be available on my Twitter. It's on screen now, as well as I will also check out the YouTube chat. So if you have any questions, feel free to contact me. I'm sorry I can't answer questions in session. So what's the plan for today? Well, first of all, I want to point out that we have a unique collaboration on Pluralsight right now. It's the Pluralsight Learning Path. And most of the authors that are on that path are European authors, so we kind of have the exclusive rights on Blazor on Pluralsight. If you want to check out my course, it's about the same topic, and I have the time to go in a bit deeper about things. When you want to check that out, feel free to do that. So, what's the plan for today? Well, first of all, I'm going to tell you what Blazor is. It's not the purpose of this talk. It's just to make sure we're on the same page. And then we're going into the basics of component building, and pretty soon we're going into the advanced component capabilities. And that's really what we're here for. So let me first start out with explaining you what Blazor is. So Blazor is a single page application framework. It's in a sense just like React and Angular. The only difference is that you can write client-side code in C#. Now, how does it pull it off? I will show you in a second. But first of all, when you are creating Blazor components, that means you're writing components. So it's the application you're building. You build that up with components. A page is also a component, for example, and in a page there can be several components. And of course, the benefit of that is that you can easily reuse everything you create. Once you have a component, you can use it on several pages, for example. And it's a very structured architecture because of that. So Blazor works with two hosting models. I'm going through this really quickly. So we have this Blazor WebAssembly model, which is out for, well, I think a couple of weeks now. It's actually been released. So we have a server on the left side and a browser on the right side. And on the server you have these written components. These are sent to the browser, but the browser of course doesn't understand C#. So the runtime is being sent along in the form of Mono. It's a very special version of the .NET runtime, which parses your components. And Mono itself is in WebAssembly. And WebAssembly is something the browser can understand next to JavaScript and everything else. And then it can parse your components and render them. The second hosting model is Blazor Server, and that works a bit differently because all the components are rendered on the server, and once they're rendered, the output of the components, so the HTML and the etc., is sent to the browser using a SignalR connection. And when something happens on the browser, some interaction occurs, then this is also sent via the SignalR connection, and then the server processes that and sends the results or the updates back to the browser via the same SignalR connection. So which one you should choose really depends, right? It doesn't need to be scalable, and do you want to utilize the CPU of the user? Then WebAssembly maybe is the best choice. But this is very Blazor Server can be more secure in the sense that things happen more on the server side. So that concludes my introduction for Blazor. We're now diving into a demo application, and we're going to look. So it's available on GitHub. And we're going to look at the basics of component building. And first of all, I'm going to show you the structure of a Blazor app real quick. So the application is this one. It's nothing, so I'm not going through the functionality or something. It doesn't matter what it does, but you see a list of conferences in this case, and you can click on a link, do stuff. I can approve my own sessions. That's how I got to talk here, of course, because you can add a new conference, etc. So it's a really basic application, and we're going to look at how that is built up. So when we go to the Solution Explorer, let's first start. So I have this. I have this Blazor project. And this Blazor project has a normal ASP.NET Core structure. And we start out with Program CS because that's the entry point of the application. Let's see what happens there. Well, this is a Blazor Server project, so not a WebAssembly project. And in a Blazor Server project, it looks kind of like a normal ASP.NET Core Program CS class. We have the startup class. It uses the startup, and when we go to startup, it adds Razor pages, and that's because Blazor components are in fact Razor pages in the sense that they are Razor actually, and ASP.NET Core also already has support for that, so that's actually utilized here. And we do add server-side Blazor. And in the configure method, we configure this Blazor hub. That's actually the SignalR hub that's being configured. It's being plugged into the pipeline, and then we have this map fallback to page line, and it points to host. This basically means that every request we do, it doesn't matter at which URL, at which sub URL, it's going to map to _host. So that's interesting to look at. What is _host? Well, it's a CS HTML file, and the CS HTML file contains the basic HTML structure, and it renders the first component. So we have this render component async, and it says render component async app. So app is our entry point component. That's when we enter the realm of Blazor. So this is the startup of this is the skeleton code for a server app. When you going to look at WebAssembly, it's going to look very different because it's a very different hosting model. But eventually, the same root component is being rendered by both hosting models. This app. And this app component, the good news is that this app component looks exactly the same for both hosting models. So, and actually all the components you write will run as is on both hosting models. So that means you can start out with one hosting model and relatively easily change it to the other hosting model eventually. But there's one but. You have to think about what's possible on the server and what's possible on the client. For example, accessing a database directly, or accessing the file system, or that kind of stuff is feasible on the server, but not in the browser, of course. So you have to think about your design when you're creating components, but the components themselves are compatible across hosting models. All right, so let's look at this app component. So this app component, it renders another component called a router. And this router, what it does is it scans the given assembly here for pages. So what is a page in Blazor? It's a component with routing data. So it's just like a normal component, no difference between other components. It just contains routing data. I'll show you what I mean in a second. So it tries to map the URL it's coming in. So I'm asking for a certain URL to a certain page in this assembly. When it finds that, it uses another component called the route view to actually render that component using a layout page. This is the layout page. If it's not found, here, not found, then it renders a layout view, which is basically the layout page with this content. So that's all the app Razor does. It routes, it maps the URLs to a certain page. Now let's look at which page is at root level. So when I'm requesting the root of the URL, which component is rendered then? Well, I actually know for a fact that it is the conference list, and you see this routing information here. So it says page root. So that's the information the router needs to actually map it to the URL. So that's why when I run this application, this is the landing page for the application. And then we see some Razor, and all the way down we see this code section, and that's typical for Blazor. So here there's a code section and a markup section. In this code section, I can declare a variable, and I can, in this case, create a method. Now, when I compile this application, this whole component compiles down to one C# class. And this C# class is then used to render the component either on the server side or on the client side. So that's a thing to keep in mind. You can see here that I'm declaring a variable, a private called conferences, which is just an IEnumerable of conference. And And I'm using this lifecycle method called onInitialized async. And that means every time the component is initially rendered, this method fires. And in that method, I'm getting the conferences from an API. And I'm putting them in this private. So that's pretty straightforward. Now when I go up, you can see that I first check if conferences equals null. So initially, which is an async operation to get the actual conferences, so initially it's null, and it's not really visible when I run it at localhost, but when it is deployed, it will take some time to get the conferences, and in that time it will show the loading screen. And if it's done, I see the actual table. Now the cool thing about Blazor is that this is dynamic. So this conference, this is a data binding to conferences. As soon as the conferences changes, this if statement gets reevaluated and automatically updated without actually. So and that it gives you this single page application feeling. Now let's take a look at this this table. And this table has a head, and then in the T body I do a for each conference. And in the for each, I'm rendering another component, the conference list item. And this conference list item gets past the conference that is, well, the current conference in the for each loop, right? So that's passed to conference list item. Now let's take a look at that component. Well, you can see that the structure of this solution, it has this pages folder, and we have this components folder. So like I said, there's not much difference between these two, except for the fact that pages have routing information. So that's the distinction between the two. So conference list item doesn't have any routing information because it is rendered in the page, right? So let's take a look at that. So you can see now no page directive, there's no routing information. And it immediately starts with a TR and it renders all the stuff about the conference. And it also has an if statement, and it colors the attendee total a certain way when it's greater than 5. It also has a code section, and this code section is actually the conference it has to render, but this one is marked as a parameter. So that means. So parameter means like a kind of a super public. It is public, but parameter makes it super public. And that means it can be set by another component. So outside this component are other components. And with parameter, it can be set by them. So in this case, I actually used conference list to set this component. So when we go back to conference list, so we can see here that I'm filling in this property, and it's converting this to camel case, and it's passing in this conference, and that means that it will end up in this variable. So if something is marked as a parameter, it can be passed in by other components, and one way to do it is by using an attribute-like structure. This is like an HTML attribute, right? So that's one way to do it. We'll see another way soon. Okay, so this is kind of how components work and how they pass on data to each other. All right. Now let's look at another component, the proposal list. So this is the page that is shown when I press on the proposals link and I see the proposals for a certain conference. Look at this routing information. It says /proposal/conference ID, but conference ID is an expression. And conference ID actually maps to a variable. So when I scroll down in this in this component, oops, I don't see a code section. Where's the code section? That's interesting. No code section. And that's because the code for this component is separated. So I have a file for the markup and I have a file for the code. And you can see that by this inherits directive. It says an inherits proposal list model. So I have this proposal list model class, and that's actually the code for the component. It's used in the component. So I have this nice separation now, separation of concerns. So this code, this class that I've created, derives from component base. And actually, all components derive from component base. You don't see that, but I already told you that that each component, all the razor and the code that you have in a component, is being compiled down to one C# file, and that is a class. And that generated class always derives from component base. But now in proposal list, we have said no, you shouldn't derive from component base. You should derive from proposal list model. And proposal list model derives from component base. So it doesn't matter if you put layers in between, as long as ultimately you derive from component base. So to illustrate that, we have, so in a component that doesn't have a separate code file, we have this conference list, for example, conference list. Conference list has a generated class. So the razor and the code is put together in a class, it's generated, and it directly derives from component base, which is in the Blazor framework. When you have the proposal list, we still have this generated code, because we still have razor, and this razor is translated to code. But it now derives from proposal list model, and a proposal list model derives from component base, which is in the framework. And of course, you can go as far as you want. You can even put in another layer if you want, as long as you ultimately derive from component base. Cool. Well, let's see what else we have. I was talking about this conference ID expression, which is in the routing information. Well, let's go to proposal list model again, and we can see this conference ID. Conference ID is a property, and it is marked as parameter. So this is another way to set a parameter by using the routing information, by using an expression. So the conference ID that is in the URL will end up in this variable. And we have the same structure here. We have this enumerable of proposal, and we have this this proposal service, which is injected, by the way. I forgot to mention that. You can inject the types you have by using the inject attribute. So it's just fetching the conference ID, the proposals for this conference ID, which is parsed. So that's basically how this application works. Now let's go back to the conference list. On the bottom of the razor, we have this add conference link. It just is an ahref, and it points to /add conference. Now, when we go to the add conference page, because it is a page, because it is being invoked by using a URL, a routing data, you can see we have this /add proposal /conference ID, same thing, right? So we're being passed in the conference ID, and we have some other components I want to show you. So these are built-in components into the Blazor framework. We have this edit form. We have a data annotations validator, which actually looks at the data annotations on your model and checks them. And we have this validation summary, and all the inputs are of the type input text. So why are these separate components? Because we have this whole validation system in ASP.NET, which is actually utilized by putting in these components. Also, there is some data binding going on here. So this input text is binding to this title property. And I will talk more about data binding in a minute. All right, so let's run again and see what it actually means to be a single page application in Blazor. So we have all these components. Now I open up the F12 tools in the browser. It's a little bit small, but I'm zooming in. Yeah. So we have this body tag, and we have this app tag, and we have this container. And in the container we have these rows, etc., etc. Now when I click a link here, oops, it will be difficult, so I'm zooming out a bit. Yep, that works. So when I press proposals, watch the F12 window, watch this section here. So when I press proposals, you can see that, well, it's actually not very obvious, but oh yeah, there we go. So when I navigate through this application, you can see that here now only this div updated. And when I press add, only that div updated, not the whole page. So that's actually what's going. So what Blazor does is when an event happens, when I click something or navigate to a page, it renders the new DOM, and it compares it to the old one, and then just updates the sections that were changed. So that's a very efficient mechanism, which is not uncommon for single page applications. All right, so now let's go back to the slides. So I have another demo for you, another application, and for that we're going to do some advanced component writing. We're going to talk about all these topics, and you can find this application at this GitHub from GeoClearen, which is a colleague of Pluralsight colleague of mine. We used this application throughout the whole Blazor path, and he actually created it. All right, so let's take a look at the application. Let me run it. And we'll see that, there we go. It's a very nice looking application. And we'll start out with this very useful component. So everybody wants this component because it's this profile picture component. It has a very, very useful feature, usable in all your apps. Yeah, in all your apps, because when you click it, the picture changes from square to circle. So that's really useful, right? You want this. You can also see that when you look at these two instances, these have a difference. One has this caption and the other one doesn't. So let's see how this application sticks together, this component sticks together. So we have this this profile picture, and this profile picture has a code section and a markup section. And the thing I want to point at is want to focus on in this component is this image tag. So we have this image. It has a certain and it has certain CSS classes. But one of the CSS classes is special. So we have this add CSS class that actually points to a field in my class. And the default value is circle for that field. So it starts out with being circle. So so that basically means that IMG gets a CSS class circle because that's actually put in here. But it also has an on-click event. This image has also an on-click event. And when that is fired, so there's distinction between Blazor events and JavaScript events. And you can see the difference because of this add sign here. So when I do add on click, it's a Blazor event that I'm handling. And in this case, I've written a one-liner, a lambda. And it's get this E. And E is actually mouse event args. This is passed in. And then the CSS class toggles between circle and null. That's basically what it does here. Now this is a simple one-liner, and that's why I've written a lambda. But you can also just create a method like this, which contains the same logic, right? And just point to that if you want. So instead of this, you can say add profile, click. That also works. So it's just a matter of preference of how many lines of code you want to write. If it's just a one-liner, maybe a lambda is okay. You can just pick and choose. So the thing is that as soon as this CSS class property changes, you saw the UI updating, right? So it's dynamic. So as soon as I change the value of a in this case a field, then the UI gets automatically updating, and that is data binding. It's one-way data binding. So when I change something in the class, some variable in the class, then the UI updates. But when I update the UI, the value in the class won't be updated. And we'll get to that, but for now, this is one-way data binding. That's how it works. The other way is another thing here, which is interesting, is this child content. So child content is a parameter of the type render fragment. So render fragment is just a fragment of UI. And it's called child content. And this child content is actually just rendered within this div. So whatever child content is, it is rendered over there. Now, but this is a special thing because when a render fragment is a property and called child content, it's kind of a special kind of a magic render fragment. Because when this profile picture is rendered, let's take a look at where that is. It should be somewhere on the home page, right? So we have this this indexed razor file, and here we have this profile picture which is used, and now you can see that there's just text between the start and the end tag, and that is actually what is being put in this child content property. But it has to be named child content for that to work. So it's kind of a naming convention going on there. So that's how the caption works for this profile picture. Now, let me go on with another component, which is well, probably more interesting, because when I go to employees, I get this list of employees. Well, we already saw how that works, rendering a list, etc., creating a table. But I have this little thumbs up, positive kind of icon. When I click it, I get to the benefits for this employee. So the benefits in this case are health insurance, paid time off, and wellness. And there is a certain start date for the benefit, and there's a certain end date. So I can say, well, the end date is 26th of March 21. And when you make a mistake, you say, oops, that's not correct. And you can press this little undo button, and it switches back to the original date. Also, when you activate certain benefits, you can see the row gets highlighted. So with wellness and education, the row gets highlighted. With the rest, no highlighting. And that's because these benefits are expensive. So there's some extra emphasis on that. Maybe, I don't know. Wellness, yeah, sounds expensive. So so this whole functionality I want to explain next. How I did that. We also have a save button, by the way, which is getting activated and deactivated when changes occur and when you press it. All right. Let's take a look. Yeah, so here we have the benefit selector component. And this benefit selector component, it has a separate code file, as you can see here, the benefit selector base, which derives from component base. And it has these benefits in a property. And these benefits are rendered in the Razor, like before, with the for each and in a table. So nothing new here. And we have this tr in the table that renders each benefit. But this tr has this key, add key attribute being set. So what is that? What does it do? Well, the key makes sure that that when you have a certain collection and it is being changed, the right one is updated. So, for example, we have this collection of benefits, health insurance, part-time education. And then we do this for each, and we render each benefit, right, in the component. But then the collection changes. Health insurance is changed to health care. Well, we have this data binding going on, remember? So when something in a variable in your classes change, the UI updates automatically. So what happens in this case is you should expect that only this benefit will update in the UI. In fact, in some cases, it could be that that isn't the case, because there's no matching going on between the actual variable and the component, the visual component it renders. And you can establish this link manually by using key. So effectively, when Blazor cannot match the object with the UI presentation of it, then it will just effectively render the whole list again. So when I only change this health insurance to health care, the whole list is being re-rendered. With key, you can say, well, I'm now putting, for example, IDs in front of a benefit. So I'm telling Blazor health insurance is number one, etc., etc. And then when this list is rendered, these IDs are matched with this number, and when it updates, it just updates the one, in this case, benefit. So that's what key is. Now, this key can also be set to an object reference. So you don't have to use an integer like in the slides. You can also say, well, I want to use the benefit object reference as a key. And then you will have this association, and as soon as you update one of the benefits, it will be automatically updated, and not the whole list will be re-rendered. So that's the purpose of key. And the next thing I want to point out is this checkbox with which you can check the benefit on or on. It actually uses two-way data binding, and it does it in a special way. We have this checked attribute, and this checked attribute is just it's an event, right? And this event, no, sorry, it's not an event. It's just an attribute that tells the checkbox to be checked or not, and we bind that to benefit selected, which is a boolean of the benefit. So this is one-way data binding, right? So when I click on when I change this variable, it will reflect in the UI, but not the other way around. And that's why I also have I've handled this onChange event. And this onChange event will fire whenever the checkbox is clicked in the UI. And in that event, I'm using a lambda, and I'm calling a method which passes in the mouse, in this case, a change event args, and the actual benefit, the current benefit, where this TR is for. I need that reference as well in checkbox change. So when I go to that method, you can see I manually set the selected property of the benefit to the new value. And that's actually two-way data binding, because now it works in two ways. But there's an easier way to do this in Blazor. So instead of using this, you can say, well, let me get rid of all this, and I can just say add bind equals benefit selected. And this actually also establishes two-way data binding. So the code I just showed you is implicitly executed here, because the value, when I click on the actual checkbox, the value will be changed in the class as well. But why? So when this works, why did I choose this approach? So when you were in front of me, I would ask you this question in person, but since I can't, I will tell you. So when I do checkbox changed, I want to do more than just change the value. I have other stuff to do. So I can't rely on this default behavior of bind. So in checkbox changed, I not only set this new value, I also set save button disabled to false, which enables the save button. And I'm checking new value, and if the new value is true, then I set a new start date and a new end date, and then the start and end date appear, etc. So I'm initializing this benefit for use, basically. So that's why I have this separation between event and the checked attribute. All right. So there's another thing going on, because you also saw that when I checked a benefit, that the row, the employee row, would highlight. And the problem is that this is not in this component, right? So the highlighting of the row is done in another component, because we have this employee row component here. So this is a row in the employee table, and this employee row component renders out the employee, so the one record for the employee, one line in the table. And lastly, the last thing it does is it says it renders the benefit selector, passing in the employee, etc. But at some point, when this benefit selector selects a special kind of benefit, a very expensive benefit, then it has to highlight itself. So this row has to highlight itself when something happens in another component. So how do you do that? Well, this is that's the on premium toggle thing that's going on here. So let me go back to the code for the benefit selector. So one of the properties I have here is on premium toggle, and it's of type event callback of bool. Now, event callback of bool is a delegate. Well, it's actually not a delegate. It's not literally a delegate, but it functions like a delegate. So when I say event callback of bool, it means a function that does something with a bool, right? On premium toggle, and it's marked as a parameter. So that means another component can put in basically a method into this delegate, and then I can fire this delegate by calling invoke async, passing in that bool. And the bool is in this case, are there any benefits which are premium and selected? true or false. So that's being passed into this delegate. Now, when I go to this employee row again, and then the code for that. Sorry, I first want to show you the on premium toggle is here set to a method. This is actually a method that is in the code for this component. So in other words, it's a method that gets a boolean. It's being called by a child component. Now, when I go back to the when I go to the code for this, then you'll see that premium toggle is indeed a method that takes a boolean. When it gets this boolean, it sets this has premium benefits boolean on the employee. Now, when we go to employee row, I'm actually using this has premium benefits boolean to determine a CSS class, and I'm putting this CSS class on the TR. So table success means it's highlighted, and else it's empty and then it's not highlighted. So you can think of all these intricate data binding schemes to make your application work. So when I go back to the slides, we actually implemented this now. So we have this benefit selector on the bottom, and eventually the benefit selector is rendered by the employee row, and the employee row is rendered by employee overview. But now the benefit selector wants to notify the employee row something. In this case, if a premium benefit is selected. So for this purpose, to call back on a parent component, you can use this event callback type, this delegate type. So that's very interesting. Hopefully. All right. So the next part of this component, let's go back to the benefit selector, is this data field, this date field component. I want to show you that. So that's the thing. You can press the undo button to go back to the previous value, and it has this two-way data binding going on, but in a special way. You see here it says bind-date. So, and it binds to the end date of the benefit. Now let's see how that works. So date field is in a special library, but you can also create Razor component libraries for to make reuse easier. So I've put this date field component into a separate library, so I can reuse it across several applications. And this date field looks like this. So we have this date field, and it has two things. It has the date itself here as a property. It's a parameter. It also has this event callback of datetime called dateChanged. This combination is the date parameter and the event callback. They actually make that I can now use two-way data binding on a specific property. So when I go back here one step, you can see here bind date. This means that it actually looks for a property that is called date, which contains the value, and also an event callback that is called onDateChanged. DateChanged, right? So there's also a naming convention going on there. If these two things exist, then it automatically hooks up these two for two-way data binding. And that's actually also how forms work. So when you have a form with an input field, you saw in the let me show you that in this application. So we have this add employee dialog, for example. It uses this edit form I showed you earlier, and it has this input text, and this input text has this add bind value I showed you earlier. This means bind to a value property in this input text component in a two-way manner, and bind it to employee last name in this case. So the built-in components also use this technique. Alrighty. Well, now we have another. I have 5 minutes left. I'm going to show you templates. Lastly, so I'm switching to another branch. When I run this application, it's slightly different than the other version. Whoops. It's slightly different than the other version because it uses a table with some extra functionality. So it has this, so when we go to the employee table, we have this little button here that can make the table more condensed or not. And when I go to benefits, it has the same functionality. So this table that is being used is now a Blazor component. Previously I just used a table HTML element, but now I've created my own component of it, and it uses templates. So let us look at what that looks like. So we have this, in this case, we have, let's first look at the, yeah, that seems like a good idea. Let's take a look at employee overview first. And you can see instead of a table, the table HTML element, I'm now using table template, which is a Blazor component. And it binds to items. And it also sets a type for these items. So each item is of type employee model. And then it has some sections here. It has a table header section and a row template section and a child template section. These are actually templates that are defined in this table template. So let's take a look at table template to see how that works. Table template. Table templates. Here, it was in my library. I forgot that. So the table template is a table, and it's typed generically to a certain item. And so you saw me fill that in when I called it, and it actually renders the table with all these sections: table header, child template, row template, and these are defined in the template by using render fragments. So each of these sections is actually a render fragment. So let me show you when you're in the CS file. So table header, row template, child template are all render fragments, and these can be generic as well. And because they are generic, I can now actually do for each on them, and I actually can also check if a certain property is true of that item, and that's because this item is now bound to an interface, and in this interface we have this child template. So you can with templates, you can actually create very generic components which are at the same time a little bit specific, right? Which read these specific components. So this template could be usable in this application, but I can also use it in several other applications, and that's why I put it into the library. So these are templates. All right. So with that, I don't have time for cascading values. With that, I have some takeaways. So I think we can agree that Blazor is a very powerful and very interesting technology, new in the ASP.NET framework, and the components are actually pretty powerful. And for version 1 we have now of Blazor, this is already pretty impressive, and probably more will follow soon. So that will get even more interesting. All right, with that, I thank you for your attention. Have a great rest of the day, and remember, you can ask me questions on Twitter or in the YouTube chat. Thank you very much, and bye bye. See you next time.
Okay, welcome back everybody. After this great talk of Roland about Blazor, we go next to more performance subject. You get to talk by Konrad. Konrad is one of these rare developers who actually cares more about running an application to the best of its abilities instead of adding new features. So he's really an expert on that level. So Konrad, are you looking forward to this talk?
Absolutely, always.
Okay, well, great to have you here, and I will say with no further waiting, let's take you to your talk. So I say, Konrad, take it away.
Hello. So thank you. Hello everyone. Welcome in the talk, which will be, as I was introduced, solely about performance and memory awareness, because those are topics that I like. So I'm presenting such a topics. It will be about what we have new in .NET Core 3 point something and what will be added, or maybe will be added in .NET 5. I'm Konrad Kokosa. I'm on Twitter. If you like Twitter, just follow me there because I'm covering topics like that on Twitter. So I'm also an author of this quite huge book about .NET memory management, or co-founder of .NET Initiative. If you like performance, if you like low-level stuff and digging into the runtime and in general into .NET ecosystem, you can look for us in the web. We are presenting interesting things. So maybe that's enough about me. The agenda for today is it can remind you something. I was basing on some very popular series of cinema movies. Here I will cover 5 topics which are or are not related to performance and memory awareness in general. So we will start talking about null, then we will cover topics related to the GC, then we will cover a little bit about app domains, and then JIT, and in the last, some topics related to overall different APIs that we can use in .NET. So let's start from this episode number 4. By design, I omitted the very first 3 episodes. So episode number 4, a null hope. You probably are aware all that we have so-called nullable reference types added to .NET Core 3.0. We can use them in C#8, and they are quite powerful change in the ecosystem, in the C# ecosystem, because out of a sudden now all references are non-nullable by default. Obviously, this name is a little bit misleading, but we know all about this. By default, references are non-nullable now. So we can enable this setting, and you have this possibility that now if you see a reference in your application, by default it cannot be null. So as we see here, the print customer method is a safe one, can be safe one in such case, because customer is by default not null, so you can safely reference its fields and so on and so on. So this is a very nice feature. You can annotate things that if you, for example, have a reference, you can the question mark annotate that it can be nullable and so on. So the question is, because it obviously changes a lot regarding the design of our application, the safety of our application, the very first question is whether it is something that improves the performance. And because maybe from JVM world, you know that they, for example, have some null checks inside the code being JITed by the runtime. So we could think about, okay, so if we have no nulls by default, maybe the generated code is faster because we can omit null checks in our code. But this is not true, so all this narration is just to say you that it is not true. The JITed code is exactly the same. In case of .NET, it doesn't matter whether you have this nullability enabled or disabled, it is always the same code being JITed, because in case of .NET code being generated by the JIT, the null checks are just omitted because the null handling is on the operating system level. Without going deep into the details, we don't have to make null checks from in the assembly code being generated. So having said all that, nullability is kind of null hope. It doesn't change anything in the terms of performance. It is just safer code, but it is not faster. And that was very fast episode, just to make things clear and expectations. Okay, so episode number 5 is about the GC, because yeah, GC is my beloved topic. So in general, .NET team is making a lot of various changes to the .NET GC because obviously it is a very important part of the runtime. So a set of changes being added. Some of those changes are so that you need to enable them. Some of them are just about things that are working out of the box. First thing is large page support, which is about how .NET Runtime is interacting with operating system. If you know that if anything you relate in memory is based on pages, .NET process also is seeing virtual memory, and it is built on the page basis. So every time you access even a single byte, you are accessing the whole page, and the whole page is 4 kilobytes. So they are page to disk and to the RAM, from RAM to page to and to the disk, and so on and so on. But all this is happening on the page basis, 4 kilobyte size. So obviously we have virtual memory on one side and the physical memory on another side, and we need to translate those addresses, a virtual address that the operating system, that the program is using, and to translate it to the physical address. And this translation is a little bit of overhead, because it is not trivial to make this translation, because we expect the page usage along the whole virtual address space is quite sparse. We are not using any linear translation, but we are using 4-level dictionary for that. So every time you see virtual address, in fact, it consists of so-called 4 selectors. We need to traverse all those levels of this tree to translate the virtual address to a physical one. Obviously, this is a cost because we are accessing memory tremendously often. So when we access every time, we need to make such translation, and this is a huge overhead because it is so huge popular operation. So there are so-called translation look-aside buffers, which are just caching the recent translations, because obviously we have to memory locality, so it is good to have this memory locality. Those buffers will be then utilized. But still, if you have huge process which are accessing gigabytes of memory, for sure those buffers will be not enough, and we will have those misses of translation look-aside buffers, because we will need to translate those pages again and again and again. So to make things faster, there is this possibility on operating system level to use so-called large page. And large page is 2 megabytes in size, not 4 kilobytes, which means we will have a lot less number of translations, because obviously instead of translating every 4 kilobyte memory region, we will translate addresses for 2 megabyte regions. So this is a powerful thing. You can enable it, and then as you see, you have to enable it explicitly by the configuration knob, which is called GC large pages, and then out of the sudden the .NET runtime and the GC will start to use large pages. So we will just have reduced TLB misses and those translations. This is a very low level stuff. As you see, there are some limitations. The administrative rights have to be added to the process, because not every process can use large pages. But in general, it is a very good thing for your process. If you have huge processes, you can benefit from it. And for example, Bing is benefiting from it. Bing is a huge application with a large number of caches. So they were able to introduce 20 or almost 20% improvement in the latency, 95 percentile in fact of the latency, because they just turned on this feature and nothing else. So this is an interesting capability that you have. Another thing being added is so-called provisional mode. This is a general umbrella term for things for the GC to make some special fine tunings when a special case is detected. So probably we can expect more and more such scenarios being detected. But currently, this provisional mode is something running out of the box. We cannot enable it or disable it. It is just for fighting with scenario that we have a huge fragmentation in generation 2, and instead of trying compact the generation 2, maybe it is better for .NET runtime to make the GC once, because obviously full GC is a very huge cost, because it is a full GC. And if we have a lot of pinning in generation 2, it means that trying to compact generation 2 probably will be unproductive. Because of this pinning, we cannot move everything around. So compacting GCs, full GCs, will be unproductive, although they are quite a huge cost. And that's then the GC will go into this provisional mode. So there are a set of conditions for this mode, like we are in high memory load mode, which means over 95 or something % of the memory of the whole system is already occupied. There is a big fragmentation in generation 2. There is a lot of pinning in generation 2. And we know that doing this full compacting Gen 2 would not help. This means that GC will enter this provisioning mode, which means it will much more prefer, in fact, it will do only generation 1 GCs, trying to fill the gaps of this existing in generation 2 by the objects being promoted from generation 1. So this is a scenario that can be especially helpful in applications that you have this quite huge number of objects being promoted to generation 2. You have huge fragmentation because not everything is living there for a long time, and you have a huge number of pinned objects there. And that's because of that probably you have this fragmentation. This is very nice improvement in the GC itself. Another thing, moving for things further, is this GC large object heap threshold, because obviously I don't know how it is in the countries that our attendees now are looking at, but in Poland there is so tremendously popular interview question: what is the large object heap and what is this threshold that makes objects being allocated there? And for years it was 85,000 bytes, and it was the answer. But for other clients, that just having this threshold as a fixed value was not enough. So now we have this threshold configurable. We can make this threshold bigger. You cannot make it smaller due to the backward compatibility, but we can increase it. So now we can say that objects bigger than some x will simply be created in the large object heap, and we can increase this threshold. So very simple code. When we create a big array, it is bigger than 85,000 bytes, so we will see that it is created in generation 2, because this is the answer for the question get generation. But if we increase this threshold to a very big number, we will see that indeed this object, which is quite big, is created, allocated in generation 0. So we can move around this threshold if you have a lot of big objects that are created in large object heap, this is just kind of, let's say, specific to your application, then you can think about increasing this threshold, because creation objects in large object heap is not so beneficial. Allocations there are slower. Also, large object heap is differently handled. It is not compacted by default. So for your application, it may be beneficial to create objects there instead of creating them in large object heap. And you have to tune it, but the question to what value and whether it should be considered or not. So there is no better answer for you just to measure. So just measure it with the help, for example, of Purview or another tool. You will be able to see what objects are being allocated in large object heap. If there are many, probably you can think about some improvement. One of them could be kind of pooling those objects, for example, but another example of solution would be just using this threshold to increase the value. Another very interesting thing that I'm pretty excited about from the whole presentation, it's probably one of the my favorites one, is that we have this possibility, and I mean we will have since .NET Core 5 possibility to create pinned and uninitialized arrays. So from the very first time since .NET was introduced, we have new API for creating objects, because so far we had only the new operator. So we are newing up something and that's all, and we cannot do anything with that. And since .NET 5 we will have totally new API for creating arrays. The array that can be uninitialized or not. And this is a quite powerful capability. So as you see here, we will have this gc.allocate array or gc.allocate initialized array, which provides obviously an argument of the size of this array. And this uninitialized array is a powerful thing, because typically now, I mean not typically, always now, when we have an object being created, we have this guarantee that it will be pre-zeroed due to the safety reasons simply, and the general expectation is that the object will contain zeros, all references will be nulls, and so on and so on. So every unmanaged data will be just zero there. And this is overhead. We need to zero this memory because we expect the pre-zeroed object. And with the help of an uninitialized array API, we will be able to create an arrays that will be with some garbage inside, because they will be not pre-zeroed. This is quite significant improvement, because now GC, for example, will be able to use gaps from generation 2 instead of using pre-zeroed memory regions of generation 0, and so on and so on. And obviously this is an API for creating big arrays. We will be mostly benefiting on the big arrays, and with some safety obviously considerations, but typically we are just creating an array as a kind of buffer that will be just filled with data, so we don't care so much what was there before. And another huge possibility of it is, as you see, the pinned flag. The pinned flag is another possibility that allows you to create an object that is already pinned. Obviously, with the new operator, we didn't have such possibility. It was just creating an object. But here we have pinned flag, which means I'm creating an array and I want it to be pinned. And this allows GC to create this array on a special dedicated heap, which is called pinned object heap. So this is a kind of very new thing, because we, instead of small object heap and large object heap, now we will have also pinned object heap, and those all will be just for quite small number of objects that are dedicated to be pinned from the very beginning. And GC now can treat this region differently, which is a very big benefit for the GC performance, because it knows that it don't have to move things around those pinned object heap and so on and so on. So this is a huge benefit from the performance perspective. And because pinned objects in general are not so many, we don't expect having huge number of pinned objects, we can expect for example, we can create pinned array pool. So we can reuse arrays created in pinned object heap with the help of this API. So as you see here, when I will be creating such an array, maybe we can expect something like that will be added simply to the .NET library. We are allocating an array when we rent something from this, and we are setting this flag to be true, which means we will have a pinned object. There is a limitation of this API because of the safety reasons. The type, which is an element of this array, cannot contain references and cannot be the reference itself, because it is by design. Like now, if we are not pre-zeroing something, we would like not to have references being set to some random values, garbage values that are left after the previous objects. So this is an important API improving things. There is also an ongoing API, for example, discussion about whether we want to add an API for asking whether the particular array is pinned and or not, to make things easier. And we will see a utilization of this API probably in future. Like, for example, in case of .NET 5 code, String Builder is already using allocate initialized array, because this is like that. It is using buffers inside, and those buffers are to be filled, so we doesn't care what's inside. As we see, because of that, we can make String Builder creation twice faster, because pre-zeroing memory is typically quite a cost, especially for large object created on large object heap. Okay, so that was a very interesting API. Another set of changes is to a whole set of changes being constantly added because of container scenarios. So we have here the most important flag, because there was some issues about interpreting the limitations put on the Docker and Kubernetes on the process being hosted inside the Docker. So instead of trying to interpret all those limitations, for example, we have GC heap hard limit, and now you can say that, okay, my application should not use more than this specific hard limit being provided, which is just quite nice. A new feature, because you can just limit it and don't care what and how the limits from the operating system, from the Docker, will be set. This is one thing, and there is a lot of other changes that are just trying to be more aggressive in container scenarios, because obviously in containers we have limited amount of memory, and we would like to have a GC much more aggressive in reclaiming memory, because we don't have this margin of big number of gigabytes like we had in case of regular desktop application. So, for example, one of the things really being changed is that sometimes GC, for the very first time in its history, can compact large object heap automatically, because compacting large object heap is quite slow. For gigabytes of memory being compacted, it can take seconds. But in case of the container scenarios, when those limits are set, we prefer to be aggressive instead of waiting for out-of-memory exceptions. So compacting large object heap will be also working out of the box just like that. And so in general, .NET is really trying to achieve a lot of aggressiveness for GC in the container scenarios. Another thing is the diagnostic, because if you ever used .NET Core, especially on Linux, you probably suffered from the lack of diagnostic support. So since .NET Core 3, and we see more and more things being added on that level, we have something which is called Diagnostic Tools CLI. This is a set of tools that you can install, global tools, and we have their interesting tools that eventually can help us in diagnostic both on Windows, on Linux, on Mac OS. They are just supported. So we have, for example, counters, because maybe you know that, and maybe you miss performance counters from Windows. We have kind of replacement. We can monitor with the help of counters your application, and you will see a set of interesting counters. There are like 20 now, about the GC, about the thread pool usage, about exceptions. and we can expect having more and more added in the future. Another huge and now it is a very powerful thing. Like the feature itself is maybe not so sophisticated, but we were really well lacking support of it. So it was really hard to make easy measurement of the state of your application. And now you have this possibility with the simple command line process tool. So it is very big improvement on the field of diagnostic. Another thing is like dumping memory. So we have this possibility to make a memory dump of the process, and that's all. And it is just so hard sometimes to make it on Linux without this tool. Now you have only one command line for doing that. And moreover, and even more important, you have a dump analyze tool, which is just the looks like WinDBG, for example, with the SOS extension being loaded, but it is just there and you can use it now out of the box. So it is also a huge improvement. And even more interesting, GCDump tool, which allows you to collect some very lightweight set of information about the GC, because in general, when you make a memory dump, obviously you are dumping the whole memory of the process, which can be a huge file, which is hard to analyze. And in the end, what we typically need is just the information about the object graph, what objects are living, what objects are kept by another object, and so on. So we are interested in the object graph, not about the object data, for example, and other stuff. So GCDump is exactly that. You can make a lightweight dump of the process about only information between objects. So you can gather statistical data, open such a dump in Purview, for example, and get a quite nice overview of what's inside your process. But the resulting file here will be really small comparing to the full dump. And if you would like to automate things, you can use all those tools also, and an underlying mechanism from the C#, because recently there is a new package being added called Microsoft Diagnostic.NET Core Client. And from there, you can do things like I described. So, for example, observing counters, observing events, and so on and so on. So possibility to make diagnostic automated is also very rich at the moment. And additional API being added to .NET GC, which is because we have now quite a lack of information, deep information about the GC. If you want to have kind of self-diagnostic, for example, typically we need to monitor our own process with the help of events, and this is not a trivial thing. And there is a new API being added, which is called Get GC Memory Info, which will allow you to get very rich information about your GC and what's going on inside. So we will get such set information, like as you see, for every generation. For the very first time, in fact, with such simple API, you will be able to get information about the fragmentation before and after the recent GC, the size of the GC, the size of the generation before and after the GC, and set on informations like what kind of GC it was, what was the pauses introduced by the GCs. So a set of very nice diagnostic data that you can use for fine-tuning, or just for example, feeding kind of monitoring tool or anything else that you can then observe on dashboards. So very nice, lightweight API for getting information about the recent GC. Powerful thing. And many other improvements. I will not dig into that because they are just very deep things, trying to make more aggressive GC, fighting with latency, reducing pauses, making GC just faster for you, and you can even not, it is just out of the box working for you. If you like low-level stuff, this presentation will be provided, so you can just click those changes and dig into the changes being added. Okay, so this was about GC itself. Now we have a very short episode number 6 about the app domain, because the app domains are returning to .NET Core if you like to know and use them. In the term and under the name assembly load context, they are already added to .NET Core 3 point something. So app domains, we had something like that for years, and app domains were kind of problematic, like they were used for many things. They were used for assembly loading, isolation, obviously, for unloading things like plugins, for generating dynamic code like scripts provided by the user or so, and also for security reasons. They just be kind of promised that they provide some kind of security boundary, but in fact they were not providing. There was no runtime guarantee to have a safety and a safety between app domains. It was kind of misconception, typical and quite common one. So when the .NET Core was created, the decision was just to remove app domains, because the code handling them was quite complex and it was kind of legacy at the moment, and it was just overkill for such a simple feature, but like plugins, because typically what we need is just to load an assembly, use it, and unload it, and that's all, and this is that's we really need. And the app domains were promising too much comparing to the code that they were just by which it was implemented. So the app domains code was kind of deleted in .NET Core, and recently we have something which is a replacement for that. It is assembly load context. It is just a isolation of loaded assemblies only. There is no security guarantees. We can just load an assembly, use it, and unload it. So it is exactly what we would like to have for plugins, for example. And now this is a new thing you can use, and it doesn't promise any security boundaries, as I said, but it is just for dynamic code. So it is interesting because I see already problems with the memory leaks created by that, because unloading assembly load context is obviously a powerful thing. It is not deterministic, it is kind of cooperative. So we are saying I want to unload assembly, but we need to get rid of every reference using this assembly. If you have at least one object being still referenced from this assembly, the whole assembly will be still living in memory, obviously, because we need all the information about it. So very powerful thing, which is already and eventually added to .NET Core, that is kind of memory awareness, because it allows you to use assemblies on a dynamic basis, let's say, which is interesting thing to use. Another set of things, my second favorite during the whole talk, is episode number 6. It is a set of sophisticated just-in-time compiler improvements being added to .NET Core. We see a huge amount of work being added, and for sure will be added also in future, because there is a so huge field of improvements here. So first of all, maybe you have heard about that already or not. We have this powerful feature called tired compilation. So tired compilation is already added to .NET Core 3.0 and the upper versions, which is just the possibility to use multiple JITs inside your application. We can have, simply said, multiple tiers of JIT. So when we have a method, it can be JITed by various tiers, and typically it means that the higher tier, the better level of optimizations we have. So currently we have 2 tiers. The tier 0 is called quick JIT. It is a new kind of JIT, which is a very simple one, using minimal set optimizations, because the only goal of the quick JIT is to JIT your method as fast as possible, because we want to have fast warm-up. So we want, for example, execute Azure functions very fastly. So we really don't want to waste time on optimizing things. We don't even know whether it will be beneficial. Maybe this particular method will be called only once. So it is quite wise to quick it, to JIT it as fast as possible. And this is the job for quick JIT. And then we have tier 1, which is our normal JIT, which was used recently, so far at least. And this is the fully optimizing JIT, which is doing the whole possible optimizations, obviously. And typically here it means that every method will be quick JITted and will be promoted to tier 1 after some time. And currently it is when we call this method 30 times, and we get rid of some startup timer. So there is some time window, but in general we can say that when this method will be called enough times, it will be called frequently enough, the runtime will notice that, okay, this is an important method for you, so I will re-JIT this method to something more optimized. And we can enable it with the help of flag tired compilation. So this is a powerful thing that will allow you to make quick starts of your application and then promote the various important methods of your applications during the application is running. This is why JVM hotspot is it was doing for years. That's the name, hotspot, detecting the hot spots of your application and re-JITting them to something more sophisticated. Recently, I was even seeing a discussion discussion about making tier even faster tier, which was just using interpreter as a tier -1, let's say. So we can interpret a common intermediate language instead of even trying to JIT it as the very first tier, at least. To have such possibility, because now we have this tired compilation, we have all the infrastructure for changing a method to something different, so we can think about adding multiple tiers and the logic to switch between tiers. We can think about even more sophisticated tiers, like, I don't know, using machine learning to do some very sophisticated quantum-based optimizations on tier 2, for example. That's we have now the infrastructure for that. And regarding that, this is a huge thing. Like, we can recompile method because we detected that it is being used. But even more sophisticated thing is so-called on-stack replacement, which is a feature being .NET team is experimenting with this feature. It is not yet decided whether it will be added to .NET 5, probably as an opt-in option, not as a working out of the box. And on-stack replacement is kind of mind-blowing feature of JIT, which is able to replace the method while this method is being executed. Because the previous, in general, tired JIT obviously is JITting something, but only the next calls of this method will notice this new version. And on-stack replacement is a feature which allows you to replace a method and re-JIT it to something different while we have active stack frames of this particular method. And this is especially, imagine main method. Main method is kind of method that is called only once. So it will have no possibility to be re-JITted because it was called only once. But with this on-stack replacement, the runtime could detect that, okay, but the main method is executed quite long, it has some loops inside, let's re-JIT it to something more optimized, and let's switch in place the stack frames and everything to make this optimized version now running instead of the previous one. So this is a huge thing, as you probably see, very difficult to implement because we are just playing around with frames while the method is being executed. So we have a set of designs there being considered. Current implementation can be enabled in one of the previews of .NET 5. They are starting with something simple, let's say. It is not simple, but the simple implementation now is, for example, which you can already experiment with, is using a set of decisions what, how, and where to implement this on-stack replacement. So, for example, we have a concept of patch points. The question is on which points in a method we would like to have the possibility to switch to a different, better version, the different version of a method. And currently there is a back jump in a loop. So when we have a loop and we are jumping back in a loop, this is the point when this injection point can be currently added. When can transition happen? What is the replacement in fact? Whether we are just replacing the whole method or maybe the part of the method, because it would be also possible. A set of decisions being made regarding this feature. You can Google it. You can click this link here about this topic, which is considering all these design decisions. It is a very, very fascinating topic, and yeah, this is how things will be probably working. Maybe not .NET 5, but in .NET 6 out of the box. And this also allows us to make other things, because here now currently we are discussing only replacing on-stack replacement of a method for a more optimized one. But obviously we can de-promote a method, we can change it to any version of the method. We can also think about in future using something which is called deferred compilation. So for example, JIT will compile only parts of the method because there are some conditions, and it can guess which parts will be executed and will be just JITting these parts. And with the help of this on-stack replacement, then it will be able to more JIT those execution paths inside a method which were expected not to be called, for example. So we have huge amount of possibilities here. And interesting thing, a lot of design decisions, a lot of interesting internal things, like when we have a new stack frame created for this new version of a method, we need to leave the previous stack frame also, because we can have some data there, we can have allocs, we can have pointers to local variables, so we cannot get rid of the previous stack frame. We need to have a new stack frame and also the previous one, just because this will be needed for possibility to use pointers to local variables, for example. So a huge interesting topic. I will just a little bit describe it internally, because don't be scared a little bit of assembler. Typically when you have a method, and as you see here we have a method which has a loop, so it can be used for this on-stack replacement. And when we see what the regular tier 1 JIT is being emitting for such a case, we see a very optimized code which is doing some comparison and jumps. This is just the handling of the loop itself. This is a regular code that we see currently being generated. And this is tier 1. Tier 0 is much more or less optimized. Like as I said, it is in fact not optimizing anything, so we see the huge difference indeed in the quality of the generated code. Stack is used for everything here, and we are handling things through the stack. And but still we have here these operations related to handling of the loop, for example. So here is a code which is just checking whether the for loop has ended or not. This is the code being generated currently, but by tier 1. And when we have this on-stack replacement feature being added, we see even more code being generated because we have these patch points being injected into a method. So now this method has some additional small overhead because we have to handle these patch points. And patch points currently are just a kind of, let's say, they are handled by counter. So we are counting how many times we have hit a patch point. And similarly, like in the case of tired JIT, if we have hit the patch point enough number of times, we will consider it as a good now moment to start rejitting it and to move it to a different version while the method is still being executed. So as you see here, we have this patch pointer set, we have the patch pointer being decreased, and when we hit 0, we will start patch point helper. And patch point helper is just the whole machinery that will start to make things, saying the more general words. So This patch point helper at the very first time will request an alternative. So it simply means we will trigger, for example, in this case, we will trigger tier 1 JIT in background. And when we will hit another point, in another point in time, we will hit a patch point, and it will have a status ready, which means, okay, now when the background JIT has prepared the new version, we will make a transition. And now the whole magic happens, because out of the sudden, now our method will start to execute a new version from this particular patch point perspective. That's a huge thing. I believe it is one of the most sophisticated improvements being planned to be added in .NET Runtime since many years. Another huge thing, but comparing to the previous one is not so sophisticated, still it is very huge, is escape analysis. Something which can be opt-in in .NET 3.0. By default, probably it will be enabled in .NET 5. And escape analysis is quite simple conceptually, but obviously not so simple to implement, is detecting whether your reference type escapes a current method. So imagine you have a very simple class. We are writing a huge number of such classes with some fields, with some operations, and that's all. And then we are using this class on some point in time. So for example, in this use calculator method, I'm newing up this calculator, filling with data using this method. Obviously, this is a contrived example, a very simple one, but again, it's like 90% of our code looks like that in the end. So obviously class is a reference type. So it means that at this moment we are allocating the calculator instance on heap, which is a overhead because allocation cost is not trivial. Then since we allocated it on the heap, the GC needs to take care of it, needs to track it, needs to at least at some moment garbage collect the memory after it. But as we see here, the instance does not escape this method. Like it is just created here, used, and we forget about this instance when this method ends. This is why this is called escape analysis. And this is a huge things also in JVM world being planned to add to .NET Core Runtime, because we are just introducing unnecessary overhead here. In fact, new calculator does not need to live on heap because it does not escape this method. From perspective of this particular method, it could be just created on the stack. All its data could be created on the stack because it has this local lifetime, very limited one. So without escape analysis, we will see that JIT is indeed creating this instance. There is a call for the allocator of this calculator, and we are just using then the fields of it. But the most typical, the main concern is here that we are calling this allocator, and after some time, GC will need to reclaim memory after it. And when we have escape analysis enabled, everything is much, much faster. Like the JIT has detected that this instance does not escape this method, so we are just using it as a struct, so on the stack. And even we know struct can be even optimized not to use the stack. Maybe the values of it can be registered to the CPU registers. As we see the huge difference here, instead of making us the heap allocation, we are having just two simple lines, because indeed here we are just using some parameters being passed to the use calculator method. So a huge benefit running out of the box if you enable escape analysis for making code faster. A lot of instances used like that will be just folded into some magically will not be living on the heap. So that's a huge thing. A current implementation has a lot of limitations because obviously .NET team need to start from something, so they cannot add a super sophisticated escape analysis for everything. So for example, we have set of conditions when this may happen. For example, the escape analysis and stack allocation will be blocked if the allocation is about array, if it is a string, if the type has a GC fields, or if it is a class which is a big, so we would like not to promote such a big type on the stack, and so on and so on. So we can expect also ongoing improvements on this field in future, but this limited set of limitations is probably quite beneficial by itself, and it will be really interesting to see the performance improvements of thanks to that API. And slowly moving to the end, the last episode is about the various APIs being added for high performance in .NET, and pretty low level stuff, let's say. So for example, we have unmanaged colors only being added to .NET 5. It is an attribute, very pretty new thing, which is just an attribute that you can use on a method, and it means that this method can be directly called from native code. And then you can use, for example, take address of operator on a C# method to pass the method as a callback for your native code also. So first of all, you can expect a lot of features like DLL export, so you can compile your code and export it for a native code. This is one of the first usages of that. Another is, as you see, when you mark this method with the help of this attribute, then with the help of the new incoming thing to the C#, which is called function pointers, you will be able to take an address of this method, and this with the help with this quite strange looking for now currently pointer, which is a new syntax for pointers in C#, pointers to functions. You will be able to take an address for it and pass it as a callback to unmanaged code. So if you interrupt with an unmanaged code a lot, it will be just very nice syntax helper for doing things. And the suppress GC transition, it's in another direction. So this is when you call unmanaged code. This is a new attribute for calling unmanaged code, because when you use invoke and when you call unmanaged code, by example, you have DLL imported some API and you are calling it, there is a huge number of things being done when such method is being called. And as you see here, there is 11 points which happen when you call pay-invoke method, and the small actual pay-invoke is just in the middle. And so we have quite a lot of things being done because we are pay-invoking. One of those things which is quite overhead is switching a GC to so-called preemptive GC. So this is something that we need to do when we call pay-invoke method. And yeah, that's with the help of this attribute, we can conditionally remove this transition to the GC called preemptive mode. So when you have a method now which you are pay-invoking and importing from somewhere, you can make this attribute, you can use this attribute, and it means that during the execution of this method, we don't have this overhead of switching to the preemptive GC, which is a benefit, because if it is a simple method, it doesn't make sense to make those transitions, because it is just an overhead that is not necessary. And obviously we should be aware of that, because now if we stay in cooperative mode, because when we use this attribute, we are staying in cooperative mode, which means that GC will not happen during the execution of this method. But if it is a small method, it is fine. We are just getting rid of overhead and we are on the safe side. Very last API, because the time is running out. String builder get chunks. If you have ever used string builder, which is kind of immutable string in .NET, you are just newing it up, appending some data to it, and then in the end, the saddest method is just the string. So we need to allocate a string, which is sad because I don't like allocations. And unfortunately, currently there is no other way of utilizing data that has been filled inside string builder other than toString, which means we allocate string. So since .NET 5, we will have getChunks API, which means we can iterate through the inside buffers. So getChunks returns us read-only memory of char. So now we can utilize the data from inside string builder directly without allocations, which is a very nice feature being added and currently used. So for example, in text writer, we can see they are using this. Okay, very last minute. So if you like those topics, there is a recently added .NET 5 Runtime Epics GitHub page, which is all about improvements to the .NET runtime. Things like I've described, they are tracking there as a epics. So 1 minute left. Probably we don't have time for questions. I don't know how we handle that. That's all. Thank you all. And yeah, thank you for listening.
So, hello everyone. That was just an awesome session from Konrad. But next up we've got Layla, and Layla is going to tell us all about TDD and the Terminator. Now, Layla, the Terminator, is that the original one with Arnold Schwarzenegger?
It is. I sort of munged T1 and T2 together.
Ooh, that's cool. So he went from the bad guy in the first movie to the good guy in, well, pretty much all the other ones. I think he didn't play one of those. So is there a moral to the story, going from the bad guy to the good guy here?
Possibly. I've never thought of it that way, but that's a really good point, Maurice. I really like that. Yeah, we see him go from good to bad, and that's a requirement change.
Yeah, so, well, looking forward to your session, so take it away.
Thank you very much. Well, good morning, everybody. I hope you are enjoying your Saturday so far. I just caught the end of Konrad's session, but it looked really interesting. I was interested to see the string builder.get chunks. That's something I'm going to investigate because string builder is a bit of a pain, isn't it? So you may have noticed some eerie eyes, and those are Terminator eyes. And that is, as Maurice said, because we're talking TDD and the Terminator, and this is an introduction to test-driven development and some other things. My name is Layla Porter. I am a Microsoft MVP. I organize my local .NET meetup group. So that is in Milton Keynes, which is about 16 miles north of London. I love C#. I've tried other languages, and I really love C#, and that's my favorite. I'm also a senior developer evangelist at Twilio, which is a cloud communication platform. Now, this is probably a question that you are all asking yourself. Why TDD and the Terminator of all things? Well, to explain this, I need to take you back a few years to a few jobs ago. Excuse me. So I worked for another communications company, another cloud communications one. And I was an engineer on the platform that managed everything for carriers. They're the people who route your telephone calls through. And I worked on this platform that allowed them to manage all of their routing, which is how they route the calls. And we didn't have a test. Not one, not a single one, not a unit test, not an integration test, nothing. We relied solely on a team of 6 testers, like actual people. Only one of those did like Selenium testing, so actual programmatic testing. The rest were like using it to test it. And it was after a particular release, and we only released once, maybe twice a year if you were lucky, that we had what turned out to be 9 weeks of regression bug fixing. And I was somewhat traumatized by 9 weeks of fixing regression bugs. And I started to think to myself, there has to be a better way of doing things. So I started to look into what could be done, and I came across testing, and then when I came across testing, I came across test-driven development. And so I started to look into this, and I thought, oh, this suits my way of thinking. I really like this. So I was like, okay, I'm going to start to learn this and teach it to myself. But I didn't really know where to start. I found it really hard. I got books. They didn't work. I couldn't get it through my head. I watched YouTube videos, and it just looked like magic. The same with Pluralsight. Someone would do something and everything would go green, and I'd be like, I don't understand. I can't relate. So I just thought, I need to build an app myself, and I need something to help me relate what's going on in the code and what's going on with the tests. And I'm a massive fan of the Terminator movies, and I thought, right, I'm going to build myself a Terminator. And this isn't the original TDD and the Terminator project I wrote, but that is on my GitHub, and you can root around and find it and laugh at my ridiculous code. So let's go and have a look at TDD successes. Now, I will say that this isn't just strictly TDD. This includes unit testing and testing in general, but we're going to loosely categorize it under TDD successes. So there is that caveat in there. So I think the important thing, and needs to be number one, is acceptance criteria. And that's generally the idea that you've got all the requirements and what will be acceptable to your product owner, product manager, or your client upfront. It's very difficult to write tests if you don't know what the outcome should be. And this allows you to forge better relationships with the product owner or client. We'll just call them the product owner. Because you're saying, I can't do this. Can you go away and think about exactly what you want this to do? So they think through it better. You're happier because you have clearer requirements and you know exactly what you want to do. You get this acceptance criteria and you can write your tests. So that's a really good start. The next thing is focus. And something that a lot of developers I meet is ADHD or ADD. They're like, oh, to do this thing, I need to do this thing. And oh, look at this, I should do this backlog item too. And we all go off on tangents. And I like to say that's shaving the yak. I've got a link to what the shaving the yak means at the end of the talk. But basically, you're like, oh, to do this, I need to do this. And to do that, I need to do this thing over here. And you never actually get to do the one thing you want. So TDD gives you focus because it has one single piece of functionality that you are writing a test for. And then your bit of code must fulfill that single piece of functionality. So it keeps you very focused. You're like, I don't need to worry about all of this around here. I just need to focus on this one thing to pass the test. And for someone like me who's like, oh, I need to do this and easily distracted, this is really helpful. Interfaces. Now, I'm coming at this from an approach of working in a team that you're all working at different speeds. And what I like about interfaces and purists, purist TDD people will say, don't bring the interfaces in unless you need them. So I'm a pragmatist and I try not to be dogmatic. And you may feel that you want to be dogmatic in your test-driven development, but you don't have to be. You can be a mixture. You can be more pragmatic like I am. But what interfaces do are create a coding contract. And once you have that interface, you know exactly what your code needs to fulfill. But so does Clara, your teammate. And you can give your coding contract to your teammate and say, I've written tests for this and I'm going to fulfill it. I haven't written the code yet, but here you can use it in your code because they know exactly what you're going to produce even before you've written the code. And that leads to asynchronous development, which I think is really powerful because at various companies I've worked at, we'll look through the backlog and we'll be like, well, we can't do that story and we can't bring that into the sprint because it's dependent on these 5 other stories. And that means that you're quite restricted about the items you can bring in. When you start to get more into this frame of mind that everything is focused and you have interfaces and everything is sort of nice and isolated and you know exactly what everything's going to do, you can start to work asynchronously. And I'm not dependent on Clara finishing the entire service and all the code in it because I've got an interface. So I like that aspect of it, and I know that it's going to fulfill everything because she's written the tests, so we know it's going to work. And all of these things come to cleaner code because you're only writing enough code to fulfill a test. You're not actually going, oh, well, I'll just put this in here because I know I'm going to need that in a bit. And maybe you don't. You simply write enough code to fulfill and pass your test. So your code becomes cleaner. You don't have all the bloat that you might have if you're just coding from the brain and you get in that flow. This is the big thing that sold it to me, was safe refactoring, and that's testing in general. I was like, yes, I need tests. I need safe refactoring. I do not need 9 weeks of regression bugs in my life. So safe refactoring, because as soon as you break old code, your tests fail. So this is really like amazing to me. This is like, I needed this. So the ability to refactor code and add in new features and know for sure that you hadn't broken previous things. And of course, that then leads to fewer bugs because you instantly know when you've broken it because your tests fail. And that's a win to me. And what happens when you can safely refactor and you have fewer bugs is that you get increasing returns because there's less time spent on fixing mistakes, more time implementing features. And that's amazing to me. And the final thing that I think I'd like to mention here is it's a living documentation. We all know that documentation takes time, A, time to write, and B, it needs maintaining. That's not to say that you shouldn't do it. You absolutely should. But what tests do is give you that, this is what it is right now. If you're thinking, hang on, this is a little out of date, you can go and look at the tests and say, this is what it's meant to do. And then you should go and update your documentation. If Clara has forgotten to update it, you're like, well, I can see what she's updated in the tests, but she hasn't had time, and you could go and do it. But the tests are that living documentation, and that's really beneficial. Okay, back to the Terminator, because that's what you're all here for, isn't it? So, where do we start? What's the first thing that we want to do? Well, we're going to talk about the process, because that's what we want to start with. And that's gathering the requirements. Remember that acceptance criteria, so we need to gather the requirements. And, okay, let's see what our requirements are. There's a boy on a bike, and we're investigating him further by zooming in on his face, and we're seeing if he's John Connor. Okay. All right, that looks like a pretty good requirement for me. So let's have a look at that. We have scan subjects and determine if they require further investigation, and then investigate subjects of interest and determine if they are a target and possibly terminate. So I think we're going to look at this first one. We'll scan the subjects and determine if they require further investigation. Okay. So what next? We've got our requirements. Well, we need to start with failing tests. And this is really, really key when you do TDD. When you write tests after coding, you may be writing them to fit your code and not your requirements. Take this example. I've got an API endpoint, and I've written the code first, and I'm like, okay, this is going to return 200 in content. So now I've written that, I go and write my test, and I'm like, okay, so this, to pass my test, I need to check that it returns 200 and content. I'm like, okay, yay, my test's passed. Now it comes to the test, the launch, and everything goes, and then we realize that the requirements actually said it needed to return a 204. And you're like, oh, now my tests passed, but because I wrote them to fit my code and I didn't bother to go check the requirements, I'm not saying you wouldn't always do that, but you know, you're in the code, you're like, I'm just write a test to pass this, and oh, look, green, everything's super. But if you start with a test, the only thing you have to write your test is the requirements. So you write those requirements to fit, you write those tests to fit your requirements. And then you know that your code is going to fit the requirements as a result. So this is really key. I like to use the red-green refactor pattern. And what does that mean? Well, we write that failing test, so everything's red. And we write just enough code to get the test to pass. Now remember that, just enough code. None of that code bloat. And now everything's green. And then we refactor. Super. All right, over to code then. Let's have a look at how this is done. Okay, so I have this simple application in .NET Core, and I've already got some things in here to show you. And the first thing I have is this interface. Now, this is for a subject, and we want to have a look at subject name. And I will say that all of this is on strings, do not write your Terminator, your killer robot, based on string comparisons, okay? This is just for demonstration purposes. I just really need to put that disclaimer in. Do not write killer robots based on string comparison, okay? So we have an implementation of iSubject, and you can see here, so we have the interface, subject implements it, and we have a public string subject name. Over here, I have an interface, and this is our subject analyzer. It has one method, and that's called investigate further, and it takes a subject. And I also have a test over here. So let me zoom in a little bit. I'm using NUnit. It's my personal preference. You may prefer to use XUnit. It is more maintained, and a lot of templates come with XUnit. They're all very similar. There's also the Microsoft test framework. I just happen to like NUnit. I've used the others, and I just enjoy NUnit. So they're very similar and have similar features, but some of the decorators and way of doing things will be slightly different. So in NUnit, we have to decorate the class with test fixture. And a good way of making your test class is to say, right, I'm going to be testing the subject analyzer or an implementation of that, and then tests. So this will be a class that contains all of the tests for all of the methods within that class. Now, here I have a private iSubject analyzer, and I've called that SUT, and that stands for subject under test. And you may wonder, why haven't I just called that subject analyzer? But if I have a whole load of dependencies here, so I've brought in lots of other classes, and I'm going to instantiate those, it's really difficult to quickly read and see, oh, which is the actual class I'm running my tests on. So by calling it SUT, it's very easy to see SUT, subject under test. You don't need to keep checking what type it is. You can just write your tests against SUT. So it makes life a lot easier. Okay, so what we're going to do is use this setup. Though this is an NUnit thing. The way you set up in different frameworks is slightly different, and this is one of the reasons I like NUnit, because I can have this setup method here. Okay, so to set this up, we need to instantiate that. However, I don't have an instance of subject analyzer yet. So what we're going to do is write that now. And let me just get rid of the tests. That's Ryder being helpful. And you can see we don't have that. So we need to go and make that. I'm just going to put it in this services file over here and add a new, not directory, class. And we'll drop that in. And of course, this needs to implement iSubject analyzer. Oops. I didn't want to do that. Okay, now this is squiggly because it's saying, oh, you haven't implemented that. So we're going to implement the missing members. And you can see it's brought in that one method we had, investigate further. And it's got this line here, throw new system not implemented exception. And that's exactly what we want. We don't need to change anything at the moment. So this is perfect for starting to write our tests. Now, if we go back here, you can see this is all happy now. And we can come and write our first test. So we're going to do that, scan subjects and determine if they require further investigation. Okay, so let's have a think about this. Let's look for women. We're going to look for Sarah Connor. And we need to decorate this with test. Again, that's an NUnit thing. And this will identify this as a test that the IDE needs to run. So this is going to be public, void, and there's several ways you can name your test methods. Let me see if I can move that up for you. Let's put a few more lines in there. So we move it up. Now, I like to delineate it by 2 underscores. Some people like to delineate each word by an underscore. It's entirely up to you. Just be consistent. Now, I'm going to say Terminator should determine to, actually let's do it determine to investigate woman further. Have I got typos in there? Investigate. Nope, good. Okay. And there we go. So that's my first method. So you can see what the determinator should, and then the action, determine, and then what they're doing. Okay. So when you're writing tests, you have three things to think about: arrange, act, and assert. Okay. Let's have a look at the act first. So var result is equal to, remember that SUT, and this is why it's really easy to have it called SUT. You just always go that. And we have that investigate further method. Now we've got red squiggles here because we want to investigate further. We're looking for something here, and that happens to be a subject. So we'll put that here, and that's what we're going to arrange. So var subject is equal to a new subject, and I'll initialize that now, and that's subject name. Oops, that needs to be a capital S, is equal to woman. And we just need to bring that in and add a semicolon. Perfect. So you can see this is now happy. Now to assert if this is correct, let's just put another space there just so we can see it a little bit better. Where I like to use fluent assertions. They're very readable, but you can use the built-in assertions, have an investigation of it and see what suits you best. So for this, I want to go result dot should be true. And you can see that's quite readable. And that is my test. I spaced it out. I'd like to make it a little bit more compact. And what we're going to do is I could run it here. I could run it here. But we'll also run it from the tests. Now I'm using Rider because I'm on a Mac, but I also like ReSharper's test suite, and that's what's on Rider. But you can use Visual Studio's test suite. You can use ReSharper on Visual Studio. So what we're going to do is run tests. And there is an option to debug tests as well. If you start finding that your tests are failing and you're not sure why, you can drop breakpoints in and run them as debug and step through your code, and that can be really useful. And straight away everything is red. So remember the red-green refactor. We're really happy that all of these are red. So let's go and fix them. I'll just minimize that. Let's go over to our subject analyzer. Now this is really key. And I want you all to think about what the answer for this should be, because this was my aha moment. Let's just have a look at these side by side. I'll close this one down. I'll zoom out of this one. What do you think the least amount of code I can write in the method on the right to pass the test on the left? Just have a think about that. What do you think that is? Okay. This was my big aha moment. That. Simply return true. Let's see if that works. We can run it. And it's green. Write the least amount of code to get your test to pass. So that was like mind blown. Maybe some of you have had that, because that was the big thing for me. So let's bring that back over. Let me zoom in on that. And let's come back and have a look at this test. Let's do another test, in fact. So I'm just going to be really lazy. I'm going to copy this one. And I'm going to update this to be Terminator should determine not to investigate. And I'm going to take that woman out. And this is going to be what it shouldn't investigate further. Now we're in Terminator 1 at the moment. I'm going to flip between the movies, so just give me some artistic license here. And in movie 1, we're after Sarah Connor. And now, if I see a T1000, that's the liquid metal Terminator, I'm like, yeah, we're on the same side. They're also looking for Sarah Connor. So let's see. If I have a T1000 in my code, I don't want to investigate them further. They are not of interest to me. So we're going to run a test. Terminator should determine not to investigate further when they see a T1000. All right, let's go and run our test. You can see now our test framework has added everything down here, and we've got one passing and one failing. Perfect. You could write all your tests up front as well. I prefer to do them like this: write a test, write some code, write a test, write some code. Some people prefer to brainstorm and write all the tests. Some people actually get a tester to write all their tests. It depends how your company works. Or you may do some sort of mixture of the two. Okay, let's go back to our subject analyzer. Now, what's the least amount of code I can write to get this to pass? Okay. Oh, I don't want that little backslash. If subject name is equal to woman, let's return true. I'm just going to put that in brackets because I don't like it when you don't have it. I know I don't need them, but ugh. Okay, and there we go. Let's see if that passes. I'm going to click all these double pluses because I've changed the existing code. I want to test everything, not just the one. Yay, everything's super green. Wonderful. Let's go write another test. Now, in the video, we saw a boy, and that could be John Connor. So what I'm going to do is just collapse this method here and come back up here. So we've got this one to investigate woman. I could just copy all of this, update the name to be boy, put boy in here, and we could have a whole class full of very similar tests. But there's a good thing about testing frameworks is that they allow you to use something called a test case. So I'm just going to delete woman from here. So now this looks like the inverse of this one. Determine not to investigate further and determine to investigate further. Now if we come to this decorator here, I can call this a test case now, add in some parentheses, and I can add woman here. I can also stack them and add boy. So that's pretty cool. And then to use them, I come down here and all I need to do is add string, and let's call that subject name. And then we can just use that subject name down here like so. Now, all of these are going to be true. So let's go and see if our tests pass. So I'm just going to bring up, I've lost my test thing. Let's just scroll up here and click this one, run all. And you can see what it's done is stacked them down here. Let me move that over. And we've got the Terminator should determine to investigate further down here. And I can expand that. And you can see all the cases are listed below. So the woman one still passes. But as expected, the boy doesn't. So let's just go and update our code. This is going to be delightful. You'll love this. No smelly switches for us. We're just going to go boy. Isn't that the most lovely code you've ever seen? Don't kill me. Or don't terminate me, I should say. Let's run it. Perfect. Everything is green. Now, we are going to refactor this and get rid of those if statements, okay? So let's go back over to the slides and see how we do that and have a little bit of a more chat about this. Okay, so now we've got the basics of our Terminator. Something's happened. Oh no, I pressed the wrong button. There we go. It's time to refactor. Now, what did I say? Red, green, refactor. So let's go on and do our refactor. Now, this is the same code, only I've added in a few more delightful if statements for girl and man. So now we've got woman, girl, man, and boy. And what I've now done is made them into a switch. Yay, because that's so much better. It's not a fancy C# 8 switch. It's just a bog standard, old-fashioned switch. Not very nice, is it? But we'll come to that in a little while. Don't worry. And now our tests. We have all of those test cases stacked, as you see, and everything is the same. But we have a requirement change. Dun, dun, dun. I really feel like I need that music. And okay, let's head on over and have a look at what our requirement change is. Okay, so it looks like we're doing something with the Terminator's chip. He's repowering. Oh, look, now he can learn things. That's interesting. Okay, so alrighty. Our requirements are to protect John and Sarah Connor from threats and the ability to learn. Now, just a note on that previous scene. I'd love to know, well, if I was with all of you in a big room, I'd get you all to put your hands up and ask how many of you have actually seen that scene where the Terminator's having that chip pulled out of his head. And if you raise your hand, I know that you're an aficionado and you've watched the director's cut, because it's only in the director's cut. And a further bit of trivia is that actually the mirror image is Arnie and Linda Hamilton, but the people that we're seeing the back of is Arnie's stunt double and Linda Hamilton's sister. So there's a little bit of movie trivia for you. All right, back to TDD. Let's have a look at this code. So currently we have the that switch on the side, and this is our determined not to investigate further method. So we've got that T1000, and that's false. Everything's passing. But hang on, we're supposed to protect them, John and Sarah Connor. If we see a T1000, one of those liquid Terminators, we definitely want to investigate further because they're a threat. So now we've changed that and added that, oh, that's one of the things we want to investigate further, but our test is wrong. And now we've got an expected result to be false but found true. Now we're going to have to go and rewrite all of our tests. I don't like doing that. So you should design your application to be more robust. And when you start to write your code and you start to come across these problems, you can start to implement design patterns. Now, I'm not saying you should implement these straight from the get-go. There's a saying that goes about fool me once, shame on you, fool me twice, shame on me. And you can apply that to code refactoring. Refactor once, fine. Refactor twice, you need to start thinking about actually doing something that's going to be more long-term and more robust. So if you've ever looked at my Twitter profile, you'll know what's coming next. And that's solid principles. Now, before you all go off and have a cup of coffee or a cup of tea or go check the weather, we're not going to go deep into solid principles. That's another talk. But we are just going to skirt around them and use them to help us refactor our code to be more robust, whilst depending on our TDD and our tests. So these are the 5 principles: the single responsibility principle, the open-close principle, the Liskov substitution principle, the interface segregation principle, and the dependency inversion principle. But we're just going to focus on those top 3 for the time being. The sunny side, Sol. All right, let's have a look at these closer. So the single responsibility means every class or module in a program should have responsibility for just a single piece of that program's functionality. So remember, when we were looking at our criteria, we wanted to pluck out the single piece of functionality, write a test for that, and implement that so we keep our focus. So that's already kind of been covered. Next up, we have the open-close principle. Software entities such as classes, modules, functions, etc. should be open for extension, but closed for modification. What does that even mean? When I first looked at this, I was like, I don't understand it. How can they do that? We're going to have a look, and I'm going to give you a very rudimentary example of the open-close principle. Okay, and the final one we're looking at is the Liskov substitution principle. Objects should be replaceable with instances of their subtypes without altering the correctness of the program. So remember when we gave our interface to Clara and she could do stuff? Well, we know that we've written tests against that interface, and we can put any implementation of it, and we know that it will still work. It's still going to be correct because that coding contract is in place. Let's see it in action. We're going to refactor some code. Yay. Okay, let's go. Now I'm going to do this in slides because it's easier to explain and point to things, virtually point. Okay. Right, on the left is our test. So we're going to refactor our tests a little bit first. Now, this is what we've got, and this is what it's going to become. We're going to get rid of the 2 tests and come down to 1. And let's just have a look at what we've done. So that test case now has 2 arguments. We've now got the string woman and the bool outcome. So you can see we're passing those in, and in the properties of that method, or the arguments of that method, it's expecting them. And that subject name then gets passed into the instantiation of a new subject object, and that outcome comes into that outcome. So we've got rid of our fluent assertions, and now we're just doing result.equals, and that will either be true or false depending on the test case. So we've simplified that greatly. All right, so this is what we have, and we've refactored that code. We run our tests, and everything is still peachy. Everything is green, which is fantastic, exactly where we want it to be. Because that's a really good starting point for where we refactor, because we want to know that it was working, and what we change is what breaks it. All right, so this is our code at the moment. We've got that delightful switch on the left, and we've got our cases, that we take a subject name, and then we have our current subject and the interface iSubject. And what we're going to do is add in a new interface, and this is called iSubject rule. And we're going to add in a rule set. So this is going to kind of show you how open-close principle can work. This has 2 methods. One is an isMatch, which takes a subject, and one is of interest. Okay. Let's go and have a look at how we implement an instance of iSubject rule. Now, if I put them side by side with our switch, that's a really good way of creating your rules, because we need to create a rule for each case. So that top one, woman, we're going to create an isWoman rule. Now, if we see a woman that is of interest, we want to go and investigate further. So that of interest method needs to return true. And then we need to do a check to see if what we're looking at matches what this rule fits. So this rule fits a woman, and we'll pass that into the isMatch rule. And because this is looking for a woman, that's going to return true. If we passed a man into this method, it would go, no, I'm only looking for a woman. Skip on to the next rule. Okay, so that's how it works, and I'll show you how we can do that with a little bit of link. Now we're going to have an isDog rule, because that's going to be our default. We're not interested in investigating dogs further. They're no threat, although I'd personally go and investigate dogs further because I love dogs. But we have that rule. Now, are they of interest? No, they're not on my list there where I want to return true. And again, we've got that isMatch. So if I pass a woman in here, it's going to go, no, go find the isWoman rule. All right, so this code on the left becomes this code on the right. So I've actually got the whole class on the right and just the investigate further method, because there wasn't anything else other than the method in our original code. So don't worry, that looks like an awful lot of code, but we're going to step through it stage by stage. So let's go and have a look. Bringing up the rules beside us is going to help us understand what we're doing in the code on the right. So let's go through. The first thing we've added to our subject analyzer code is a collection or a list of iSubject rules. Now note that's a collection of the interface, and that's vital, not any particular instance of it, but the interface. I now have a constructor for my class. I didn't have that previously. And the first thing I do in my constructor is instantiate a new instance of subject rules. So we have that new list of iSubject rule, and I can totally do that even though it's an interface, okay? And now we're going to add our rules to our subject rules. And you can see because our rules fulfill the iSubject rule, this code is perfectly happy saying, yep, I'll take your dog rule, I'll take your woman rule, and add them all to my collection. So now we've got a collection of everything that fulfills the iSubject rule. So that's really lovely. And you can see that's there, and the isDog rule. Great. Now let's go and take a closer look at that investigate further method. So you remember that we just had the switch in this previously. Now the first thing is we want to go and pluck out the relevant rule for us to use. Now imagine I'm passing a woman object or a subject with a subject name of woman into my investigate further. We've just spotted a woman. It may be Sarah Connor. So what we're going to do, this could be .first, by the way. It doesn't need to be first or default because we haven't got any null checking in here. This is like a happy code path. So if there wasn't a matching rule, this would fall flat. So just bear that in mind. So we're going to use that link to go through our subject rules, and using the expression there where we have R, which is going to be a subject rule, and we're going to call the RIsMatch looking for subject. So when we hit the isWoman rule, it's going to say, yes, I'm looking for a match on woman. That returns true. That's going to be your rule. Okay. So now when we've passed woman into this bit of, into the investigate further method, we're going to get that rule back as the isWoman rule. Okay. Now, the next thing we want to do is call the investigate. Now, that happens to be a private method. And we'll come on to private methods in just a moment. So this private method is investigate, and we pass in our rule that we've just plucked out of the collection, and we're going to call that of interest. Now, when it's a woman, you can see, oh, yes, we are interested in investigating a woman further because it could be Sarah Connor. So our method returns true. So our investigate further method is going to return true as well. Cool. Now, back to private methods. If you need to make a private method public in order to test it, then it's time to refactor. So Clara's given me an interface, and I've implemented it. And I go through it and have a look. And I'm like, oh, I need this investigate method. I need to test that, don't I? Well, I'm just going to add it to Clara's interface. Well, when Clara goes to run her code, it's all going to go, you haven't implemented this interface properly. So what she's going to do, she's going to be like, I don't need that investigate method. So she's going to have stuff like this. I have seen code, even like framework code, that has come back with like 30 methods that all have throw new not implemented exception. Okay. And you're like, oh, that's code bloat. If you've got a class and at the bottom of the class it has a region and shoved in that region is a whole load of these, that is a code smell. That is not good. You should be like going, no, refactor. And this is where the interface segregation principle can come to your rescue. So this principle splits interfaces that are very large into smaller and more specific ones so that implementations will only have to know about the methods that are of interest to them. So take it that I want to, I've just had a beep. Does that mean I have a question? No. Alrighty. So we will take that, investigate that private method, and if we want to make that public and create a test for it, we're going to create its own interface. Okay, so we're going to go and create an interface for it, and then our subject analyzer class will implement both the iSubject analyzer interface and our new interface, and Clara's code won't even know about it. Okay. So let's have a look at what we've got in our tests now. So if we have a look at our public subject, oh, this has a different name. That should be an analyzer. That must be from an earlier version. So this is still our subject analyzer constructor, and we've got our collection in there. You can see now that all our tests still pass for all of our rules. When we pass in our test cases, I should say, we'll pass in dog and we pass in woman, they still return true and false, and everything passes. Because we've done this massive refactor, but we haven't regressed our code because we've got those tests. They were written ahead of time. The same could be said if they were unit tests as well. We can still do that refactor. Just the mere fact of having tests means that everything's going to go peachy. So let's have a look at how this fulfills the open-close principle. So just to remind you, that means that a class or a method or whatever it is open for extension but closed for modification. That means that I can't go and modify it. I can only extend it. So let's have a look here. I want to add more rules, but I can't go and modify my code. Now, if this was still the switch, I'd have to add in another switch case, and that would be modifying my rules. But I don't have to modify anything here. I've got a new rule, I add it. I've got another rule, I add it. I haven't modified the code. I've just extended it. Okay. Oh, look, there's a T1000 rule in there as well. With good practices, code management becomes infinitely easier. I just recently built a notification service that used this pattern. And basically the code that was doing the update, it's like, oh, I need to send an update via email, or I need to send an update via text. It's not that class's, that update function's job to do that. That should be palmed off to a service. And in that service, you may have like, if this, do that, if that, do that. But now every time you have a new notification type or a new instance or occurrence that needs a notification, you're going to add a new if-else statement in there. But by implementing a set of rules, I can just keep adding those rules. I don't have to update the tests. My notification service goes, oh, give me the rule that goes for this enum, and boom, it's done. So it's a really useful pattern. So as I said, with good practices, code management becomes infinitely easier. Let's have a look at TDD failures. Now, this isn't failures about where it goes flat. This is about you learning TDD. Underestimating the learning curve. Now, maybe you want your team to learn TDD, or you yourself are doing it. It's very easy to underestimate the learning curve. Switching to test-driven development is a massive change in the way of thinking. It's really very different. And if you just think, hey, I'm going to pick it up like that. I'll give the team a week. It's not going to happen. This is a long-term transition. Of course, there's always going to be that one person that's like, yep, got it. But a lot of people are going to have to break patterns, working patterns, and reestablish new ones. There is the confusion between TDD and unit testing. I did a Twitter poll last year, and the number of people said, oh yeah, I do TDD. I write my tests after I've written my code. And you're like, no, that's unit testing. A lot of people just confuse it, okay? And they munge it together as well. I was a real victim of that when I first started it. So I'd be like, oh, I know that I'm starting my if statement here. So if woman, return true. But I know I'm going to test the boy next. So I'm going to put if boy, return true. But I haven't written the test for that. So I've kind of left my TDD because I've gone on too far. Remember, it's just enough code to fulfill that test. Thinking TDD is enough. I joined a company that did TDD, but it didn't do unit testing, and it didn't have like UAT or user acceptance testing. It didn't have any testers. We weren't encouraged to test each other's work or anything. TDD is not enough. I'm sure you've all seen that meme where you can, one door handle works in isolation, so does the other, but you can't do them both at the same time and open the doors. So testing, unit testing is not enough. You need that integration test as well. Not starting with failing tests. That usually means that you've done something wrong because you've probably already written your code. And then not refactoring enough. That would be like taking that private method and just tacking it onto an existing interface rather than making its own implementation of the interface, okay, and screwing over Clara's code. So that would need a refactor. Obviously, don't go and refactor too much. You can get overzealous with it, but just keep making good decisions. So that final point is not actually doing TDD, which is basically any of the above. But the thing is, remember to be pragmatic and not dogmatic about it. All right, so implementation within your organization. It can be controversial, and it is a significant culture change. So basically, just be patient and talk to your team or your team members and be like, I really see the benefit of doing it like this, and slowly start to bring it in. There are going to be people who just say no and move on. When you have big changes like this within an organization, it's not going to suit everybody. So don't be surprised if people say, yeah, I'm leaving. I don't want to do this. Some people just don't change or won't change or can't change for different reasons. So if you've got a highly productive team, the initial drop in productivity can be really disconcerting. So make sure that you know, like, you are going to have a drop in productivity. Prepare everyone. Prepare the product owner. Let them all know that we're going to slow down for a little bit while we transition. We're going to have less items in the backlog in the sprint. We're going to have people pair programming. So we'll cut our output by half. But once you're in the flow, you will see that productivity will go up exponentially. I've seen it happen. Reworks are reduced. So this can be your selling point. Like, yes, we're going to have this initial drop. But once we've got into the rhythm, our productivity, reworks, new features is all going to go whoosh, because we're not going to have any or nearly as many bugs and regression bugs. You'll also get an increased understanding of requirements and their acceptance criteria. So remember that chat with the product owner. You're going to be like, yes, I've got this. I know exactly what they want. They know what they're expecting, and your relationships are better. There's less friction. So if you take one thing away from this talk, let it be this. Write the least amount of code to get your test to pass. And if you need to return true, just return true. Okay? That should be like, if you only take one thing, just try and remember that. So with that, I'd like to say a massive thank you to everyone on the team here. It's been lovely, and massive thank you to all you viewers at home tuning in on a Saturday in June. Although the weather here is torrential rain. I don't know what it's like everywhere else. If you want to follow me on Twitter, you can find me on Layla Codes It. My GitHub is Layla-P. I do have dark hair on that. Don't be like, oh, this can't possibly be her. My email, if you have any questions, you can email me at lporter@twilio.com. If you want the repo, you can go to that link. If you want the deck, that link there for TDD Deck. And I also regularly stream 2 or 3 times a week, and you can join me on Twitch at Layla Codes It. And remember that shaving the yak? If you want to know about shaving a yak, you can hit that link at the bottom there. So yeah, a massive thank you to everybody, and I really appreciate your time. So thank you.
Hi everybody, welcome back. That was a great session by Layla. Thank you very much for that. Nobody has an excuse anymore not to use TDD from now on, I think. So everybody go ahead and use it. So next up we have Niels Tanis. I met Niels the first time, I think it was in a taxi when we were from the airport going to the Prague conference a while ago.
Yeah.
And it was the first time we met, and he explained to me what he was doing, and I thought to myself, that's awesome. And I saw his session there, and I said, you know what? Everybody needs to hear this story. It's we talked a bit. It's a lot of fun, and since then, I think I've been inviting you to all the conferences I'm part of. I think so. I think everybody needs to hear this. So Niels, a friend of mine says security is a bit like spinach. I mean, most developers don't like it. We don't want to have to deal with it, but we know it's good for you. So how do you think about that?
I do love spinach. That's my answer. Like looking at security, and that's exactly what I'm going to cover in this talk, is that it's the way that applications are being developed right now and the way that hacks have changed over time resulted in the problem that I'm going to talk about today. And I think it's good to have some awareness of how are we developing our applications and what type of risk are we facing. And I think that's important. And yes, security needs to be integrated into the development lifecycle, right? It needs to be part of the thing that you're doing for the same reason that you need to do TDD, as Layla explained in the session before. And it's essential. But so stick around for the next 60 minutes. That's what I'm going to say.
Yeah, well, I agree. So I say the virtual floor is yours, and take it away.
Okay, thanks. Thanks, everyone. Welcome. Good afternoon, good morning. And we're going to wrap up and continue with the session. So I'm going to talk about, as I said, the rise of software supply chain attacks, how secure is your .NET application. A nice long title, which I heard just before the session does fit into the caption. So let's move on. First, to introduce myself, so I'm Niels Tanis. I work as a security researcher for Veracode, and I got a background in .NET development. Started out developing with the first .NET 1.0.1.1 bits, and always was interested in application security in general. So that varies from authentication, authorization, but also to more conceptual things that we're going to talk about today. Then after 12-ish years, I moved into the application security consultancy space. I mostly trained developers to do the right thing and help customers of Veracode out with fixing the problems that they had. And in 2016, I was able to join the research team, the product research team for Veracode. And in my current role, I will combine everything I've done in my past career. That means developing, hacking, and I will mostly focus on static analysis of .NET applications. So if you're into that and you want to talk about that, then come see me afterwards, like drop me a message and we can talk about Veracode. Because today we're going to talk about, as I already said, supply chain attacks in the next 45 minutes. I think if we look at the way that I started out developing myself with .NET 1.0, as I said, we always created like a monolithic application that would have every piece and bits inside of it, right? You might not even pull that amount of stuff from the internet. You might have got some code generation, data access generation. That's what I used at that point. But it was all pretty self-contained. It was all pretty simple. If we see the software that we develop nowadays, it's a lot more complex. There's a lot more moving parts from, let's say, start to end when we develop our applications, right? We need to start out writing code, then we need to have a build server that integrates all the stuff, gets all the packages it up, tests it, and then pushes it in production, which is, of course, a completely different approach than taking that MSI to that single customer and giving him the binaries and say like, hey, you need to install this on one of your servers and then you're good, right? So with that move and with that change in software development, some other security risks need to be in your, let's say, radar. You need to be aware of it, and that's exactly what I'm going to talk about. First, we're going to briefly touch some hacker history because it's fun, right? It's a Saturday. It still is sunny out here in the Netherlands, although we had a lot of rain. But it's always good to start out with some fun stuff. And I want to just quickly go through some hacks that were done in the past and then relate to software development and the stage that we're at that point. Then we're going to move to a definition of a software supply chain, and we're going to work on a .NET Core application or a .NET application generally. It's pretty agnostic. This applies on a lot, but I will define a supply chain that we're going to work on from that point, and we're going to identify security issues at the different spots in that supply chain, which of course includes development, but also building, releasing, deploying, right? That's all the thing that we do. Then in the last part of the application of this presentation, I'm not going to talk about software, but I'm going to talk about supply chains. We're going to work out a way on how to secure it. And it's good to see that a lot of companies that are, like, say, the big ones in our industry have recognized that this is a big issue and we need to do something about it. There are some tools, and I will take a .NET app and we will work through some of the supply chain things, and we're going to see how we can secure it in a better way and work on that. And then at the end, I will conclude and hopefully have some questions I can answer right away, or I will definitely see you afterwards and join the chat in order to get those questions answered. So as I said, first, let's start out with some fun stuff. Let's start out with some hacking history. And I think if you look up hackers on Wikipedia or something else, then the first thing that will probably show up in the list is that something that's called phreaking, which technically means like hacking phone systems, right? And that started out in the late 50s, 60s. The picture you see over here is something that a hacker would call a blue box, and a blue box allows him to emulate tones that were used in order to create a phone connection at those days. So this box would allow you to do free phone conversations, right? And that's how it started out. Usually in that era, there was a lot of social engineering done based on this, right? You do a phone call, you convince somebody to do something for you. And one really nice story is something about a hacker called Kingpin, who's also known as Kevin Paulson. And he took over, I think it was somewhere mid-90s, he was able to manipulate a phone system of a Los Angeles-based radio station, and there was a contest to win a Porsche, and guess who won that Porsche? It was him. He was able to manipulate this. So with all my slides, I'm referring to content that's on the internet. If you go eventually to my GitHub repo, when I put everything in, there's a slide deck that has the notes in it, and all the links to the sources that I'm talking about are in there. So you can like take your time afterwards to read it. But in those content notes, there's also a link on a video where Kevin Paulson explains how he did that, how he did pull that off. And it's a video recording of a DEF CON hacker conference in Vegas, which was a while ago, but it's really intriguing. I like to watch that. That's fun stuff, right? So this is how hacking started out. Then halfway the 90s, stuff got connected, right? So companies were putting servers towards, let's say, their servers were on infrastructures that was maybe local. They connected them to something that's called the internet, which came around that same time zone, time span, right? And in 1995, a Dutch guy called Wietse Venema and a US guy called Dan Farmer released a cool tool called Satan, which is, I think, technically speaking, the first vulnerability scanning and exploitation tool that was created. It's mostly focused on network-controlled things, so connect to a server and take it over. The second one would be Nmap, which probably you have seen, right? Which is the port scanner, which is still a lot used nowadays to check, like, hey, if I connect to this server, then what am I able to use? What ports are open? What type of services can I use? Right? That's usually how it started out. So services who mostly were contained within the organization got connected to the internet, and that's exactly what happened with hacking, right? People moved to those servers, and they probably had a lot of fun with hacking those, and so on, right? So what then happened a couple of years later is that we saw a shift more towards application layers, right? And Frack is a hacking magazine, which is still around. You can find it on the internet, and the link is in the notes. The 49th edition of that magazine, a hacker by the name of LF1 talked about something that was called smashing the stack for fun and profit, which was the first write-up of a buffer overflow, right? So code execution, a lot of possibilities. So we saw a shift towards the application layer. And a couple of editions later, in 1998, Rainforest Puppy, which nice hacker handle, also wrote for the first time about SQL injection, which was in this case related to MS SQL Server. So the dynamic SQL problem, right? If you take input, put it into a dynamic query, then people can do some other things with those queries and piggyback some additional statements that will be executed, right? So that moved to more application layer stuff, right? From network to application layer. And what happened in the early 2000s was, of course, we saw all the worms popping up, which, of course, two knowns are Code Red, that targeted IIS service, right? And the other one would have been SQL Slammer. So if you were in the Microsoft space, then you probably were encountering these. So the application layer vulnerabilities were used in a much wider fashion, and a lot more amplification, right? There's a lot more happening. So that also resulted, of course, in Bill Gates sending out the Trustworthy Computing Initiative email or note where he says, like, hey, security needs to be, as Dennis said during the beginning of this session, needs to be on top of mind, needs to be part of the way that we develop applications. And that's exactly what he tried to achieve with this. And we all know what's happened after that, right? So that's a good thing. So let's move from nice hacker stories to software architectures and a bit about the things that I've already touched when I started out the session, right? So if you look at how software has evolved, we started out developing monoliths, then we maybe did something with front-end, back-end servers that had some SOAP-based web services in the back that allows you to scale a bit more, right? It moved towards service orientation, microservices. And then, of course, right now we're seeing a lot more stuff happening with serverless cloud-native stuff, like which even is the other thing. As I said, like the monolith development is quite different than compared to, let's say, if you're doing serverless microservices and if you deploy on, let's say, a daily basis, a couple of times a day. The services are quite small and granular, right, in the case of microservices, and have a purpose. And we involved if we build those, as I already said, there's a lot more stuff that's done automatically. So we mostly have a build pipeline. So a developer checks in code, and that thing will be tested, that thing will be built, that thing will be deployed to our Kubernetes cluster, and will be available to our customers, right? And technically speaking, all those steps are supply chain steps, right? And what's a good analogy in case of supply chains? That's usually what I use. It's either food or car manufacturing. I like car manufacturing more. So I'm going to talk about that. So if we look at supply chain in relation to car manufacturing, it's the art of starting out with nothing, let's say the base of the car with no wheels, and then moving to the end product, which is the car that drives away, right? And all the steps that's done in between makes up our supply chain. But I think it was this week that I saw on television Richard Hammond talking about some factories. He's talking about big factories, and he starts out like everything is big to him, right? Because he's a small guy. But the thing that he showed was I think it was at the Volkswagen factory in Germany, and he had a Golf in front of him, like the Volkswagen Golf, fully manufactured, and that thing includes 10,000 parts from beginning to end. It includes 2,600 suppliers that will deliver those parts, right? So every supplier delivers the thing that they need, and that will make up the end product, which is the car. Technically speaking, Volkswagen relies on all those suppliers doing the right thing and delivering those parts, right? And that makes up the whole supply chain and the whole ecosystem. And if we then take this one and reflect it back, we're going to see the automotive industry later on, because they really have some good practices that we should adopt also. If we look at the supply chain thing, I think the abstracted view of the supply chain, and I'm going to talk about is this. Now, I've taken all the Azure things you can put in from developer perspective, but these are all, of course, interchangeable with, let's say, a GitHub or GitHub Actions, right? It's nothing wrong. It's more about the concept. But if we look at our supply chain that we're going to talk about today, apologies, we have a developer, right, that writes code that puts it into the source repo, which in this case is Azure Repos. The developer itself needs third-party libraries he fetches from, let's say, NPM or NuGet, right? That's the thing. Then we have build pipelines that are involved when coding is done and stuff needs to be tested, right? And then at the end, the artifacts will be probably deployed, maybe put into an Azure container registry, and then have Azure Kubernetes service support take care of that, right? So this is the whole chain, starting from writing code, supply chain, putting in code, testing it, making the end product, and then pushing it to production, right? All the steps make up our supply chain. And the thing we're going to talk about is, hey, what could possibly go wrong in this? And I can assure you it's a lot, and we're going to walk through. And we're going to first focus on the developer's machine, right? Because that's the first bit that's part of this whole chain. So let's move into that. So if you look at your machine as a whole in the physical device, you probably have a machine that includes something like secure boot and has hardware that's called a trusted platform module, right? That allows it to boot the firmware, and you have some kind of guarantee that the firmware is the firmware that's supposed to be on, that's being put there by the manufacturer, right? It's not being compromised. So yeah, that's hopefully the first thing you have in place. Second thing is that, hey, so I'm working on a Mac. I got like code on it, which of course might be code that's important to our company. So I'm definitely going to encrypt my disk, right? I need to make sure that I have hardened my system and make sure that I've installed all the updates that are available. But then if we just assume, right, and that's the leap of trust you take with the fact that you take a laptop and you just use it as a development machine. If you look at the hardware, and this is the thing that you take, but can you really trust the hardware? And I'm going to throw in some, like not fair, but throw in some stories which are really nice to watch. And I think one really good story was something that was told by Andrew Wang, also known by the name of Bunny, who talked about supply chain security from hardware manufacturing perspective. And this is a talk he did at Blue Hat Israel, which is a security conference which is held, I think, 3 times a year by Microsoft. And he talks about how chips are designed, how chips are manipulated, and quite intriguing on how explaining like, hey, what could possibly go wrong in this stage of manufacturing, or like, how would you be able to identify if the chip was modified or not, right? Because that's the end thing. And then the subtitle says, like, if this was a nation state, right? We know with Snowden revelations and stuff that has been published, this is not something that is totally not done anymore. So, but this is a nice story, and can you trust the hardware? If you're interested in seeing that, then move to this video and watch it. So let's now assume that the development machine can be trusted, right? Hopefully you got some corporate IT department that also helps out, forcing policies on your machine, making sure you install everything they need. I'm working on a Mac myself. I do a lot of .NET stuff within VS Code, and Microsoft is a bit lacking a good system to install tooling. Homebrew was created for that reason, and allows you to easily get things you need, like I need to install the OpenVPN client, or I need to install Docker. I think that's one is even available in Brew. You could just say Brew install and it will do its thing. But first, if you need to install Brew, what will happen? You need to grab a shell script from this GitHub repo and then execute that. So you take a giant leap of trust into like, hey, what's happening? And of course you can look into the details of that script and see what's happening, but a script, getting it from the internet and running it on your machine directly is a bit, you need to worry about that, right? If you look at your development machine as a whole. And you would say like, oh, this is only Mac. And of course, this is not only Mac, because on Windows, you've got Chocolately, which does similar things. And the funny fact is I looked this one up on their website yesterday, and there's this disclaimer where they exactly stated the thing that I just mentioned to you. Like, of course you can trust us, but it will be good if you check the scripts, because they also point out to a PowerShell script that installs it on your Windows machine, right? So there's a giant leap of trust you take into like, hey, I'm just pulling out these tools and I need to have it, right? But it technically has influence on the way that the machine might behave or the things that might be changed. So now we're going to move more to IDEs and move more towards the development space, right? So if you're going to start write code, and this year in May, the end of May, you see over here, GitHub security team published a malware campaign called Octopus Scanner, which was targeting the NetBeans IDE, right? Which I think you can use for doing Java development. Turned out that there was some malware that infected the IDE itself, and every package that was produced with that IDE also had a piece of malware dropped into it. Very targeted attack. Why would somebody do this, right? There's always then that bit of intriguing part of the story. Like, why would somebody put time and effort into doing this? Because logically looking at it, that's also what this same security researcher concludes. Like, why would you target an IDE if you can also target the build system, which will have a lot more impact? And that's the thing we're going to see later on. So I think there's probably a reason for doing this, right? And it happens, and I think that's important to know. Reflecting it back on the stuff that I'm doing, as I already said, I'm doing a lot with VS Code. And if you look at VS Code itself runs on Electron. And the diagram you're seeing here, you can visit that site, Bluefire.com, mpn.bluefire.com. And if you then type in Electron, you will see this graph. And there's no need for you to see all the details, but just to give you some sense, if your application uses Electron, which is VS Code and Slack, they all do the same, you rely on this whole dependency graph, because Electron is being built off from this dependencies and all the transitive ones, right? So the ones you get because you're using that other dependencies. In this case, it's 82. And it includes also 110 people who are tagged as the maintainers of this project, right? So these are the people that develop those modules, and you could ask yourself, what could possibly go wrong? And that's something I'm going to touch on an example later on, but be aware of the fact that you pull in a lot of things, right? So that's VS Code uses Electron, and VS Code itself also has a bigger code base and has some issues. And what could then go wrong with the Electron? That's something we saw in 2018. Turned out that it was able, so Electron uses Node as a lower layer, but you should not be able to communicate to Node directly. But for some reason, you were able to enable that integration again. With a lot of, let's say, not devastating, but a lot of outcomes. We saw that, you could just control it. You can start child processes, you could do process scripting, and then move to a much more wider attack, right? So it just took over VS Code, it just took over Slack by just targeting Electron. So you can see your target audience, right? And it's not MC. And if we then reflect back to VS Code, don't get me wrong, as I already said, I love VS Code. I'm using it a lot, and I really appreciate the fact how it's grown from the start, where it was, and what shape it is right now. I'm also really happy with all the extensions that are available, but last month in May, turned out that the Python extension had some issues with remote code execution, right? So because it's a bigger ecosystem, it's an IDE that is used a lot by a lot of people, it will get a lot of more attention, also from hackers, I think. And in this case, somebody disclosed it and it got fixed, right? That's the whole purpose of this, of the Microsoft, of the security bulletins and doing responsible disclosures, how they call it. But keep in mind that by using VS Code or by using .NET Rider or by using Visual Studio itself, there are a lot more dependencies you pull in, and that will have effect on your development machine, right? Because as we saw earlier with the NetBeans, stuff might be influenced in a way that you don't want it to be. So let's now assume that we can trust our development machine, the tools that we installed, the IDEs that we have in place. Now we're going to look into the things that we need. So from our development machine, we need to communicate with our repo, our source repo, and we need to talk with maybe some third-party library repositories to get stuff out of Docker Hub, out of NuGet, out of NPM, right? So for this communication, let's say it's with package management like NuGet or NPM, we rely a lot on transport layer security, right? So TLS, HTTPS, right? That's the thing, which is a system that has trees of trust, and there's root trust on certificates, right? And that's the reason why somebody can say hey, this is me, and the communication will be encrypted. Of course, we have also seen in the past that this whole system definitely has issues and still is. I would not say it's completely unsafe, but you need to be aware of stuff that's happening. Same counts for, let's say, TLS standards that have changed. And a lot of things that we've seen lately is that TLS 1.0 and 1.1, because of the Poodle and the Beast, marketed branded types of attacks, have got deprecated. And luckily, NuGet also did that. I think they started that out in April, some testing, and I think right now they pulled it through. So, because be aware that if you have TLS and if somebody is able to force you to downgrade your connection, because it's all about compatibility, right? Browsers or any HTTP client wants to stay compatible and wants you to allow to communicate to that server, you might be able, with TLS 1 and with the Poodle and Beast, it's man in the middle, and that can be an issue, right? So how much trust can you then put into that data you fetch from that repo? Same counts for another stone, a really cornerstone of the internet, which is the DNS, domain name service that we rely on a lot, right? So the fact that if you go to nuget.org, it will translate back to an IP, and that's the thing you will use in order to connect to it. Over the years, there have been some additional standards done, and one of them is called DNSSEC, which allows authorities to sign DNS records as being the owner, meaning that There's a similar type of trust system inside of it. And if I then get a response from a DNSSEC enabled website or a domain that uses it, then I can verify that that's really authentic response that I get back. Turns out that both NuGet and GitHub don't support DNSSEC, and I think that's a missed opportunity, right? So if we then look into communication, and there's a lot of trust in TLS, in the notes of this slide you will find a risk model that's been done by Qualys, and they explain like what's the risks are with TLS, and you see a large big tree. I was like doubtful to show it because it's a lot. I can even maybe talk about it for the next 40 minutes that we've got left, but that's not what we want, right? So there's a lot that we can deal with this, and at last there's a lot you need to be aware of, right? So what can happen next? A developer needs to connect to a Git or to a source repo, GitHub or Azure repos, or GitLab for that matter, and let me allow this one. Okay, cool. So, oh my, what's happening? Hold on for a second. There's nothing more fun than getting pushed updates during a presentation. That's exactly what just happened. I'm hoping that the IT department is on top of that one. So, turned out that these accounts from Canonical in this case, so that's the team behind Ubuntu, right? That's the team. Got hacked, and I think it was just a matter of stolen credentials. And at this point where this article was published, they could not, it appears to be safe, right? There's no guarantee, but they're still investigating, right? So just ordinary credential theft, that's what happened. And you would say like, hey, do more companies have that? Yeah, I think more companies suffer from that. So same thing happened, I think a month ago with Microsoft. And I'm not sure, there were not much details on what exactly happened, but I'm assuming that's just like a one account compromise that allows somebody to, or a group called the Shiny Hunters, to get 500 gigabytes of private repos from Microsoft and share it. And I think they tried to sell it on dark markets. So this was all a matter also maybe of just some simple credentials. And what's the thing that we can do with credentials and with source repo storage? Of course, we need to use multi-factor authentication, right? That would allow us to be more safe, because aside from the username and password, right, you maybe run the Google Authenticator or the Microsoft Authenticator on your phone that will produce one-time passwords that are code that rotates throughout the time. And that's an additional factor. So if somebody compromises your password and has the ability to get into your account, then still he or she also needs to have this number. And that's the additional factor that will safeguard you from getting hacked or getting access, right? And I think this is the default that should be done by everybody. So we sorted out communication, we sorted out authentication with a source repo. What could possibly be another additional thing that we can do? And of course, that's something that's called Git commit sign, which is, if you look at the Git authentication part, is an additional factor that you can put in, right? So with Git commit signing, you will generate GPG keys, public-private key pairs, that you will use to sign the commits that you're doing yourself. And I've just taken some from the .NET Roslyn repo. That allows you to sign that one with your private key, and then it can be verified, as you see over here, because the public key has been put into the account, in this case, of Jared Parson. And then it will show up as being verified. So even if somebody has access to, let's say, the code generation of that multi-factor, that OTP code, in your username and password, then the commits that the person will do won't have to verify him because he misses that, right? And it's the additional layer of defense stuff that you can do. So I think if we talk about code and we talk about development, I already said if you're developing, we mostly rely on third-party libraries, which I also do, right? Because that gives us productivity. And keep in mind that whole dependency graph you saw with Electron, the Electron slide I showed you, what could possibly go wrong in that perspective? And I think the biggest example, and I've used this in other presentations also, is something that happened with an NPM package called EventStream. That was in 2018 of November. The problem is that this thing was downloaded 2 million times a week, and it is a transitive dependency of 2,000 other libraries, and that was the key reason why. So if you pull in something from NPM, then the odds are high that it also has EventStream in the whole dependency graph. Keep in mind, so that the hack that was done was somebody that eventually joined the team and became a maintainer, got maintainer access of the repo, and then eventually decided to deploy or create a version that was malicious. So be aware that If you look at NPM and at the event stream thing, that's a supply chain on its own, right? Because the people who are developing that package aren't releasing it. That supply chain got infected by somebody who got malicious intent. But it also means that every application supply chain that uses event stream also got compromised, because that's a direct relation. They're tied to each other, right? Car manufacturer, if one of the parts that get compromised on the thing that's been put in, but that come from the supplier, then the whole car might have got problems, right? That's the end result. So this is a nice example of that. So let's move on and let's more focus on build side of things, right? So we got our code into our repo, we hopefully signed it, we're using multi-factor authentication on the stuff that we need, we hopefully have a hardened system, as already said, those kinds of things. We've got like IT pushing updates during a presentation to your machine, it happens. So let's move on, let's see what we're gonna do about builds. So I think from this narrative perspective, we can ask ourselves the same question. And it of course depends a bit on what type of build approach you're taking. If you're doing, let's say, Azure DevOps with your own agents, right, then you need to be responsible for your own build machines and there's hardware involved. Similar accounts if you run agents that are on Azure, right? You do put a lot of trust in Microsoft in delivering the right agent to you that's passed in web data. I'm confident that with the scale that they're doing it, they're pretty good at it, but it's something to be aware of, right? TLS issues are all the way, like it's a similar thing over here. And even if you're doing something with Docker, what amazed me also is that Docker Hub doesn't support multi-factor authentication. And we have seen in the past that Docker images have been compromised, right, by putting minors in it. It's not unseen. So let's say, for example, in your build system, you eventually grab a Docker image that you rely on that has been compromised, then your supply chain is compromised. And on the other fact, if you have a build server itself, it also can be compromised. It's a machine. And be aware of, like, if you look at that NetBeans story I just told, the audience that's being reached by a build server and being able to control a build package that's then distributed across a lot of people, that's quite powerful, right? One example, there was something that happened in 2015 with the Xcode compiler, and it's also named Xcode Ghost. Turned out that somebody created an Xcode compiler that also included malware on each of the applications packages that were being built, resulted in I think like 75-ish apps on the Apple Store that were infected with this malware. And how did this happen? So it turned out in Asia that internet connections might be unstable, so people put up mirrors in order to give you tooling. And somebody just created that Xcode package that looks authentic, but had this malware piece inside of the compiler thing. So each thing that was compiled with it got infected. That's it. That's what happened. That's one story, right? The other story is something that was published last year, which is related to WebWing, which is, I think it's like a web platform that's used by a lot of people. So last year at DEF CON's AppSec Village, somebody published this problem, and it turned out that for more than a year, one of the physical build servers that was used by the WebMin project was compromised. And was compromised in a way that it was a persistent thing. So every build being done on that build server got infected. And at some point, I think they pushed in some modules, additional modules that had some malware inside of it. But it was there for over a year. And that was only due to the fact that the build server was there running and was hacked for that reason. So a lot of, let's say, exposure, a lot of people got infected. And I think it's a series of, for more than a year, the downloaded versions all contain that malware. So pretty significant, right, if this happens. And something that's, I think, is a problem as a whole. And looking at that, and now we're going to move more to the solution space with approximately like 20 minutes left, so that's nice. The things that I've shown you in the solutions that I came up with, that specific area that we were talking about, are all pretty pinpoint solutions, right? So doing multi-factor authentication and GitHub, Git commits signing onto your source repo will solve the problem of the developer transition code to the Git repo. But how much of a guarantee do you have that that's the code that's also used to build the application? And maybe it's compromised, right? Same counts for multi-factor authentication. Let's say even with repos like NuGet and npm, right? Packages might still be compromised, as we saw earlier with the event stream. And then if we build our software, I think like one key thing that we really need to be aware of as an industry is something which is called reproducible or deterministic builds. And you can look up this. This is a website that has some documentation about it. And what the goal is of reproducible build is that if you take the same source code, build environments and build instructions, you need to be able to create a bit by bit identical artifact out of that compilation step. So if I go to, let's say, GitHub and I grab the last Dapr implementation, then I should be able to get that source, build it, and then maybe take the one that's on NuGet and then compare those DLLs and see if they're bit by bit. They can be compared and they're exactly the same. I can assure you that's not as easy as it sounds, and this will definitely not be the case if you do that, because there is some things that we need to be aware of in order to make sure that we have reproducible or deterministic builds that we can rely on, right? So the problem is that we want to have taken source code, and we want to make sure that we have the same output that we can produce it. Because otherwise, how can you have a guarantee that the source code that you saw of that component is really the one that ends up in the package, right? That's not justifiable. That's not how it works. Luckily, I think with whole .NET and what's the stuff that happened with Roslyn, Jared Parson has got a really nice blog post. That's a link in his notes. He explains on how with Roslyn 1.1, we started out to have some kind of determinism in the way that stuff was built. And that was based on the fact that if you give it the same inputs, and inputs is something abstract, the compiled outputs will always be deterministically the same, right? If I'm right now on my machine doing a .NET new console with a name, and I create a second one, I will move that folder and I will create a second app CS project with the same name, build two of them, compare them, they're not equal. Although it sounds so, but they are not equal. There is some things happening over there. As I said, first we need to have the inputs to be deterministic. And there's a last list inside of the GitHub repo, which is the documentation on deterministic inputs. You can also search for that. You will find it if you do Roslyn deterministic inputs. You see a whole list of stuff that a compilation relies on in order to be deterministic. And one problem it has is that if you build PDBs, right, if you do a debug build, then the PDB location itself will be inside of the PE header. So if you do two projects, same name, same code, different locations on your machine, and you build a debug and you then compare them, they're not equal. Same would count for release. It has to do with the fact that the PDB and the debugging symbols might still be in. And that's the thing you can at least circumvent. There are some ways that you can do some relative path rewriting, and that's exactly what's happening. And there's also a nice project being shared about deterministic builds by Claire Novotny. She talks about doing these types of things with SourceLink incorporated, right? So if you have a NuGet package that you deploy, if you like an open source developer and you produce those, then by doing that, then you will have deterministic compilation, and you will also have the ability to log to work in the right way with the PDBs that are generated in that separate package. A really good read if you're interested in that. So this is something that the Roslyn compiler does by default, and luckily also that has been done by .NET Core, right? So because .NET Core is based on Roslyn, still there are elements inside the PE header which have the need to become more deterministic and will be non-deterministic, and that's an MV ID, which is a GUID that identifies the PE header. And there's a PDB ID that's also a GUID, and there are some date timestamps. And with MS Build, there is a flag called /deterministic that will take care of this. And that's the default for the .NET Core. So if you sort it out, if you take a console app, same name, and if you then say, I would like to embed the PDB information, and you then do it second time, same name, different folder, and then also embed, and then you compare those two DLLs output bit by bit, they will be exactly the same, right? So yes, it's possible. Is it possible with projects that are run and that are shared by others and that are on NuGet and GitHub, like Dapr, like Serilog, like all the open source things that we rely on? That will be hard because you need to have the identical build system with the same stuff installed based on all the deterministic inputs. So yes, we need this. It's hard, and we need to be aware of it. And if something is high profile for you, and if you rely on a source repository, then I think it would definitely be good to invest some time in this if you want to make sure that that's the right thing and that's the right GLL that you put into your project. So we talked about deterministic builds. We talked about some of the pinpointing problems that we saw earlier. Now let's move back to the automotive space, and let's move into like how can we do a better job, right? I think This is a picture which, if people are reading automotive magazines, then I think the one in the Netherlands had like articles where they take apart a car fully after it has ridden 100,000 kilometers, and then they put every part out, which you see, okay, this is the car, and this is the wear and tear, this is the stuff that went wrong during its life cycle, and that's the thing that that we see over here. What amazes me and what I find really intriguing is that you probably have, if you drive a relatively new car, then at some point manufacturers might reach out to you saying, hey, you've got a problem. Turns out that part X that was in your car has some issues, and we want to do a replacement, right? Everybody probably has those kinds of recalls. And that's I think that's a good thing. So for some reason, if a car manufacturer is being built, then they have the ability to keep track of what's inside your car. And I think that's a knowledge we need to dig more into a bit by taking a look at one other example that I created, just to illustrate how the automotive industry deals with this. So if we need a car that has brakes on it, then we need to have brakes being produced by a supplier, which was also done. It's also done by Bosch. And we need to have a steel factory that delivers the steel, right? In this case, Tata Steel. That's one that's based in the Netherlands. That factory needs to have iron ore that comes from an origin, right? I come from Sweden. That iron ore needs to be tested, and it needs to meet the expectations, right? It needs to meet the quality grades that they need in order to make brakes out of it. So if that's being created by Tata, then it has a batch number that will be pushed to the Bosch factory in order to produce brake discs out of. So they will identify, like, hey, we use this batch from Tata to produce those brakes. We have also fully tested it according to our standards, which is, I looked that one up. The ECE R90 is really a standard that's related to brakes. We will give it a serial number, that's it. And then we know that these will be distributed by Ford, Volkswagen, and Kia into using their cars. And at the end, if we then take a look at Ford manufacturing, they will have those discs. They will take the other supply parts, like the 2600, as I talked about with the Volkswagen Golf, and they will put it in, right? And it includes the disc with that serial number. There's an exhaust that has a serial number. We put on these tires, and that will make up the car that's identified by this vehicle identification number, right? So from beginning to end, if something went wrong with the steel that was produced by the iron ore, then there is a way to correlate back to say, like, hey, so we have the problems with this series of brakes that were being put into those cars. So we need to recall, and we need to make sure that the people get those fixed because it's a hazard. And I think from software perspective and the way that we saw supply chains and how that smashes over, like it's being smudged over everything that we do, I think we need to have a similar thing. And as I said, so big manufacturers like Google and Microsoft are really seeing the importance of this. If you go to the last RSA conference that was held in February, you see Mark Rusinovich talk about supply chain attacks and open source, which is a really good talk if you're interested in seeing more of this. But he also touches the concept of something called a software bill of materials, or an SBOM, and a policy in the way that you can enforce it, right? So it's an industry standard that describes software, right? It does similar things to what we saw with the car, because we need to have a producer identity. We need to have what's inside the product. We need to make sure that it's unaltered. We need to make sure, like, in what type of license it have, right? But can we use it in our project? How was it created? How is it tested? Does it meet all my expectations? And then what was used, as I saw earlier about the reproducible builds, like what source code was used to build that artifact. So out of the OWASP dependency project, something called Cyclone DX has created, which is a lightweight software bill of materials that you could start using right away. So it has the ability to produce a full dependency graph of your whole project, and it does it for a lot of technologies, .NET, Java. I think there's a lot. If you go to their website, you will see it, but you will see again a whole tree of dependencies you can produce it. And if you do that with each of your deployments that you do and releases, then you got like that piece of paper you look into, like, hey, that package was compromised or had some issues, and I know that it's inside of this version of my app, so I need to fix those, right? That could be the first step. Still, it's quite a pinpointy solution because it's just that single moment in time. And is there a better way? And I think there is. So a university in New York and New Jersey combined have something called Security Lab, and they started out creating a tool called In Toto. And Intodo is a framework to secure integrity of software supply chains, right? So it's not focusing on the single spot fixes we saw earlier. No, it looks as the looks at the whole process and then defines like what you need to do. And Intodo, I think, has got a lot of potential. It still is academia to a certain degree. The tooling has some glitches, and I was just talking just before the session, like my demos broke this morning. They should be working. I just need to retry it a couple of times. That's what I said. But the concept, hopefully I'm able to show you the concept on how this works, because I think this is powerful. This is a powerful tool, and it would be really good to see how it works. So let's move to the demo space. This is the only demo I have. So I think for Intodo, we need to be aware of a couple of terminologies before I move on. First, you have functionaries. And functionaries have a public-private key pair, because we're going to sign stuff on artifacts that we produce. We've got a product owner, that's me. I'm going to be like walking you through and showing you stuff that's happening. Then we've got a developer by the name of May, and we've got now who's responsible for publishing and packaging the app itself. So what I'm going to do as a product owner, I'm going to define a supply chain layout that describes what will happen, by who, and what are the materials and byproducts of that step. Then we're going to produce something called link metadata, which we will see later on. It's all going to be console driven, but hopefully you get some sense of what's happening. But it will be metadata that's output of each of the steps. And if we look at the steps, we can have materials that are input. Products are output of a step, but it can also be used as materials of the other step. And I think that's the quite powerful thing. So let's say a developer checks in source code, has a specific signature, it will just check hashes, and that hashes can then be used later on to check out if that was really like used in the build server, right? There's a lot of power in doing that. And then at the end, we're able to verify and do verification as the product owner. So each step will have a signing key, private key that can be checked by just looking at this public thing. And me, myself, as a product owner, I will also sign the supply chain, because that's my responsibility, right? So that's the terminology. Let's go to the demo and see if the demo guards are still good with us. So I've got several folders. So this is a tool that runs on Python. My Mac was really having a hard problem with all the Python environments. So I'm using a dev container. All this source code you see over here, including the scripts, is inside of my GitHub repo that will be in the last slide. I've got the scripts that are there, and I've also added the dev container instance that I'm doing, because I'm installing some additional things. So you should be able to do exactly the same, because this is just running a Linux and Ubuntu image on my Mac right now, and with all the goodness of having VS Code as my main driver. So that's cool. So first, we need to start out as the owner, and we're going to create a layout. And that layout is something, I don't want to install any extensions, especially not the Python one. So we're going to define a layout, and this is just a script that I've stolen from their demo, but I've adapted it to the scenario that I want to talk about. But we need to walk through a bit to see hey, so I've got my private key pair because I'm the owner, and I need to have the one that's related to MA, and now there are the other functionaries in this whole supply chain. The first step, what will happen is something will be created, and it's just going to be an ordinary .NET new console. That's what will be done by MA, and MA is the only one, because keep in mind that each of the steps are tied to functionaries. So I force only developers to do this. In this case, MA is my developer, and she will do that. I will have expected materials, as I already said, like a C# file. And then the next step would be a publish. That's done by Niels, who will look into. He will have some expected commands. So Intodo, I'm using Intodo run, but Intodo also has the ability to just start monitoring. So if you have a series of things that are happening, then Intodo will produce the artifacts of those steps, and we'll have the cryptographic result of that, right? Same counts for them packaging, right? There's a thing happening. And then at the end, there is some inspection that we're going to do. And we're going to, eventually there's a gzip tart created, and we're going to extract those and see if those artifacts match the ones that came from publish. And then we're going to, of course, do some fiddling around with some source code to see how that behaves. So first, I'm going to do a series of scripts. So bear with me for a couple of seconds. I'm going to move to a terminal. I'm going to maximize that. First, we need to generate the layout. That's the script you saw earlier, right? So I have the owner Niels, and I have there's a Python script that I'm going to execute right now, which is create layouts. and that will produce a layout file. And if we see in my folder, then this is the file. It's similar to what we saw before, only it has written out and it has replaced the key information with the keys that are being fetched from the files, right? So nothing fancy. We need to have my public key and the other one. We need to make sure that we put it into the final product folder. I'm going to use that later on. So this is the first step. I created the layout. This is the layout of the supply chain that I'm trying to follow. Don't do this again. Thanks. Okay. So now we're going to move to functionary MA. And so MA, she's the developer, right? So functionary MA. Move on. Yes. So she will just do a .NET new, but you can probably imagine that this is also a git clone or something else, or maybe a developer is going to tag a release once it's done. And this might be a command that I need to execute twice. Yes, this is the one. Let's just hope for the best. Third time is a savior. As I said, these are still like, let me just quickly reopen the terminal. So what it does in total, it does some rewriting of the in and outputs, and I think it's having a hard time with the virtual machine right now. So let's try it once more. So we're going to do the create, right, which internally just does the in total run, and it will say I'm going to run a .NET new. Geez, come on. Let me try one more thing. Let me help him a bit. So .NET new console and app. Let's try it once more. This is not. So let me quickly show you the next step that's done by now. So unfortunately, I don't think we can check the real thing that I was planning on showing you. But now we're going to move the source to Node, who probably gets that from the source repo, right? And let me just do one of his actions to show you like what's happening, because there's an artifact created. So unfortunately, I think we don't get to verify it. But let's see. Oh, please. I don't think the demo glots plugin has worked, Edwin. Sorry. So once more, functionary nodes, because I just want to have one of the artifacts produced so I can show you that, because that also is illustrative for the things that's happening. Publish sh8, that's the one I want to execute. And now it did work, so this is cool. So let me quickly just be stubborn. Go to MA once more, and then say create. Running it twice. Trust me, I've seen it work. No, okay. So let's move back to the functionality now. So I'm gonna probably write out a blog post on this also, just to show you what's happening, right? But one of the steps, once it's executed, will produce this file. And this file, let me expand it a bit, explains exactly, so we've got some signatures. This is Now that has signed the package. He shows that he has done this command, right, that executes. He has taken some materials which were initially from the developer, right? And that's a SHARS 265 fingerprint of that file. And then he has published that app, and it has like the DLLs, the PDBs, and some config files, which also have the hashes. Right? So if we then make up the whole chain, everybody does their own signing, then we will have those artifacts. And those artifacts can be verified against the layout I just created. And if there is a tempering then done, let's say at some point Now decides to do some adjustments on the code, because he can do that, then the whole supply chain integrity will fail, because it will recognize that the programs he has used to publish is not similar to the one that was put in by MA as a developer, because that one was signed, right? So that gives you some guarantee, and that gives you some concepts of what's happening here. So unfortunately, it didn't work. And we're also a little bit running out of time. As I said, I'm going to write the blog post. So let me wrap up. So if you're interested in Toto and how it works, Datadog is a company that has embraced it and that uses it for their agents. And there's a good blog post on how they explain how they used it. Google has taken it seriously by taking Grapheus and Credas, which is two components that are in the Google Cloud Platform that can do a gathering of those SBOMs by component metadata API called Grapheus, and Credas that allows you to do policy checks in order to, before you do to development. So let's say that example we saw earlier, if you want to push to production and push your application to your Kubernetes cluster, then you want to check those artifacts, right? And that's exactly what Credas does already on Google Cloud Platform. Pretty powerful. And within Azure, we've got the Azure Pipelines artifact policy, which has got the potential of doing the same. Right now, it can just check things for you, but it's not anything more than that. So it can be extended to do stuff like Intoto does, right? So quickly recap, and then I'm going to wrap up. So I think it's important to be aware of everything that's happened in your supply chain. Make sure you pull in, that you know what you pull in. Use MFA on all the accounts, right? Integrate security into your life cycle and start considering using something like software bill of materials. So I will be around to answer questions. Go to this GitHub repo if you're interested, and keep an eye on my blog because I'm going to post that demo. It's going to work, I know. So thanks everyone for your time and enjoy the rest of the session.
Okay, welcome back, everybody. Well, Niels, thanks very much for the great presentation. First scaring us with all the things which could happen, and then giving us gladly some pointers on how to prevent this. So we go off to the next session. Steve, we met from at the last .NET Core summer event. So very nice to have you back here. Of course, not in person, so as the last event. So you are now one of the people who can very testify there's actually live in Veenendaal. So that's great to have you here. For all the viewers, Steve is a .NET developer, expert on MVP and expert on .NET and .NET Core and ASP.NET in particular. Overall nice guy, very enthusiastic about community events, but not to put too much pressure on Steve, he was also the best rated session last year.
Oh,
so,
okay.
I'm not saying anything, but actually we are very, very looking forward to this session. Steve?
I'll try my best.
Take it away.
Thanks very much, Thomas. Okay, well, thank you everyone for joining us. I know it's a Saturday. It's great that people are taking time to kind of attend these events in their own time, and I really do appreciate sort of every minute that people give for those events. So as Thomas mentioned, I'm Microsoft MVP, Pluralsight author, and .NET developer. I spend my day developing microservices and sort of APIs, things like that. You can find me online. I'm at Steve J. Gordon on Twitter, and I blog reasonably regularly, a little bit less at the moment, but at stevejgordon.co.uk. So hopefully some posts will follow this talk at some point that will sort of dive into some of the things that I'm going to talk about. I do want to highlight, I've got a link here. This is the link to the resources. So bit.ly/ASP.NET Anatomy. That will take you to a copy of these slides, a download link for the sample code, and a few other sort of references and things that might be useful if you want to kind of study this in your own time afterwards. So why have I chosen to talk about the anatomy of ASP.NET Core requests today? So generally, when we use ASP.NET Core, most people will be familiar with actions and controllers and sort of the MVC pattern. And so it's very easy to add a controller, add an action method to your application, and things pretty much just work. We don't have to think too much about how that request is actually going to get sort of sent to that action method and how ASP.NET Core is actually going to process it. But sometimes it's useful to know a little bit about what's going on in the layers below us. So in this session, what I'm hoping to do is explain how ASP.NET Core actually handles a request end to end, and also explain some of the places where you can sort of provide your own features and your own kind of cross-cutting concerns for your applications in ASP.NET Core applications today. So we're going to start with a client that wants to make a HTTP request. So a client in this case could be a human user visiting a website on a browser, or in this case, we're going to pretend that we've got an API on my blog /API/blog/books. And in that case, you're probably going to be having sort of programmatic clients reaching out to you and making requests to you. So the client wants to make a request to us. The client is going to first need to connect to us. And we're using HTTP, which is the kind of application layer protocol. But underneath that, we need a transport protocol, and that's where TCP comes in. So the client is first going to establish a TCP connection with the web server. So the client's going to grab one of the spare ephemeral ports on the client machine, and it's going to use that for its outbound connection. And it's going to make that connection to the IP address of the web server, which is resolved through DNS. And then that will typically be on either port 80 or 443. We'll assume 443 because most things should go over secure HTTPS communication these days. And so we need to establish that connection. So the client and server will do a little handshake. The client says, "Are you there?" The server says, "Yes, I am." And then connection can complete. Now, because we're using sort of HTTPS for this communication, we need another layer between the TCP layer and HTTP that's going to handle the secure part of the connection. And that's where TLS comes in. So we won't dive into this in huge depth, but fundamentally, again, it's another handshaking process where the client is going to basically get a certificate from the server to prove who it is. The client server then can determine how they're going to actually encrypt the traffic and do exchange of keys, things like that. So at this point, the client has now established a connection to the to the web server. So the next thing we need to do is send a HTTP request. And so HTTP is a very simple protocol at its heart. If you haven't ever read the RFCs for HTTP, I do recommend you have a look. They're not hugely exciting, but if you're doing anything in sort of the web area, if you're building web applications and APIs, having a bit of a fundamental understanding about how the protocols were designed can be useful, and can help you sort of really understand how to sort of be a good citizen with your applications. So at its heart, HTTP request message here is just a bit of ASCII text. So the first line is the request line, and this is saying to the server, okay, I want to get a resource. So we can send different HTTP methods. Here we're using get, but you may also see put, post, patch, delete, for example. The next part is the resource. So that's /API/books. And then we're using protocol version HTTP 1.1. We can then send some headers with this request, and these are basically just key value pairs. So the first header is a very common one that should be included on your requests, and this is the host that you want to actually communicate with. Because we're connecting to an IP address, that web server may be dealing with handling multiple logical websites at different domain names. And so sending the host header will allow that web server to route it to the appropriate virtual server that it's running. Some other common headers you may see, things like the accept header here to say that we would prefer application JSON as the responses from the server, but we can take plain text. We could take pretty much anything you give us as a backup. The language that we would prefer, we can also say what encodings we can accept. So can the server compress the content it's sending to us? And then we include a user agent, which is a really important thing to do, particularly if you're building microservices. I find this is really useful to be a good citizen and identify your service. So if you're doing programmatic calls over HTTP client, send a user agent, and then the downstream service knows which version of your application is connecting. And the request message is concluded with a blank line. So the client will take these bytes, or take this text, convert it over to bytes, and fire it over to the web server. The web server in ASP.NET Core is Kestrel. This was introduced with ASP.NET Core 1.0 as a brand new kind of web server. And one of the fundamental differences with ASP.NET Core is because Kestrel is built as part of ASP.NET Core, it runs in the same process as your application. So fundamentally, ASP.NET Core applications are just console applications. On top of those, you'll start the host, which is the thing that basically keeps your application process alive until it's signaled to shut down by the operating system. And then that host can start up a web server, which is anything that conforms to an iServer interface. So you could potentially plug in your own server if you wanted to. So Kestrel is a highly performant implementation of a web server. In the early days, you weren't expected to expose it directly to the internet. So you typically expose it behind a reverse proxy. But today, Kestrel is web hardened. And so if you want to run it at the edge, you can do, although it's still very common to put it behind some kind of load balancer or reverse proxy, or even sort of behind IIS if you prefer. So this is what this request process looks like at a very high level, and we'll start to kind of get closer to this as we go through. So the client has connected over the internet, and Kestrel has accepted that connection. As part of connection, there is this piece inside Kestrel known as connection middleware. So if you've used middleware in ASP.NET Core itself, this is a very similar concept, but it's around connection handling. So how does Kestrel actually take that connection and the incoming requests and process them? And if you want to do anything really low level at the connection sort of end of Kestrel processing, you can actually write your own connection middleware and plug it in to Kestrel, and then it will use it at runtime. We won't talk about that today. It's very low level. I've never needed to do it. But after the connection middleware and after the request comes in, ASP.NET Core will handle the request. It will generate a response, and the response flows back to the client. So if we zoom in a little closer, we'll see that what actually happens once Kestrel receives that request. So Kestrel's job is fundamentally to parse HTML. So it's getting raw bytes over the network connection, and it needs to convert those bytes to a valid HTTP message to make sure that the client has sent us something that we can actually process. So Kestrel's job is parsing that response, and what it will produce as an output is an instance of a HTTP context. And the HTTP context is basically just the contract between Kestrel and the rest of ASP.NET Core, your application code. So you'll probably have worked with the HTTP context at some level before. It's really just a sort of strongly typed representation of the request as it flows through the system. So we'll get the request itself is attached to the context. The context can carry other information as it flows through the application. So there's a items collection, which is basically just a sort of a bag that we can throw key value pairs into. And there's also this concept of an iFeatures collection, which if you want to do anything with the context and apply it as a feature as you've processed the request through, you can attach it, and then further downstream components and ASP.NET Core can potentially look for that feature and grab some additional data from it. So that is one of the first places that you can potentially plug in behaviors at a very high level. So the application code will attach the response to the HTTP context and pass it back to Kestrel, and then Kestrel can convert that to the bytes that go over the wire. So we'll dive in even closer. So after we've got that HTTP context, the very first piece of ASP.NET Core that will kind of interact with it once Kestrel hands it off is middleware. Middleware is this concept of a series of components, and each of those components is responsible for processing the requests. So we write our middleware components, we apply them in a particular order. So we define them in a given order, and they will always run in that order as a request comes through. And each piece of middleware has a few options. It can pass the request on to the next piece of middleware without doing anything further. So maybe it's not interested in necessarily doing anything with the response at that point, the request at that point, sorry. It can just hand it on to the next middleware. If it wants to, it could inspect the request, and it could maybe attach something to the HTTP context. So maybe it parses out some headers and adds them to the items collection, or maybe it sort of transforms some of those headers into some other values, and then hand it on after modifying the request. And the final thing that middleware can do is short circuit pipelines. So it can take the request that it's seen and say, I can generate a response for this. It will generate the response and then actually not pass it on to the next piece of middleware in the pipeline. So this middleware runs in the order that you define in a consistent way. At some point, something's going to handle the request. And in general cases, that's going to be what's known as an endpoint. And you can think of this really as the MVC component of ASP.NET Core. So that's going to get the request, do what it needs to do to process it, and then generate a response. That response will flow back through that middleware pipeline, but this time in reverse order. So this gives every piece of middleware the opportunity to also inspect the response and potentially modify some of the data on that response, or maybe add some additional information, maybe do some kind of cross-cutting concern like logging or monitoring, sending metrics somewhere, and then it will just pass it back up the chain. Eventually, that HTTP context returns back to Kestrel, and as I say, then Kestrel can return the response to the client. So this is how we define the application pipeline. This is how we set up our middleware pipeline in an ASP.NET Core application. You'll probably have seen this before. This is part of the startup class. It's part of the default template if you create a file new ASP.NET Core project, and it's the configure method. So this method gets run by the application when the application is starting up to define the processing pipeline that's going to be used while that application is running. And we get access to the iApplication Builder, and this is the component that we use to register middleware into the pipeline. So for a first example here, we can see that we're calling app.useDeveloperExceptionPage. And what this piece of middleware does is it attaches middleware that will look at the response as it goes back at. And if there's been an exception that's not been handled by the framework as part of processing that request, it will take that and transform the data into a user-friendly stack trace representation that can go back out on the response. Now, obviously, that's something that's great for development, not so good for production. You don't want to be leaking those details in production. So as you can see here in the default template, this is conditionally registered. So when your application starts, it works out which environment it's running under. It assumes to be production by default, but when you're developing, you're typically set to development. And so in this case, we can say if the environment is development, then we register this helper middleware. Otherwise, it won't be part of the pipeline when this application goes to production. So this is one of the ways that we can register middleware conditionally. Another thing that we could do here is actually access the I configuration for our application and conditionally choose to register middleware based on values set there. So maybe you've got a feature flag of some kind that turns on or turns off one of your pieces of middleware. The next piece of middleware, use HTTPS redirection. This is a piece of middleware that is a good example of short-circuiting the pipeline. So in general use, if it receives a request where the scheme is HTTPS, then it will just pass it on to the next middleware in the pipeline, and that's all it does. But if a request comes in that's only got the scheme HTTP, and this application says, no, we have to have HTTPS communication going on here, then it will check that scheme and say, no, I'm going to issue a redirect. So it will short circuit the pipeline. It won't pass it on to the rest of the middleware, and it will return a redirect response to the client so that they know that they should connect under the HTTPS scheme. We'll look at some of the rest of these in a few moments, but let's just visualize what this pipeline looks like. So on the left, the request has come in. It flows through that middleware in the order that it's been registered. Some point, endpoint is going to handle the request. Now, one interesting thing about this diagram, if you're sort of looking at it quite closely, you'll spot there's a couple of pieces of middleware here that aren't in that configure method. So where have these come from? ASP.NET Core includes another feature that's rarely used and is mostly there for the framework itself called iStartupFilter. And by defining something that conforms to the iStartupFilter interface, we have the opportunity to inject middleware into the application pipeline right at the beginning. So it doesn't give us control of where it applies directly. It's just going to be at the start of the pipeline. And so ASP.NET Core uses this for a couple of pieces of middleware that it wants to enforce running first. So we don't want these ever to be removed by someone who might be modifying that configure method. So the first one here, for example, is post-filtering middleware. And this is responsible for ensuring that if the client has set up their application so that they only respond to certain host names, which is a good practice if you're publishing to production, they'll use the appsettings.json file to define the host names that they want to respond for. And then the host filtering middleware will check that the host name on the request actually matches what's being configured in the appsettings.json. And if it doesn't, it can reject the request without passing it on to the rest of the pipeline. The forwarded headers middleware is responsible for taking any headers that might have come from something such as a reverse proxy that might have run before our application and transform those into headers that ASP.NET Core can then interpret later on. And apologies, my neighbor has decided to start this moment to start drilling something very loudly outside, so I hope that doesn't pick up too much. So these two pieces of middleware are injected through that iStartupFilter mechanism. And if you do have a requirement that should run very early in a request or very late in the response, you could use that mechanism. But as a general rule, I wouldn't recommend it because it doesn't give the consumer of that middleware any opportunity to decide that it should run before or after something they may have added of their own. So once the endpoint has handled the request, as I say, the response is generated and then it flows back through that middleware pipeline in reverse order. And each piece of middleware in that pipeline has the opportunity to inspect that response and potentially take some kind of action. So if we want to write our own middleware for an application, we can do that in the configure method. So here we're doing this inline. This is an inline registration of middleware where we just use the .use method, and then we can provide a delegate that represents our piece of middleware. And that's an asynchronous method that has a context, which is the HTTP context, and then next, which is the next request delegate. So the next piece of middleware that's going to run after it. So in this case, we're going to do a very basic kind of timing middleware. And what we're going to do is, as soon as we get the request, we're going to start stopwatch. We'll pass the request on to the next piece of middleware in that pipeline. That will flow through the pipeline. Something will generate a response. The response will flow back through the pipeline to us. And when we get that response, we stop the stopwatch. And then what we can do is, for example, here we're using a service in our application, an iMetric recorder, to record a basic stat about what response status code went out and how long it took. Now, one downside of this approach is that we're using the sort of service locator pattern here. So if I just drop down to this line of code here, you can see we've had to grab the request services off of the HTTP context, and then we've had to call get required service to get the service that we want. I don't really like that mechanism in code. It's a bit sort of mucky. So what we can do instead is write this middleware class. And this is a very simple class that we're going to use here just to take the code that we've just written, but move it into its own class. And this doesn't require an interface or anything particularly complex. It does have a few things that you must do. So it's kind of duck typed and it expects those things to be present. So the first thing is that it expects your constructor to accept a request delegate, which is the representation of the next middleware in the pipeline. And then you can inject any other services that you want to. So we're injecting our iMetric recorder here. We must then have an invoke async method. This accepts the HTTP context. And then the code here is fundamentally what we've just looked at. Start the stopwatch, pass the request on, and then stop it once we get the response back, logging our metric to the metric recorder. To register that then, we can use app.useMiddleware, where it takes the type of our middleware class. So you can see that this is a lot cleaner than writing inline middleware. For very simple requirements, inline middleware is usually fine. But if you want to kind of keep your code clean and clear, I recommend moving your middleware out into its own classes. And that's a great way also to move it into a library if you need to share that with other applications. So the next thing I want to touch on is endpoint routing. And we could spend probably 50 minutes talking about endpoint routing. So I'll give you the highlights. Endpoint routing was introduced in ASP.NET Core 2.2. It wasn't enabled by default, but it was there if you wanted to use it. And then since 3.0, endpoint routing has been part of the framework, and it's part of how ASP.NET Core works by default. So before endpoint routing was introduced, the way routing worked in an application was ASP.NET Core got the request, passed it through the middleware pipeline, and eventually passed it onto a special piece of middleware that invoked MVC. And inside MVC, MVC would work out the routing for that request. So basically which controller and which action that request should map to. Now, because that was done inside MVC, it means that only MVC had knowledge of what the final endpoint was that was going to handle the request. And so this means things like authorization, for example, have to take place inside MVC, because only that is aware of what action method is going to get called, and therefore which of those action methods maybe have the authorizer attribute applied to them. What the team realized is that's a bit of a pain, and it means that you're a bit limited in what you can do using middleware. So they've elevated routing up to its own feature called endpoint routing, which now lives outside of MVC, and it gives us some more power in our applications. So we can see where this is used in the configure method. We have two pieces of middleware for endpoint routing to work. Use routing is responsible for looking at the request that's coming in and looking at, say, the method of that request and the URL path, and determining which endpoint is going to map to. So which endpoint should handle it. So it has a routing table that it uses to look that up and figure out which endpoint is going to finally handle the request. Then it attaches that metadata to the HTTP context. Later, we call use endpoints, and this is where the endpoint itself is actually invoked. So this is where the framework says, okay, I know what endpoint to call, I'm going to now call it. The other confusing thing about this, though, is you can see that we've got this Lambda expression here inside use endpoints. And what this does is map the endpoints. So it looks a little bit out of order. Logically, we know that this must have run first because this needs to map the endpoints to the routing table when the application starts up. And indeed it does. But the team designed it this way just because it was the most sort of clear overall way to set up this code pattern. So inside endpoints, in this example, we've just mapped the controllers, which then means that ASP.NET Core will scan the framework, look for all instances of a controller, find all of the action methods, and then work out how they would map to requests coming in. So which HTTP verbs, for example, and which paths should route to them. So these two pieces of middleware work together to make endpoint routing work. What this means is that between these two pieces of middleware, we're in what's called the routing zone. This is an area of the application where anything between use routing and use endpoints is what we call endpoint aware. And what this means is because use routing has run and it's attached to the context details about the endpoint that's going to get invoked, these next pieces of middleware can actually use that information and perform some kind of logic based on it. So here, for example, it means that the team have been able to introduce this new use authorization middleware that runs as part of the authorization framework to make sure that the request coming in and the user that's attached to that request that's authenticated with the application to see whether they're authorized to actually access the endpoint. And if they're not, then it can return a forbidden result. That used to live inside MVC, but now it's been elevated up to a higher point in the middleware pipeline. So let's have a quick look at a demo for this. So I'm going to just stop the application there and jump to my application code. So this is all available in the downloads if you want to explore it. And there's some stuff that we won't touch on just through time today. But you can see here I've got two use middleware calls, and they're both to the same piece of middleware. And this is just a piece of middleware that I've written. The important thing is that this first use middleware is before use routing, and the second is after it's run. So if we just take a look at what endpoint logging middleware actually looks like, it's not very exciting, but when the invoke async gets called, we're going to use this extension method on the context to get the endpoint information. So this will return the representation of the endpoint if it's known at this point when this middleware runs. So this may be null. If use routing hasn't run, then this will be null because use routing hasn't yet an endpoint to the request. Other reasons it might be null is that perhaps nothing matched the route that was coming in, and so it just doesn't have a matching endpoint to send this request to. So in here, we just switch on that, and we can log out some additional information about the endpoint if it's known, or the fact that we don't have an endpoint. The easiest way to see this in action is if I jump over to Postman and just make a quick request to my application, we'll see that this comes into the middleware, and this is the first registration of that middleware. So this is before use routing. And as you can see, the endpoint here is null. If I continue, you'll see we come back into the middleware again, where we've registered it a second time. And this time it's after use routing. So now we have an endpoint mapped to this request, and we can dive into that, and you can see we can get details such as the controller and action method that's going to get invoked. We can access a metadata collection. And in here, we have a huge amount of information, some of it from MVC, some of it more general, but it's things like what attributes are attached to the action method and the controller, what details about MVC do we know about this endpoint. So now this middleware is running endpoint aware, and it can use that information if it wants to. I'll just continue that, and you can see we get our response. So if I jump back to the slides, we're now going to dive in from looking at the sort of early part of ASP.NET Core into how MVC itself works. So a quick primer on MVC. If you haven't used the MVC pattern before, we basically create controllers and action methods. If you're using this to build a UI application, then you might have Razor views as well. So here it's a controller for an API. So you can see we've got a simple class that derives from controller base, has an API controller attribute and a root attribute that defines how we want this to be mapped when the request comes in. So in this case, the root to this will use the controller name without the controller suffix, so just /books. We can have a constructor inside controllers that we can use to inject dependencies, and then we can create action methods. And basically any public method inside a controller is considered to be an action method. We can control how this is going to get routed to by adding additional root attributes if we want to. And as we've done here, we can also attach the HTTP GET attribute that says that this method should only respond to GET requests. The method itself could accept some parameters it doesn't do in this example. And then the method is going to return an iAction result. So this is a representation of the final result of the HTTP request that's been made. In this example, what we do is we use a helper method from the controller base called OK, and that's going to create an OK object result. And the object of that result is going to be just a list of books from a books repository. So a very simple example here. Now, if we take a look at the 10,000-foot view of how MVC is actually going to work, the main part is the first thing that we need is an instance of the controller. And every request is going to use a new instance of a controller. So the controller factory is responsible for initializing the controller that's going to handle the request. Then we hand off to the action invoker, which is responsible for actually calling the action method of our controller that's been mapped for the request. Then we're going to actually execute the results. So ASP.NET Core action methods return that iAction result. That is not the response content that we're going to send. It's not actually attached to the HTTP context as a sort of example of the response message at this stage. It's a more sort of high level view of what type of response we're going to send and maybe the data that we're going to include in it. So the way that gets turned into a response is through the execution of that action result. And then finally, the output can be generated. So in an API, that's just going to be some kind of data, probably JSON, that gets sent to the client. And if we're doing something with sort of UI applications, then the view gets rendered at this phase and returns a view result that sends the HTML to the caller. We can dive into this pipeline because MVC internally is just a very big state machine fundamentally. So as the request flows into MVC, it tracks the state of that request, and it will update that state as it flows through various components that MVC uses for the request handling. So we can take a look at some of those components, and for some of them, we'll see how we can create our own instances. So on the left, we've got the middleware pipeline. So the middleware is already run, and then that hands off to MVC. And the first set of filters that run inside MVC are called authorization filters. They run under an attribute called iAuthorization filter. So you can potentially create your own iAuthorization filter implementation, but generally you shouldn't need to do that. If you find yourself doing that, then you're probably misusing the overall authorization framework of ASP.NET Core. And I can't really dive into authorization in the time we've got, but it is a really interesting topic. Fundamentally, if you want to customize how authorization works, what you should be doing is using the built-in features. So you should be writing authorization policies and attaching those to your application. And then MVC and ASP.NET Core will make sure that those get executed and applied appropriately. Today, because of endpoint routing and because use authorization will have already run in the middleware, these filters don't really do much anymore. So they will check and see if the use routing and use authorization have already run. If they have, then they assume authorization has taken place. Otherwise, they'll run the authorization service and perform that work as part of this on authorization method. As I say, don't really worry about using them yourself, but what they would do is if the request hadn't already run for authorization and they determine that the request shouldn't continue, then they short circuit the pipeline and return a forbidden response. The next next filter, I should say, in this pipeline are resource filters. And again, today, these aren't as useful as they used to be. But fundamentally, they run when the request comes in and an on-resource executing method gets called. And so this gives us the opportunity to inspect the request that's coming through. And at this point, we've already done the routing sort of work. So we know where this request is going in terms of which controller and action. And so if we wanted to, we could customize those resource filters to take some actions based on that knowledge. Now, as I say, because of endpoint routing, and because now we have that concept of endpoint aware middleware, a lot of the functionality that you would previously have written as a resource filter, you can now move to a piece of middleware that first checks what endpoint has been called and then does its work there. So again, these are sort of less used, and they could potentially, again, short circuit the pipeline, but more commonly, they'll pass the request on. And then later on, after the rest of MVC has generated a response, they get called again on resource executed, and there's another chance for you to run some code there. Now I'm going to skip over the demo of that. There is a little demo in the code if you want to take a look at it, but it's, as I say, it's not something you should need to do today. And for the interest of time, I want to focus on the more useful filters. The next filter in this pipeline are middleware filters, which seems very, very strange. We've already run middleware. So why would we have a filter? Well, this allowed, again, in the days before endpoint routing, allowed the idea of applying a piece of middleware, but only to certain controllers or actions. And so if you had a middleware component, maybe like response compression, that you wanted to apply, but just to one endpoint, you would need to know what that endpoint was, and you'd have to apply it through a middleware filter inside MVC itself. Today, with endpoint routing and endpoint aware middleware, you could do that same logic by having a piece of middleware that only runs based on certain endpoints being matched. So after these initial pieces, which, as I say, since 3.0 have become a lot less useful, the controller itself gets created. So at this point, we're ready to create the controller instance, which the controller factory will do. And then we enter the action invoker stage. So what happens first as part of this sort of action invoking is that we need to do model binding. So it's very, very possible that our action method has parameters on it that it requires for it to function. So if you can think of an endpoint for our books API, we might have one that accepts the ID of a book so that it can return a specific book in detail. And so to get that ID, it needs that to come from somewhere on the request. And this is where model binding comes in to match data from the request to parameters on the action method. And this works through a process known as model binders. And there's a bunch of these registered by default inside MVC. Most of those will do what you need to do out of the box. So there's things for dealing with sort of simple types like integers, the more complex types like actual sort of strongly typed objects that you may use for input models, for example. So most of those are going to work perfectly well on their own. The way this works sort of at a high level is imagine we have this search action method here, and we have two parameters. We need a string, which will be our keyword, and then we need an integer representing a page size for a search. So when the request comes in, one of the ways that data may be sent to us is on the query string. And the way this is extracted is through what's known as a value provider. So the query string value provider can interpret this query string, and it will match to basically a set of key values that it's found on that query string. Then when model binding takes place, it can ask the value provider, okay, I need something called keyword, and I need it to be a string. And it will go to the value providers and say, have you got one? And the query string value provider will say, yeah, well, I've got this thing called keyword. And yeah, it has a string. So I will pass that over to you. And then model binding will map the performance value there as the parameter for that first keyword argument. We also need a page size. So model binding, again, will ask the value providers if they have this information. They will make sure it's an integer in this case and then inject it in. Now, we do have a situation often where we're accepting sort of more complex types. So if we want to accept a new book to be posted to our API, for example, what we might do is create a book input model, and then we need that to be bound from the request somehow. And this is where this data is usually going to come on the body of the request. And the way that gets matched from the body to the object that we need is through input formatters. So by default, ASP.NET Core includes an input formatter for JSON content. So if it sees JSON content on the request, it will try and use that to create an instance of a complex type that's needed by your action. You can register other input formatters if you want to. So there is an XML one that's not enabled by default that you could register, or you can write your own input formatters. So if, for example, you wanted to support message pack or protobuf, you could write an input formatter that can take that data off of the request and convert it to a typed instance during model binding. Let's have a very quick demo of model binding. So I've got an action in my my books controller, which is here. My books controller has an action method here, which takes this date range type. And if we take a look at date range, it's a very simple read-only struct. So we're trying to be a little bit sort of domain-driven design here and not accept data that can be sort of mutated. We want a representation for a date range. So you can see it has two dates on it, a start date and an end date. These are read-only properties. And so the only way we can create this date range object is through its constructor, passing in those two dates. We do a check here that may throw if the end date is before the start date, and otherwise we have an instance of this type. Now, ASP.NET Core itself is going to try and bind complex types using the sort of model binding framework and input formatters. But in this case, we're not expecting this to be as part of the body. So we need to create our own model binder so the framework knows how to bind this up. So I'll dive to the model binder and then we'll talk about how it gets attached. And this code is quite complex. I've tried to put some comments in, and it's not necessarily like, deploy it to production code, but it will give you an idea. So we'll quickly run through it. So here we're saying we're going to define first the two properties that we're looking for on the request. So we're going to expect these to be sort of strongly named, so a start date and end date. We're going to then ask the value provider system here, do you have something that matches those names? And they'll return a result. Now that result might be none, i.e. they haven't got those values. And if either of those haven't been found by the value providers, then we know we've not got valid data for this request. We can't bind this type that we need to bind. And so we'll return a failed model binding result. And we'll attach to the model state, which is information about that binding, that what actually failed. So this property failed and we couldn't find it. Moving on, if we have found those values, then we'll set the model state to say, okay, we found these values and these are the values. We'll extract those values from the value provider result. In this case, they're both going to be strings immediately. So we need to then try and parse those out to dates because we're expecting dates. If either of those is not a valid date, then we can't use them. But if they are dates, then we'll create an instance of date range. And then we can attach that as the success. So what we're saying here is model binding succeeded, and here is the bound object. We created an instance, and this is the bound object to pass to the action method. Now, obviously, this may throw an exception, so we catch that, and we also set a failed result here. So that's pretty much it. So there's two ways to attach model binding. If you own the type, you can attach the model binder with a model binder attribute, as I've done here. And so now the framework, when it's trying to bind anything with date range, will use the model binder. In some situations, maybe you don't own the type. Another way to match this up is to attach the model binder to this collection of model binder providers. So here we're inserting a model binder provider at position 0, so it runs first. And then we provide the binder provider, which is a very simple interface. We need to implement getBinder, and we say we can provide a model binder if the type is of date range. And if it is, this is the model binder to use. So all of these providers get checked until one of them says, yes, I can hand you a model binder that can handle the type that you're trying to bind. So that's kind of how it all works. So if we now make a request to this application, to that author's endpoint, to the date range endpoint, we've got the start date and end date on this request. So I'll send the request through. See, this has hit a breakpoint in my code, and we've got a bounds date range here because of our custom model binding behavior. If I jump back to excuse me, I should continue that request, and you can see that we get a response. So one of the things that we know is invalid is if we make the start date after the end date, we can run the request. And you can see now we get a 400 error through the model binding system, and it never hit the breakpoint in our action method. Model binding failed, and it didn't pass it on to that onto that action method. So continuing on, there's a few more things I want to cover. So the next filter that runs is an action filter, and these basically give us the opportunity to apply our own logic at this point in the process after model binding has occurred. So the main thing that action filters have that previous filters wouldn't is the knowledge of the bound arguments for that action method. So what data has been bound off of the request. And so here on action executing, we can potentially do something with that data. And we may choose to short circuit the request again at this point with a response. Typically though, what they're going to do is actually then move on to action execution. So after that filter runs, the action execution occurs, which is where our actual action method gets called. So this is sometimes the first place in the application where your own code is going to run, where code that you've written in your action method is executed. So that gets executed and it comes back to the action filter. And at this point, we have the on action executed method where we could then see what the result of that action method is and maybe take some further action. So let's have a look at how action filters work. So in my application, I've got a very simple example of an action filter here, 2-year date range action filter. So what this one does is we're going to run on action executing. So this is after model binding, but before we call the action method. And what we're going to say is from the context, find the action arguments and see if there's one called date range. We're expecting because it would have bound. And if that is of type date range, then what we're going to do is run some additional logic. So our date range type itself performs validation to make sure it's a valid date range, start date before the end date. But perhaps in our application, we have a requirement that we only ever allow a maximum date range of 2 years. Anything longer might be too much data, for example. So we're going to create that kind of cross-cutting concern as a filter here. And so we can apply the logic that says, okay, if the end date's greater than 2 years beyond the start date, what we're going to do is return a bound request. So we're going to return a 400 error. And on that error, we're going to include an object. So this will just be a JSON serialized problem details result that says what went wrong. So the nice thing about doing this as an action filter is we could apply this to one or more action methods. So if we have a look at the book controller, I've applied this filter with an attribute to this method. And at the moment in this application, that's the only action method that needs to use that filter. But if I have other things later on in my application code, rather than writing that same logic in each action method, for example, perhaps at the start of the action method, I can just apply the filter instead. So if I come into Postman again, and this time we will make this date range invalid by making it much greater than a 2-year date range. We'll send the request in. And again, it didn't reach the action method, but this time it was our iAction filter that took that request and realized actually that's greater than 2 years. So we sent back our 400 response. So that's kind of nice. So one other thing that might happen is that inside our action method, perhaps an exception's thrown. And if an exception's thrown that we haven't handled, that could be a problem because it could crash out. So ASP.NET Core is going to handle that by default, and it uses a mechanism of exception filters to do that. But we can write our own exception filter. So we need to implement the iAction filter interface to do that. And this is probably best seen just by quickly looking at one in the code. So I have one here. And what this exception filter does is on exception, what we're going to do is we're going to record an exception metric to our metric system. So perhaps we've got a monitoring framework we use to alert us when weird things happen in our application. We're going to fire a metric. Now, this is obviously something you wouldn't want to write inside a try-catch block in every action method. So rather than doing that, if we write an iException filter, we can apply this logic here. And in this case, what we do is we just return a custom format for the data type that we return if an exception has been thrown by the application, with a status code of 500. Now, this is something you could also probably do with middleware if you wanted to. So it's a preference thing about where you implement it. But if I call an endpoint on this application that in here throws an exception, not good, then we'll see that our iException filter got executed after that action method, and we got our nicely formatted message from our custom iException filter to run. After action filters come result filters. So at this point, we know what the iAction result is from the action method. So it's some implementation of iAction result has been returned as a result of our action method executing. And at this point, we could have a final chance where we might customize our sort of response and make a change. So we'll have a look at that in a moment. But after that filter runs, what happens is the action result itself gets executed. So this is where the OK object result, for example, actually gets executed. And this is the point where the data on that object is turned into a response for the end of the request. So the way this happens inside ASP.NET Core, typically if you're using an API application, then we're going to return JSON. So it needs to take that object and turn it into JSON. And to do that, it's going to use an output formatter. And just like input formatters, we can register more of these if we want to for different content types that we want to return. And in this case, the default JSON one will be fine. But again, if we wanted to send a protobuf response, for example, we could do that with a custom output formatter. So the output formatter is actually responsible for producing basically the body of the HTTP response message. After that runs, the response flows back through the pipeline. And as you can see here, we go through the result filters, we go back through any middleware filters and resource filters as well. So remember that those filters kind of have a double chance for some of the filters at least to see the response on the way out. And so any of them could at this point still change the response if there's some kind of cross-cutting concern that you want to apply. And we can look at that actually with a demo of a result filter. So inside my application here, I have a result filter, last modified result filter. So you can see we derive from this result filter attribute, which allows us to create one that can be used as an attribute. And if we sort of dive down into that, if it doesn't take too long for Visual Studio to navigate, you can see that this is of type iResultFilter here. So what we're doing is on result executing. So this is before we actually start creating the response, but after the action method has been invoked, we're going to run some logic. And the logic in this case says, look at the result on the context, and if it's an OK object result, get the value, which is the object, and check if it's this type, mutable output model base. And what we've got in my application here is a very simple sort of base class that we're using for any type of data in my system that could potentially have mutations occur in the database. And we basically say everything is going to have a last modified date in that case. And if we have a look, the book output model for this application derives from there. So as well as the book information, we're going to have that last modified date set from the database. So what this means is we've now got that data from the actual object. And so we say, okay, well, it would be nice if we could add a last modified header to the response containing the last modified date. And so that's what we're doing in this piece of code here. So not sort of super complex, but fairly powerful to apply. So if I now go to make a request to my books endpoint once again, you can see that the data itself includes the serialized last modified date. But because we ran that result filter, we've also got this additional last modified header here that's been included on the response for us. So that's kind of nice. And the way this gets applied to the framework is rather than registering this for each action method where we want it, we want this globally. So I've actually registered this along with the exception filter as global filters. So basically by adding them to this filters collection when you add the controllers and configure the MVC services, these will then be applied to every request as it comes through at the appropriate place, and then they can run their logic. So for cross-cutting concerns like exception handling, like applying the last modified header, those can be applied conditionally to all requests. So we've nearly finished the journey. We've gone through the pipeline. We came through some early filters that, as I say, since 3.0 have been a little bit less useful. The controller instance was created. Model binding occurred, which takes anything that we need for the action method to be invoked from the request, if it can do. And remember, if that fails, then the framework today will automatically return, or at least for APIs, it will return an automatic 400 bad request with details of why model binding failed. If model binding succeeds, then the action filter can run. Once it passes through the filter, the action method, so our actual code on the action method gets executed. The result of that is an iAction result. That gets passed to result filters, which can interpret that iAction result as we did with the last modified date, and then the result is executed. So this is where the data of that sort of iAction result interface is turned into the HTTP response that goes onto the context. And as I say, if you've got an object in there, that will go through an output formatter to produce, say, JSON results. So this all flows back through the framework, back to middleware. We've got a response in the context. This flows back through our middleware pipeline, remember. So each piece of middleware still has the opportunity to interpret the response from the context and maybe add additional data or take some other action. It flows back to Kestrel, and Kestrel's job is to turn the response into the actual bytes that it's going to send over the internet to the client that requested the request. And then finally, the response goes out. So here's the response from the end of our journey that we've looked at today. So the response message is, again, another fairly simple sort of ASCII text document generally. So here, the response header, or the response line, I should say, says that we, yes, succeeded. It's a 200 OK status code. The response includes some response headers. So some of these have been set by Kestrel, such as identifying the server that was used. Some of them may have been set by MVC, such as the content type that was used. And we've also got our own custom last modified header that we applied through our filter. So this is all of the data that we generated as part of the MVC pipeline. Because we have an object on our result that got serialized to JSON, and so that JSON message is returned as part of the response body. So that's quite a lot of information. I've tried to pack it into the time that we have. Let's just summarize what we've seen. HTTP request messages in ASP.NET Core will be received and parsed by Kestrel. Kestrel is a very performant web server today. It's well at the top of the Tech and Power benchmarks, which is a third-party benchmarking scheme that measures sort of web servers, and it's very near the top of that list. And it performs basically at the limit of the testing framework today. The team have done a lot of work to make it highly efficient, so low allocation and very quick to execute. After that, it creates the HTTP context, and then that first flows through the middleware pipeline in the order that you registered those middleware components in the configure method of your startup class. Each piece of middleware may choose to short circuit the request and return a response. More often, they will maybe add some additional data to the context and then pass it on. The rest of the middleware pipeline runs until some endpoint is going to handle the request. And today, that's most likely to be MVC, so a controller and an action. But what you can also do is write what they call sort of route-aware or route-aware, which is where you have just an endpoint defined directly that knows how to build a response. So this is like sort of an extension of what you might do with middleware today. But we saw it going through MVC, which has its own request pipeline. So we saw that it went through that filter pipeline, and filters provide a mechanism where we can plug in our own behavior for cross-cutting concerns if we need to. So if you've got something that applies on more than one or two action methods, then maybe think about whether it can be written as middleware, which I'd always recommend as your first port of call because it's the easiest for people to reason about. But if it can't easily be done in middleware because it needs to know something about model binding, for example, then you could write it as a filter inside MVC and apply that filter to either some action methods, some controllers, or globally for your application. After all of that runs, the action gets executed, your code gets run, it produces the iAction result, and from that iAction result, we produce the final HTTP response that goes onto that context, and then this flows all the way back through to Kestrel. Appreciate there's lots of information. Pretty much use the time I think that we have for the session, but I will certainly try and keep an eye on the YouTube chat for any questions. If I missed your question there, do reach out to me at Steve J. Gordon on Twitter. You can follow my blog, stevejgordon.co.uk, for sort of blog posts about some of this stuff when I get around to writing them. I have a few Pluralsight courses, so you can go to my author profile there if you want to view those. And a reminder one more time, if you want the slides, if you want the demo code, the bit.ly link there /ASP.NET Anatomy will take you to that link. So that's pretty much my time. I really appreciate you, as I say, taking a time out of this Saturday to join me. Very sad I'm not there in person and we're not able to kind of chat afterwards and over lunch, but hopefully we'll all be back and traveling next year so we can return. Thank you very much for your time, and I hope everyone enjoyed it.
Wow, that was an awesome session by Steve. I know a lot more about the internals of the ASP.NET Core pipeline now. But next session is about building an eShop on Dapr by Sander Molenkamp. So Sander, what's Dapr? Well, you're going to explain all about that, but I've never even heard of it. So
Dapr is this distributed application runtime. It's pretty new. It's been announced last year at Ignite, and it aims to make it much easier to build distributed systems.
And I quickly looked on the website, and it seems to be cross-platform as well. It's not just for .NET.
It's not just for .NET. You can basically use any language, any framework to use these building blocks. So it's it looks very promising.
Okay.
And
Well, very cool. So take it away and share the goods.
Let's dive in. So hello everyone. Thank you for coming to this session. My name is Sander Molenkamp, and I'm a principal cloud architect at InfoSport here in the Netherlands. So I help customers create cloud-native solutions, and I'm also a Microsoft Azure MVP. And as Maurice said, the next 50 minutes or so, we're going to be talking about Dapr. So nowadays, developers are writing more and more cloud-native or microservices applications. And if architected well, they can provide a lot of benefits, such as scalability and a higher resiliency than traditional applications. But writing distributed applications is actually pretty hard. They can be really complicated, and it can take up a lot of your time. So if you look at complexity, you can make a distinction between essential complexity and accidental complexity. So essential complexity is complexity which is inherent in the problem. So you cannot make it less without reducing the functionality of the system. So this is where your business value is, and it should be the main focus of the developer. And everything else is accidental complexity. So this is the stuff that we as developers add to the solution to actually make things work, the glue code, as it were. So that includes infrastructure, frameworks, maybe even writing services in multiple languages. So now, obviously, we should add as little accidental complexity as possible. And that's exactly where Dapr comes in. So Dapr is this distributed application runtime, and it's an event-driven portable runtime for building microservices that can basically run anywhere. And before we dive into the details, it's important to know that Dapr is still in preview right now. So please don't use it in production yet. The version number is now up to 0.8, and I believe the plan is to get up to a 1.0 release before the end of the year. Now, at its core, Dapr is a set of building blocks. And each of these building blocks is independent. So you can use one of them, you can use some of them, or you can use all of them in your application. That's entirely up to you. Now, in this first release, you can see the list of building blocks that are provided. So first of all, we've got service-to-service invocation. So this enables services to communicate with each other using HTTP or gRPC messaging. We've got state management, which provides a key value-based API for persisting state, so you can use that to create stateful services. There's PubSub in there for messaging between services in a loosely coupled manner. Then we've got a very interesting one, resource bindings and triggers. So a binding provides a bidirectional connection to some external servers, and then you can very simply use that service by going through the binding, which is much less code than having to write custom code yourself to access the servers. Or you can let the servers trigger your application by sending an event. So this is very much like the bindings and triggers that we all know and love from the Azure Functions team, but now it's totally decoupled from any runtime. Then we have actors. So Dapr also provides a actor model, a virtual actor model to be precise. An actor is an isolated, independent unit of compute and state, and it's also single-threaded, which makes it very easy to program with in highly concurrent scenarios. And actors can be actually a highly effective solution in situations where there's a lot of parallel processing going on. And then we've got some features around observability. So observability deals with metrics, logs, distributed traces, everything to debug, operate, and monitor your solutions. And then we've got secrets, which is a building block that integrates with various secret stores, such as Azure Key Vault to store your secrets. And then also Dapr also provides the extensibility to add new building blocks. And I'm sure we will see this set being expanded in the future. Now these building blocks are exposed over common HTTP and gRPC APIs. So that means that you can access these building blocks from any language or frameworks that can make an HTTP or gRPC call, which is basically everything. And now to make Dapr even more natural to use in some of these languages and more productive to use, they also provide language-specific Dapr SDKs. So these are available for Go, for Java, JavaScript, .NET, and Python. Now, Dapr uses a sidecar architecture, and it can run on multiple hosting platforms. So in standalone mode, the Dapr process runs as a separate process from your application process. And your application can then call the Dapr APIs via HTTP or gRPC, which again makes it possible to use from any language or framework. And you can also deploy Dapr in Kubernetes. And in this case, Dapr runs as a sidecar container in the same pod as your application container. So the latency between those two containers is very low because they are running on the same machine. And you may recognize this sidecar pattern from service meshes such as Istio or Linkd. But it's important to note that Dapr is not a service mesh. So service meshes mainly focus on networking infrastructure to connect services together, to provide telemetry about those services and their interactions. And Dapr can provide you with some of that, but Dapr is much more developer focused and also provides all these additional building blocks I just talked about that are outside the scope of a typical service mesh. However, there's nothing stopping you from using them together. Right? Your servers can have two sidecars. So for example, you could have a Istio sidecar that you use to connect to other services, and then a Dapr sidecar, which you use, for example, to use the actor model or the state API. Now, in the remainder of this session, I want to dive into some of these building blocks and show you some of the details of how you work with them and how they can improve an existing application. And that application is eShop. So eShop is a classic .NET reference application. It's a web shop that lets you buy some cool .NET merchandise, and there are different variations of it. So eShop on web shows you how to build a great web application, for example, and there's a version of eShop that adds all kinds of AI and ML features. Now, the version that I'm using for my demos is eShop on containers, which is based on a microservices architecture with Docker containers. So let's have a look at the architecture of eShop on containers. So eShop on containers comes with multiple clients. So we've got a MVC implementation of the front end. We've also got a SPA implementation, and there's also a mobile implementation. And then we've got this ingress part where requests from the front end are handled by application gateways that follow the backend for front end pattern. And these are implemented using Envoy. So Envoy is created by Lyft, and it's a open source high performance admin service proxy. And it's used as a reverse proxy basically. And it will take the requests from the front end and route them to the backend services. Now, the backend services are split into these two contexts. So we've got the shopping context and the marketing context. And those services provide the core functionality of the application. So the catalog API is responsible for keeping the catalog of items. The basket API is responsible for tracking the items in your basket. The ordering API for the ordering process, and so on and so forth. So most simple calls that only need one backend service are directly being routed to those backend services. But then in the middle, we've also got a set of aggregation services. And these provide a simple API to the clients for more complex operations. So those are mostly operations that depend on two or more services. And then finally, the backend services also communicate with each other. But this is done using messaging to keep them isolated, independent, and loosely coupled from each other. Now, for the Dapr version of eShop, first thing I did is just add Dapr sidecars to all the .NET services. And that makes it possible to use the Dapr building blocks from those services. Now, you can deploy eShop to Kubernetes. There are Helm charts included for that. But for now, I decided to keep it a little bit simpler and to use Docker Compose for my deployment. And the way it's simpler is that it provides a very nice F5 debugging experience in Visual Studio. So you can just hit F5, Docker Compose will do a compose up, and you can very easily debug across services. So for that, let me go the right way. So there we go. For that to work, I needed to add the sidecars to the Docker Compose file. So this is a small piece of the Docker Compose file. This snippet here defines a catalog API service. It references the Docker file for the specific service. It exposes support. And it still needed a sidecar. So I've created an additional service in the Docker Compose file called catalog API Dapr. And here I'm using the Dapr daemon Docker image. And when the Dapr daemon starts, I need to give it some starter parameters. So first of all, I'm specifying the application ID. Each application that uses Dapr needs a unique ID, so it can be addressed uniquely. So in this case, the ID for my catalog API service will be catalog API. And then I also need to tell the Dapr sidecar on which port my API is listening. I also give the sidecar a 5001 port that it can use to listen for gRPC connections. And this components path is interesting because all these building blocks, most of them use components as a kind of plugins, as a way to inject different state stores, for example. And the configuration for that is saved in YAML files, and those are saved in this component path. And then this config file contains some more general configuration settings. Now, the network mode here is very important. So by specifying server's catalog API, I'm telling Docker that I want my sidecar to run in the same network namespace as the catalog API itself. And that means that the application container and the sidecar container can reach each other through localhost. Then last but not least, I need to make a little bit of change to the catalog API service. It needs to know where it can reach the sidecar. So I'm saving the gRPC port here in an environment variable, and I need to expose that port to the host. So with all that set up, let's have a look at eShop actually running. So here I'm on my development machine, which is at this point I'm a VM running in Azure. And I've opened the eShop on Container solution, and I've already started it because it's using a lot of memory, a lot of Docker containers, and on my VM it can take a little bit of time to get started. So if I go here to the containers, you can see that all the containers for the different services are already running. And if I scroll a bit more down, you can even see all the other containers that the solution uses that are not directly related to projects in my solution. So these are the Dapr sidecars and also containers for things like Zipkin, RabbitMQ, SQL Server, and so on and so forth. So let's look at a typical service. This is my basket API, which is running in a container. And my basket API has a corresponding basket API Dapr sidecar. And if I look in the logs for that, you can see that Dapr is initialized and the sidecar is now running. So let's move over to a browser window and see if the application really runs. So here we go. So you can see all t-shirts are for sale this weekend. That's great news. There are some nice products in there, some really cool swag. And I can add something to my cart. So let's find a t-shirt. Let's add a .NET Foundation t-shirt to my cart. And again, with everything going on in the debugger, this is running a little bit slow. If you deploy this to Kubernetes or in a production-like environment, or even without a debugger, it's much, much faster. So I've just added something to my basket, and the item count here has also been updated. So this seems to work pretty well. So let's start looking at some of these building blocks. So first of all, let's look at the service-to-service invocation building block, and we'll just touch upon a little bit of the observability here. Now, eShop on containers itself uses both HTTP and gRPC for service calls. And it used to be HTTP only, but now only the simple calls from the API gateway to the backend services use HTTP, and the more complex calls from the aggregator service to the backend services are done over gRPC for performance reasons. And of course, there are proto files in the solution, and those are used to generate strongly typed clients. Now let's consider an interaction between the web shopping aggregator servers and the ordering API. So when a user clicks on the checkout button in the application, a request is made to the web shopping aggregator to create an order draft from the basket. And to do this, the web shopping aggregator needs to call a couple of services. And one of those is the ordering API. So it will need to make a gRPC call using the generated client. So this is the original code from the eShop on container solution. And you can see that it uses this ordering gRPC, that ordering gRPC client, to make the call. And of course, it needs to know where the ordering API is. So it needs a URL, it needs an address to make that call. And those URLs are configured in environment variables. There are quite a lot of these type of environment variables in the complete Docker Compose file. So this is how things stand with eShop on containers. Now let's see how this works if we add Dapr. So first of all, if you use Dapr, Dapr takes care of all service discovery. So instead of directly calling the ordering API, the web shopping service makes a call to its sidecar. And this example here is using HTTP, but you could also use gRPC to call the Dapr API. Now, based on the application ID, the sidecar forwards the request to the sidecar of the ordering API service. And that sidecar will make the actual request on the ordering API. And the response will follow the same path back. Now, because eShop on containers is entirely written in C#, I really wanted to use the Dapr.NET SDK to have a more natural .NET experience instead of just having to directly work with the HTTP client. And luckily, the Dapr.NET SDK provides some very nice ASP.NET Core integration. So let's see what this looks like. So on the caller side, you need to create an instance of a Dapr client class. And you can use that to make the call to the sidecar. And the Dapr client will use gRPC for that. Now the sidecars also use gRPC to communicate with each other. And then on the callee side, so on the basket side, oh, it says basket should actually be ordering API there. So on the ordering API side, I decided to change eShop back to HTTP. Why? Well, I couldn't really use the eShop proto files they provided in the way that I wanted with Dapr. So to let the sidecar call my service, I would have to implement the Dapr proto file. And especially this uninvoke method that you see here. Now that method is very generic, and it doesn't give me the natural, strongly typed gRPC experience. Now that said, the team is looking into how Dapr can use gRPC reflection to get a better experience here. And I do still get gRPC performance benefits for any calls across nodes, which are the calls between the sidecars. Okay, so let's look at some code. let me switch over to Visual Studio. All right, so this fella here, the web shopping HTTP aggregator, this is the aggregation service. That's the one that is making the call. And to do that, it has a, let me see, where is it? It has a iOrdering service interface, which defines the get order draft async method. And I've changed the implementation of the ordering service to use Dapr. So first of all, I need an instance of the Dapr client, and I've registered Dapr in the startup class. So now I can very easily use constructor injection to get an instance of the Dapr client. So this is what you see here. And I want to call the ordering API. So I need to know the application identifier, and I've stored that in a constant. Now, if I want to, or when I want to call the method, that's very easily. It's just a one-liner. I call dapr method async. I pass it the app identifier. I pass it the method that I want to call, which maps to the route of the MVC controller on the callee. And I give it basically the payload, the data I want to send to the servers. So let me just add a breakpoint here so we can actually see this running in a moment. And let's have a look at the other side of this, which is on the callee side. So this call will go to the ordering service. And in the ordering service, there's a orders controller, which is just a common MVC controller. And here we've got a method. Let's see, where is it? Create order draft. Yeah, it's all the way on the bottom. So this is the method that I'm trying to call. So let's also add a breakpoint here. And now let's go to the solution, go to my basket. And now when I click checkout, we should break into those breakpoints. So here we are on the web shopping aggregator side. It's going to invoke the method, and when I press F5, it will do so, and we will end up in the second breakpoint where the call comes in. And we get a gateway timeout because I waited too long in my breakpoints. So that's nothing to worry about, actually. So let me do one other thing. Let me quickly remove my breakpoints before I get into trouble later. And then let's go look at Zipkin, because I've configured eShop on containers to use Zipkin through the observability building block of Dapr. And that's very cool because now all traffic is flowing through those Dapr sidecars. Dapr can give me a lot of insight into that traffic. So if I search, I can now see all the calls that are being made between the services. And there's also this very nice dependency graph where you get an entire topology of your microservices solution. So let me clean this up just a little bit. So you can see here my web shopping application gateway, which is going to that aggregator service. And you can see all the backend services here on the right side. So this provides me with very valuable information. And it's basically here for free due to the fact that I'm now running all the traffic through those Dapr sidecars. All right, let's switch back to the slides because initially I only added sidecars to the .NET services. But then all these service calls originating from the web shopping API wouldn't be visible in Zipkin because they wouldn't be routed through Dapr. So in a second version, I've added also Dapr sidecars to the Envoy application gateways to get even better insights. And that was pretty easy to do. So this is a piece of the Envoy configuration. And you can see here that if a request is made to any path starting with catalog API, then I rewrite that request to a Dapr invocation, and I send that to my Dapr sidecar. And the Dapr sidecar will then eventually send a request to the catalog API. So I think this truly shows that you can really use Dapr from any language or framework. It's really easy. So what are some of the benefits that we actually get from this? So first of all, error handling. Now, if there's a network or connectivity error, Dapr will retry. I don't have to deal with that myself in the code. And for the future, the team is also looking to expand that capability to even include stuff like circuit breaker support. Secondly, as we've just seen, Dapr gives me a lot of insight to my application by just capturing, tracing, metrics, telemetry, making that visible. And I use Zipkin, but there are many other things you can use, such as Jaeger, Application Insights, Prometheus, many more. And thirdly, Dapr can secure and encrypt the communication between services by automatically using MTLS. And that saves you from a lot of work, like dealing with certificate authorities, etc. And all of these benefits are made possible because now there are these sidecars in the middle. All right, so now let's switch gears a bit and go to state management. So state management basically provides you with a key value store, and we'll also touch upon secrets a little bit. So eShop on containers uses already a variety of data stores. Many services use SQL Server and they use Entity Framework to interact with the database, and that's perfectly fine. Entity Framework is very good at that. Entity Framework also already provides support for many different databases, such as SQL Server, MySQL, Cosmos DB, so that already gives us a level of portability for relational data. But there are also some other services that use other data stores. An example of that is the Basket microservice, which uses Redis to store its state. And to make it work, it uses a third-party NuGet package called StackExchange.redis, which is a Redis client for .NET. It's developed by Stack Exchange. And we can make that service maybe even more portable now by using the state management building block of Dapr. So what does that look like on the Dapr side of things? Well, with Dapr state management, you can very easily load and save state in a key value store just by making calls again to the Dapr sidecar. So if the Basket API wants to update the basket, it simply does a post request to the Dapr sidecar, and the Dapr sidecar will save the state in a state store of your choice. So a couple of examples here: DynamoDB, Cosmos DB, Redis. In the demo I'm going to show you, I will be using Azure Table Storage. And then if the Basket API wants to load the data, it again makes a simple call on the Dapr sidecar, in this case a cat call. So let's look at the code for this. Let's close the Zipkin. And let's first have a look at this components folder over here. So components are like plugins for building blocks, right? And these components, YAML files contain all the configuration for my building blocks. So if I look at statestore.basket.yaml, then this is my configuration to use Azure Table Storage as the backing store for my state management API. So I've got to give this a name. So I'm naming this one Basket. I'm telling it to store the data in table storage. And then, of course, I need to give it some more details on how to connect to my specific storage account. So I do that by specifying the account name and also the storage account key. Now, of course, I don't want to directly store any secrets inside these files because these files will end up in source control, so that's no good. So here I'm using another Dapr building block called the secrets building block. And that secrets building block I've configured in the secrets YAML file. So here I'm telling Dapr to create an instance of the secrets building block that I'm calling Azure Key Vault. And I'm telling it to get the secrets from Key Vault. Now, obviously, I again need to tell Dapr where it can find the key vault. So I need to specify the vault name, tenant ID, client ID, and also a password or key to access the vault. Now, again, I don't want to store that here either. So for now, I'm using a certificate, which I can keep out of source control. But if you're running on, for example, Azure Kubernetes servers, then you can actually use managed identity with Azure Key Vault, and you don't need to worry about this. So going back to that state-store.basket API, I'm loading the storage account key by a secret key ref, and that's all stored in the cloud, in my eShop on Dapr Key Vault. If we look in here, you can see I've got two secrets. I've got the storage account key, and I've got a dummy secret called foo. That's just to show you how easy it is to work with these building blocks, because you can very easily just query the building block by going to one of the Dapr sidecar containers. So one of them is listening on this port right here, and then go to the endpoint for the secrets building block, tell it the name of my secret store, and then ask it to get the key with name foo, and it will return the secret to me. Now, while we're in Azure portal, you can also see that I've got my storage account here. And if we go to the Storage Explorer, you can see the actual table containing my basket. And just to show you that this really is the live state from the application, let's just delete this. Go back to the application, go to my cart, and it should be empty now. And it is. So it's really using that Azure table storage. All right, so let's look at some code, because I'm using the .NET SDK here. So let's find the basket service. And let's go over to, let's see, the repositories. So eShop used to have a Redis basket repository, and I've added my own Dapr basket repository. Again, I'm using the Dapr client. It's being injected in the constructor. And then when I want to update the basket, I can simply say Dapr client get state entry. I give it the name of the store and the key under which I want to store my data. Then I can set the new value, and I can call save, and the data is being saved to the store. Now, there are also some interesting options I can specify here. So for example, I can specify the concurrency mode, whether I want last write wins or first write wins. I can also specify the consistency mode. So if your backing store is distributed as well, and if it runs on multiple nodes, I can choose strong consistency if I want all the nodes to be committed before save returns, or eventual consistency if it's okay if only one of those nodes has committed the state before returning. And then I can also set some retry options here. So I can choose between linear retries, exponential retries, and set some of the options there. Now, this is pretty cool because you get all these features independent of the kind of store that you choose. And Dapr has already many supported state stores. So now your application can use all these state stores without adding or learning a third-party SDK. And as you can see, the state API also supports transactions, but only for a selected number of components. There are other subtle differences between stores. So for example, a string stored in table storage has a maximum of 32K characters. That's just a limit of table storage. Now, if you're storing large JSON documents and you're switching from a store that does support that to table storage, which has that limit, then maybe now your application will fail. So you gain a lot of portability with this level of abstraction, but you still need to pay close attention to the details of the components that you use. So the last building block I want to talk about is pub/sub, which allows for messaging in a very loosely coupled manner. Now, eShop on containers
includes an event bus abstraction to handle integration events between services. And there are two implementations. So one for RabbitMQ and the other one for Azure Service Bus. So for example, you can use Azure Service Bus in production, and then when you're running locally and you don't have an Azure Service Bus locally, you can use RabbitMQ. Now, because of that, the code base now contains twice the amount of code for sending and receiving events, because we need two different implementations. And actually, to be able to write those implementations, you need to learn two different SDKs. And then once you're all done with that, you end up with startup classes like this, which are also really verbose because you need to specify which one you want to use, and you need to be able to configure them both. So let's clean that up a bit with Dapr. Now with Dapr, to publish an event, you yet again make a call to the sidecar, and you pass it the topic that you want to publish on, as well as the actual message that you want to publish. So here I'm publishing a order status change to awaiting validation event from the ordering API servers. And that event is raised right after the customer has checked out an order. Now that message data, that payload, is wrapped in a Cloud Events envelope. So Cloud Events is this specification for describing event data in a common way. So it's very nice that Dapr also uses that standard. The sidecar then publishes the message on the configured pub/sub component, whatever that is. So that may be a Redis cache, which supports pub/sub. It may be Nats, or Azure Service Bus, RabbitMQ, whatever you want. And then on the subscribe side, these sidecars pick up the messages and they call the actual services. And that looks a lot like service invocation. I really like that. So instead of pulling for messages from your application code, you get pushed a message when it arrives. And that's a very nice programming model. So let's go back to the code and have a look at the eventing code. So let me see, where did I put it? In building blocks, I think. Yeah. So here you see a couple of event bus projects. So RabbitMQ and Services Bus, those were already in the original solution, and I added my own implementation, Event Bus Dapr. So that was really hard work. It's only like 22 lines. It doesn't have to do very much. It only needs to take an integration event and then publish it. And with Dapr, that is really easy. You can just make that call to the sidecar, and I'm using the Dapr client for that. Now there is one nasty thing here, because initially I didn't do this cast to dynamic here. So I told the Dapr sidecar to publish an event of type integration event. But integration event is a base class from which all other integration events derive. And the problem I ran into is that only the direct properties of this base class were ending up in the actual event message and nothing else. And the problem is that Dapr uses the new system text JSON library for the serialization. And the system text JSON does not have very broad support for inheritance. So this method is actually a generic method which takes a generic type argument. So what happened is it basically interpreted it like this, and that caused the system text.json serializer to only serialize the direct properties of the integration event class. So now, by casting this event to dynamic, I'm letting the .NET runtime figure out at runtime what the correct type parameter should be. And that works perfectly well. Now, let's go over to the service that's actually the subscriber in this, and that's the catalog API. And to subscribe to messages, I first have to change some stuff in my startup class. Whoops, didn't want to go there, I want to go to 88. So first thing I had to do was to add this Cloud Events middleware. And that just makes sure that the middleware can unwrap any incoming Cloud events. And then I needed to add this subscribe handler. So the subscribe handler is called by the Dapr sidecar when it starts to find out in which events this service is interested. So by adding this subscribe handler, by calling this method, I now get an additional endpoint on my service. So the catalog service is exposed on port, 5105, and it now has this Dapr subscribe endpoint. And that's not exactly what I would expect. I don't think my service is actually running on 5.0. It's running on this port probably. Yeah, that's the one. So you can see the catalog service is interested in all these topics, and it also contains the route to call whenever a message comes in on that topic. So the Dapr sidecar uses this information to listen to the messages and to deliver them to the actual servers. So, and now the actual handling of the event is done in just a general MVC controller. So I've created this integration event controller here, which is just a normal controller, but now it has a method for each event for which I'm interested in. So this method here will handle the order status change to awaiting validation integration event. And to let Dapr know that I want to subscribe to that, I just need to add this topic attribute on top. And of course, I also need to still add an HTTP post attribute because the sidecar needs to make a call. And right now in the .NET SDK, these two names must be the same. And if we go to, let me see, to my components directory, to the pub sub, then you can see that I'm using nets now. Up till around this morning, I was using RabbitMQ, but I wanted to try something else. So I've just needed to change this single component file to make use of nets. So nets is a really lightweight, very high-performing messaging platform. And it also provides this nice demo environment. So I don't even need to install anything or get a Docker container. I just point Dapr. I just tell Dapr I want to use nets, point it to this demo environment, and all the pops up messages will go through that. Okay, so I might just have enough time to just set a breakpoint and show you this in action. So let's go to the catalog API, go to the integration event control and set a breakpoint here. And then we need to go to the shop and make sure that that breakpoint's actually being hit by buying something. So let's just buy the first thing we find. It's this nice .NET mug. So this will be added to my basket. And I click on the basket. And it's added, so now it's also being stored in table storage again. Clicking on the checkout button here. And sure, that's my address, and I'm placing the order. And as you can see, I've already bought a lot of .NET swag. Okay, so what's happening now is that there's like this grace period in eShop on containers. So immediately after you buy something, the system waits for a little while to see if you're going to cancel it. And then after about a couple of seconds, like 30 seconds or so, the order status change to awaiting validation integration event is fired and the process starts to handle your order. So as you can see, this comes in perfectly. And now I can go check if I've actually got stock to fulfill this order. If so, I'm going to send a confirmed order stock item. Otherwise, I'm going to send a order stock rejected integration event. And again, that's just using the same PubSub mechanism there. All right, let's go back to the slides. So, just to wrap this up, does this improve eShop on containers? Well, there's a lot going on in eShop, and Dapr really helps by reducing the number of different frameworks that you have to deal with. So changing an existing application to use Dapr like I did here really only makes sense in a migration scenario. So let's say you're re-architecting an existing on-prem application to move to the cloud. Then it can make perfect sense to replace existing code with Dapr building blocks and add new functionality using Dapr. And of course, the same is also true for any greenfield scenario. In fact, I think you can really save a lot of project startup time if you build a new distributed system using Dapr. So Dapr also reduced the amount of code that needs to be written manually. And in eShop, this is particularly clear if you look at the pub/sub code before and after the Dapr rewrite. And you also get some features basically for free, like the distributor tracing and the MTLS encryption. Dapr also greatly increases portability and interoperability. So eShop supported those two pub/sub systems, Rabbit and Azure Event, Azure Service Bus. But now I can choose from a whole lot more just by simply changing that configuration. And that also allows me to defer some important infrastructure decisions to a later point in the project, which can be very valuable. And on the point of interoperability, eShop is, of course, completely built on .NET because it's a .NET reference application. But now with eShop on Dapr, I can easily add microservices written in any other language and use the exact same building blocks. Now, be aware, though, Dapr is still in preview. There are breaking changes between versions. And generally, you can run into some unfinished items, such as incomplete or out-of-date documentation, maybe some features still missing in the language SDKs. But that's all to be expected from a preview release. So Dapr will not be a silver bullet that solves everything for you, but I do believe that it's a very useful tool that really makes it easier to build distributed systems. There's also a really active community around Dapr. It's also very useful for figuring out any problems that you may run into. So I'm very interested to see where this project will go in the future. So with that, I'm at time. So you can see or read everything about Dapr on their homepage, dapr.io. All the code that I've changed, so my fork of eShop on containers can be found on my GitHub page. Also want to make a little plug here for a video podcast I'm running along with my buddy Edwin van Wijk, who is also organizer of this fine conference. And you can see those videos at youtube.com/.netflix. And we will definitely talk more about Dapr in the coming months. So thank you very much for listening. I will look through the YouTube chat to see if there are any questions and answer them there. And if you want to reach out to me with any other questions or remarks, you can do so via Twitter at Amolenk. So with that, thank you very much.
Hey everyone, we're still doing .NET Core Summer event here. We just saw a great session by Sander Molenkamp around eShop on containers, and he did some stuff where he used Dapr, the new runtime that we have from that came out, and he used that to rebuild basically eShop on container, and all the communication goes through Dapr. It's a pretty cool session. But now our next speaker's up. Hi, Irina.
Hello.
Hi,
hello everyone. Fine.
Yeah, we already discussed it's also hot in Romania, so we're all just sweating here, but we're trucking on. Your session is going to be about GraphQL.
Yep.
It's pretty cool. I haven't done a lot with GraphQL, so I'm very curious about your session. So I will say, just take it away and show us everything about GraphQL.
Thank you. So today we're going to talk about GraphQL, just because I really believe that in order to pick the right technology for our problems, we need to be aware of those technologies, because let's face it, there's still no silver bullet out there to solve all the problems we might face in the project. So that's why I chose GraphQL. So a little bit about me. I'm a developer because that's what I do in my daily life. But I'm a software architect at Endava. I teach .NET and I often blog. And I am Microsoft's valuable professional around developer technology. So I'm pretty much passionate about everything that is .NET and around .NET. So today, we need to talk about REST because, in a way, GraphQL appeared as a response to REST problems. Then we're going to talk about GraphQL as a concept, GraphQL in .NET, and we will try to decide, okay, which is better, GraphQL or REST. Okay, so a short reminder that REST was there and is there, and a lot of us brag that we implement REST APIs, when in fact, looking under, when zooming in, basically we kind of do, I don't know, JSON over HTTP. I admit, I do the same thing often. So REST constraints are 6 at their number, and the first of them is client-server. First, we need to have a client that is able to issue requests to the server, and then a server that is able to understand those requests from the client and answer, if it can, with a proper answer. Next is stateless, or it should be stateless. An API should be stateless. What means to be stateless is basically following the constraints of HTTP around not keeping states. If you work with ASP web forms, you might remember that we had a lot of ways of keeping states, hidden fields in there, cookies or whatnot, whatever inventions we had at the moment. But when it comes to APIs, stateless should be a constraint that we need to follow. Caching, the cacheability or the ability to cache is one of the most important constraints of web in general, where the server marks the response as being cacheable. And the client, when notices that, okay, that resource is cached is marked as being cached, it should keep that resource on the client side and serve that resource back when it's needed. REST needs to have an uniform interface. What it means is that we need to be able to identify those resources. And by identifying those resources means to have a proper way of identifying them in terms of naming of our endpoints and naming our resources. Next, we work with representations of those resources. And what it means that we will be able to request a different representation of a specific resource depending on the headers we send or the verbs we are sending to the server. And more than that, the messages or the requests we issue from the client side needs to be self-descriptive. Not only the requests, but the responses also. I mean, by looking at an independent request, you need to be able to identify what is needed, right? So if you identify what is needed, means that you can treat that request in isolation without any trace of what requests have been issued before, right? Next, the most overlooked thing around REST, it's HOAS, hypermedia as the engine of the application state. We often say, well, if I do this, it might add overhead, there might be performance penalties in my API, so I don't do that. So REST APIs are centered around verbs. We have different verbs that we should use correctly. We have headers that should help us identify and add meaning to our requests. And we have status codes that we often forget or we do not care because we are pressured to deliver. And to think about, okay, in this case, what status code should I respond with? In a way, it adds overhead to us as a developer. So media types. Another thing that we often forget is the correct usage and the power of them. So having a REST API pretty much means that we will have intuitive endpoints. We won't need documentation to realize what's there and what can be issued and what are the responses that we can get back. REST APIs should have meaning, and it fully leverages the HTTP power. And of course, responds to different needs. But when we talk about representations of a resource, no matter what is the resource, we talk about headers, and there is that process called content negotiation on the server, and also status codes. For example, with a specific header, we might get back a 200 and a JSON response body. And if we change a header and specifically the accept header, then we might get back a 200 as the response and an XML as body representation. Moving on, the same pretty much request, but with a different header, might bring us a 415 and no content as a body, right? But REST APIs should be scalable. Server and client could evolve independently, are discoverable in a manner, but we do not implement HOAS, so they're kind of not discoverable, and are, of course, evolvable, or it should be, as Roy Fielding stated in 2000. More than that, server is the one that drives the application state in REST. And by driving the application state, as a consequence, it means that server and the client can evolve independently, right, without being so tightly coupled. And more than that, if we talk about versioning our APIs, I think having a v1 in the URL is familiar to most of us. I admit I did it, but REST APIs are very rare and often treated superficially because we're pressured to deliver. We need to do things as soon as possible, and in a way, we do not have the necessary time to design that API in a manner that is fully REST. And more than that, you need discipline. And if you do not have time, you kind of can't be disciplined. And also, you need to constantly design your API. When you need to sync with front-end teams and so on, designing the API, it's often overlooked. In terms of evolvability, Roy Fielding said that, well, the reason to make a real REST API is to get evolvability. And having a v1 is a middle finger to your API customers, indicating, in fact, that is not REST, is an RPC or HTTP. Simple, not REST API. Roy Fielding said this on Twitter in 2013. And since then, we're still not improved in this term. We still add v1 into URLs. We still do not increase that v1 to v2, no matter what is happening inside our API. And we often found out that, well, our APIs, no matter if they're fully REST or not, are very chatty. And this chattiness is harmful for our systems. Because in a real world scenario, we should have exact fetching. I mean, if the client needs something from the server, the client should receive only those fields that are used in the customer application. But in fact, REST has an issue. One of those is overfetching, brings more than you need in the client, and at the same time, it forces you to make additional calls just because you might need extra information. And this is a disease that is not so treatable in terms of REST APIs or in terms of APIs when you do not have the time to stay and design and constantly design and take care of your API. So what is overfetching? You get more data. No matter what is the scenario, you get and you will get more data. How you can solve this? Continuously designing and trimming the API. If you're lucky enough to have the time, or if you're lucky enough to have control over the client app. I mean, not all the teams have control over their customer APIs. They write the APIs, publicly expose those, and leave other teams to consume them. So they do not have ownership in terms of Angular app or React or Vue.js or whatever JS is written on the client side. So you just create an API, you expose that, and leave others to consume it. So in some scenarios, you're not able to control this, to trim and design your API, because you might not even know who consumes your API. Maybe you have, I don't know, integrators. Think about GitHub, right? They have an API. They expose that API. You can leverage that, but they do not actually know who uses their API. So not having control over the customer app, they cannot control over fetching. And in terms of underfetching, the second issue that REST APIs have, they will force you to make another call to get additional data. So once you have something, you'll need to go back and get additional things and maybe go back again and get something else. So if you look at a specific scenario, we might have a client that, I don't know, calls an API to get all the restaurants available, paged or not, but those restaurants will be returned as a collection to the client side. So once the client obtains the list of restaurants, then it's forced to go back again to the server side and get additional data. I mean, fetching a specific restaurant from there. And once the client receives that specific restaurant, it might need to get the reviews for that. Maybe it's a client app, it's a mobile app, or maybe it's an Angular app. But these requests need to be made because you need the reviews, and you kind of can't bring everything together in one call. And even so, if the server evolves and the client app evolves, you might not know which fields from those responses are really used. So these are the major problems of the REST APIs. And as I like to call them REST-ish API, almost fully use HTTP. There is no HOS, no hypermedia there because, well, we consider that it harms performance. The usage of headers is like, well, the minimum, the default, and everything what is in there. Restore space in terms of endpoints, it depends. Bad naming, yes, is there. Bad naming for the resources. Often junior developers, for example, confuse accept versus content type header. And self-descriptive messages, maybe, but not to the extent that it should be. in order that API to be fully REST. And status codes, well, 404, the most common ones. But let's face it, most of us did that. And most of us still do that. Because of the time pressure, not because of something else. But these are all the reasons that you should take a look at GraphQL. We already know REST API is old and it has issues and it's very hard to maintain and maybe trim, and there are specific scenarios where you cannot treat those diseases. And it might worth a look because in a way it solves a lot of problems, and we will see what are these problems. So what is GraphQL? Well, GraphQL is a query language, a specification, in fact, that solves and treats REST APIs of their diseases. What it does is that, well, will bring you exactly what you need. You just need to tell GraphQL endpoint to bring you what you need, and those exactly fields will be sent back to you. Who uses GraphQL and why all the hype? Well, first of all, Facebook, GitHub, Yelp, KLM, PayPal. These are major players that use GraphQL. First of all, there are others like Airbnb, Atlassian, and big giants in the industry. And what it does, GraphQL, and what they solved by using GraphQL is that, well, overfetching and underfetching are not there anymore. Exact fetching, the specific, the good scenario is there. So why the hype? Well, first of all, it enables the clients, the consumers of the API, to specify exactly what data is needed. And by specifying that, it allows you to aggregate data from multiple sources. And you can also do that. Issue a request and get three responses, or responses from three places at once, which is very powerful. Think about, in a way, you solved three separate requests that would have traveled over the HTTP, over the network. And from all the three requests you got back, maybe you don't need to use all the fields. So this is major in terms of performance. Think about how many gigabytes or megabytes of data you save to the people that are could use your app from a mobile device. I mean, data is expensive in some countries. So what it solves? We have here an example for a conference. We have speakers, and we have speakers by ID, and maybe we will need to have speakers by ID and see all the talks of that speaker. So if we compare GraphQL to REST, we will have just one verb, post in our case. We can have headers, but media types and status codes? Nope. We do not have such a thing. So post as verb and headers, whatever we need. That's it in GraphQL. So let's take an example. If we have speakers, and from that speakers array list, we need only the highlighted ones. I cannot move to highlight this. Okay, so here. So we will need only the company name, and the last name of the speaker, and the first name, and maybe the Twitter handle. So in a REST scenario, all the other properties that are not highlighted would just be, I don't know, data over the network, and that's it, because the client app won't use those. So what we get back by calling with GraphQL is exactly what we need. And for example, if we have the endpoint, speaker talks, the third call that we make, we might need only the description, the title, and the speaker. And more than that, from the speaker, we need only the first name. So I do not care about the Twitter handle or whatever description that speaker might have. This is all that I need from the API. So by using GraphQL, I'm able to specify that. So, okay, this is an introduction to GraphQL, but the building blocks of GraphQL are just 3. So first of all, we have a schema. That is a general framework for everything we will build on top of GraphQL. So a schema is something that we specify, and a schema can contain queries. And those queries are defined by us. It allows us to get data from whatever the need it is. So query, get data. It might be similar with a get, but in fact it won't be a get request. It will be a post. We can have queries and we can have mutations. And a mutation is nothing else than the rest of the create, read, update, and delete. It can be an add, it can be an update, it can be a delete for specific data. More than that, we can have subscription, and by subscription, we can subscribe to events that we're defining on the server side in order to have the clients notified whenever something happens. Okay, so these are the 3 blocks of GraphQL, and down into the core, we have fields that we need to specify for each entity we need to return to the client, and we have resolvers. Resolvers are the ones that tell GraphQL how to fetch data from the database to send from the client and maps in a specific way to the queries or the mutations. And after resolvers, we have types that we define separately in our API. So having these building blocks, we will look at them in particular. So querying. What is a query as a concept in GraphQL? So a query is absolutely everything that can be questioned from the outside. It can have headers, and if you have a specific scenario where you need to define and run multiple queries in parallel, you can also do that with one request to the GraphQL endpoint. Okay, so let's have a short look. How a query looks. Well, the request for querying something in GraphQL will look like this. We'll start with the query term, and then if you look at it, it's in a way similar to JSON, which makes it very familiar for us. So let's say I need to get the speakers, and from the speakers, I need to get only the company name, last name, and first name, and maybe, I don't know, the Twitter handle. So these are the only 4 properties I will need for each speaker I have in the database. So this is a representation, exactly as in REST, but it doesn't matter if I have, I don't know, 20 property in my speaker object inside the API. I need only these 4. And by issuing the request in GraphQL, I will get back an array of speakers. And for each speaker, I will have only these 4 properties I need, right? So this is a speaker object. You'll see here for brevity. And in fact, here and here, it's an array. So it's very similar to what we have been getting back from by calling a REST API, with the exception that everything that I specified is returned, and nothing more, nothing less, all in one query. Okay, so this is a generic for a collection, but let's have a look of how it looks when we need to query something by ID. So if in REST we would have had this, talks, ID2, and the speaker, now we will have pretty much the same thing, but we'll specify a parameter with the value that we need to match this. And then we'll have something like this. I need for each talk the description, the title, and the speaker, but not the speaker in its entirety, because it might have, I don't know, 10 fields. I need only the last name because this suits my business scenario. What I get back is a talk object with only the fields that I specified. Description, title, the speaker, and from the speaker, only the last name. Okay? So this is the response I get back by calling something with a parameter. Talk with the ID 2. It's very easy to use, is intuitive, and we'll see in a demo how it looks further. But by querying data is not enough. We often have scenarios where we need to create something to fit our business needs. And when we need to create or update or delete something, then we will look at something that is called mutation. A mutation is the second building block of GraphQL that allows us to send or delete or update data on the server side. So basically, a mutation replaces the post, an update, and a delete. It can have headers, and it can only be run one by one. And what you need to do is to define in your .NET GraphQL API the input type for it. So a mutation, unlike the query, is defined with the keyword mutation. It can have a parameter. In our case, is a talk of defined as the name of talk input, and it also has a name that I specified. So talk input, and this is a variable that is defined further in my my query. So when creating a talk, I'm passing basically to the server these variable that I create, and as a response to this create, I need only the title, the description, and the speaker ID. And as a result, I can get back something like this. So it's a talk object with only the title, description, and the speaker ID that I requested. But bear in mind that I actually sent something to the server, a talk object we will see implemented in a short time. And pretty much that's it. We have building blocks, query and mutation, and next we need to talk about subscriptions. So we won't dig into details in this, but you need to be aware of it. So what happens in a subscription is that you have a GraphQL API, and you have several clients, and those clients will be notified whenever something is happening in your API. For example, a new object is created, your client will be notified. Okay, enough with the talk about GraphQL in general. Let's talk about GraphQL in .NET. So what are the steps you need to do in order to have something up and running? So, well, installing a few packages might do the job. First package you need to install is GraphQL, and then the transport for ASP.NET Core, and then something that is called a playground. Is nothing else than a graphical interface that is pretty and it has autocomplete in order to allow you to work better and to query and to mutate things on the server side. After all the installation is done, you will need to add middlewares for GraphQL. You need to create the schema, create and resolve the queries, resolve mutation if you have, and then you're done. Well, you're not done. Just because, as you will see, there are a lot of steps you need to do in order to have something that is up and running and it actually responds to the client needs. Okay, what we have here is a snapshot of that graphical interface I told you about, and we'll dig deeper into it. So what do you need to define? After all the installation, the setup is done, you need to define your graph entities, every available query, every mutation, schema and mutation, and this will be done field by field. So you need to take your domain objects, go there, and redefine them specifically for GraphQL. So how a schema looks like? Well, a schema is a simple class. You can call it whatever you want, but it needs to inherit the schema that comes from those .NET packages. The schema has I-dependency resolver, and then for each of the building blocks, you need to tell the schema how it will resolve everything you have in there. So if you have a query, you will have, in my case, I have a conference query that contains everything that I want to expose to the outside world with the names and fields that I want to be able to be queried. And in the same manner, if you have mutations, you need to say, okay, I have a mutation, and in order to resolve that mutation, you need to go to this class to find something in there. And similar, if you would have had subscriptions, you would need to go here and say, okay, here's a subscription, and here's the resolver for it. Okay? Nothing fancy so far. You just need to wire things up. And then, after everything is wired up, you need to go to your individual entities and say, okay, I have something that I call speaker object for GraphQL. And in order to be able to expose that speaker, you will need to inherit from object graph type of T. And that T is nothing else than your domain entity. It's basically a simple class generated by the entity framework in my case. And then what you need to do is go field by field in your speaker class and write something like this. Field T first name, blah, 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 which it does is basically exposing these properties, right? So these properties come from here, from the speaker that you have in the database. You can add a description because this description can easily help the ones that are using your GraphQL endpoint to discover and to understand what it's in there. What's the position? Well, how that person stays in the chair? No, is the position in the company, like job description, okay? So if you do not want to expose something like first name, maybe you do not want to do that, you simply won't define it in your return type. And that's it. Okay. On to the conference query, because we need to define and see how a query actually looks like. Well, a conference query class is nothing else than simple class that has everything that it uses, right? So we have here repositories, as we know, they're simple repositories. We have services if we need to have services, but then is where the actual magic happens. So in here, you need to define a field. You need to tell that field, okay, this is a list graph type, so this will return a list of something, and that something will be the speaker type that we defined previously in our slide. Also, in order to for a user to be able to find and identify your queries, you'll need to have to give it a name, because if you do not give it a name, it won't work. And also, this is the name that you will use in the interface. Of course, a description, and after the description, you have the resolve. So what it means in this context is means that, okay, how do I resolve this query if someone calls speakers? What do I do to get data for that query? Well, you go to the speaker repository and you get all. So this is nothing fancy. You just call the repository in order to bring data, okay? For that, this is the query. So for each query we need to expose, we need to do something like this. Give it a name or parameter and tell it how it will be resolved, either by calling a service, either by calling a repository, either way. You need to tell it how to identify and get data. Okay, talking about mutations, well, in a similar manner, but of course, what it needs, give it a name, and this is the name that will actually be used in order to send something. Very intuitive, create talk. In our case, we will have argument, and the argument will be talk, and the talk will be something of a talk input that we defined. And also, you need to tell this mutation how to resolve. So first of all, you need to tell it, okay, from that argument, get entities from that object, And what do? Well, you call the database and add that specific object that I sent. Of course, you will need to add some validation, and you can also do that like in here. I didn't add it, but you can do that. And for each operation that normally in the REST API would have used post or whatever verb you need to get in here and create a mutation by giving it a name. Some might say, well, this is kind of soapish. It kind of is, but it does the job, and it solves a lot of scenarios. Okay, enough with the talk. Let's look at the code. So let me show you here what I have. I hope it's big enough. So what I basically have a simple API. I called it GraphQL API, and I have another API that is called Feedback API. What it does is I have a data that contains my repositories, DB context, initial seed, repositories that are very simple and dumb, nothing special about them. But I split this way just to show you that we can actually reuse existing data. Okay, inside our GraphQL API, we need to look a bit at the packages, right? So in here, we have those packages installed, transport, playgrounds, and of course, GraphQL. So those are the things that we will need in here. By looking at the startup class, we'll go here and, of course, DI, whatever we need to DI in here. We have the conference schema added. And in order to enable GraphQL, you need to just use the middleware. Services, add GraphQL, and then graph types, and so on. And more than that, there is the section in configure where you define okay, this is my schema. Use GraphQL with this schema. And also I added two options in order to show you that there are different visualization of it, but nothing stops you of using Postman. Okay, so digging deeper into the structure, as you see, my controllers folder is empty, so we do not have any controllers. But inside the GraphQL, we have the conference schema. That is exactly what I showed you in the slides. So this is the schema, and the schema contains query and mutations, and each one of those can be resolved by using these classes. And by looking at these classes in query, we will see that it's nothing more than something that has injected the services that I need, the repositories, and so on. But it has the queries that are available from the outside. So by being available, it means I am able to call speakers and get everything in there. So I have speakers, talks, feedbacks, and so on. Okay, let's see in here. This is an option of using GraphQL. You will see that this is called playground. It's darker as a color, but you can have in here whatever you need. And there is the other option that is lighter called graphical. So you can choose whatever suits your needs or what you prefer. By having in here, I will do some queries. As you'll see, the endpoint that it calls is this, GraphQL as an endpoint. I do not have any controllers to call. And as I mentioned, the queries looks like this. You specify the keyword query, and there is something similar to JSON. And then if you control space, you'll be able to see what are all your options. And you'll see I have something that is related to speakers. Okay, let's select that. But if I run, I will get an error telling me that the field of speakers might have a sub-selection. So speakers is a query that I named inside my API. And here it is. So the name, and because I give it that name and I told it how to resolve that, now I'm able to subquery it. And here I have all the fields that I'm able to query. For example, I will select description, and then I select first name, and I will click prettify to arrange this. And by running it, what I get back is a list of speakers, 1, 2, 3, 4, with only the fields that I need. Description, first name. So if I need the last name also, I can go ahead and add that in here, and I will get back. Okay, so array of exactly the things that I need. Also, if I remove this and I say, okay, now I want the talks. And because I need 2 talks, I need the description for the talks, and only the description. And by running it, I will get the talks description. Okay. Another things that I showed you is talks for a speaker. Okay, so talks for a speaker. This is parameters. It has a parameter, and it will suggest me, okay, you have an ID. So if you have an ID, give that ID value. So I will give it a value because I know that 2 is a speaker here. And if I try to run it, it won't run because I didn't specify what to bring me back from the server. So talks for a speaker. I need the description, and I also need the title. And I run that, and you see I get back the description and the title for my talks. And also something else. This is an JSON object that has a name, and that name is specifically my query. Okay, so this is pretty simple, easy to use. But let's have a little short look in our types. Okay, we got how we stitch things together, but let's look at the speaker object. So the speaker object inherits from object graph type of T, and T is exactly that object that is familiar to us, generated by entity framework. So this is my entity, domain entity, if we can call it that way. So we specify the fields in here that we need to expose. Okay, this is for 1, this is for the talks. Okay, field description. And here it gives me the ability to query even further. For example, for talks, I need to be able to get back feedbacks. And feedbacks is nothing more than a second API that I have in here. And it's running in the console, right? It gets all the feedbacks. So server to server, when someone calls feedbacks inside GraphQL, what it will do is we'll call my feedback server and we'll get everything in one go. And let's do that to see how it goes. So I said, okay, we have talks, and we need to get the description and see if everything is in there. Okay, but not only the description, we need to get the feedbacks. But if you run it in here, feedbacks is a complex object that we need to specify. Okay, I need the comments. Okay, so in a way, I did a subquery. I have the description for the talk, and I have the feedbacks with comments for every single one of them. And for this, I have no feedbacks, and I will have an empty array. So basically what I did was to aggregate layers. And by aggregating layers, it gives me the power to create something, an extra layer for my APIs. Say I have a GraphQL API and I have, 40 other microservices behind them that will be aggregated in my GraphQL. Okay. Something else, because I didn't show you. I need to show you how a mutation looks. Well, a mutation is nothing else. It's in a similar manner. I have here variables that I am able to use. And I will add something for brevity. It's nothing else than a JSON object with properties. Bond1, James1. And I will run this. And as you see, I got back what I requested. Even though, sent on the server side, I have this. All these fields, and I can show you speakers. This is the object that I created. Okay, so it works. But in order for that to work, the things get complicated on the server side because there is a lot of work and it's kind of tedious. I need to define input types. Speaker. Okay. So for each thing that I want to send back to the server, I need to define an input. So input that inherits input object graph type. You will give it a name, and then you go again field by field, and as a parameter, it will be a string that will map to your entity. So I have a simple scenario, but imagine if you would do this for a very complex scenario. It would take a lot of time. But it works. And for the mutations, as it looks, it's pretty much the same thing, except the fact that you kind of get back to the soapish thing, create talk. It's not discoverable. It's discoverable, but only if you use the graphical tool. By using Postman, you can also use Postman. You can do this. And I see talks. You see the endpoint that I'm using is GraphQL, and I'm using Post for everything. And description. And I will be able to run it, and I get back only the description. So there is no need to use something that is visual. You can use Postman, but it is a bit of a learning curve because you do not have that introspection that gives you the ability to see, okay, what's available now for me? What can I query more? Okay. So that being said, GraphQL is kind of awesome. But it's awesome in scenarios where you need to defer the understanding of the domain or you do not care who the consumer is. It's easy to get started. It has that built-in introspection and the graphical tools. It's friendly. It's very friendly because it's super similar with JSON and it's contract-driven. And those playgrounds are super useful. Okay, this is awesome. I mean, you do not need to read any documentation. You will just explore your GraphQL by using the playground or graphical, or why not Postman, just by trying stuff. But the real power of GraphQL is that client performance is first. I mean, it saves bandwidth, it does exact fetching, and you have less round trips. And it's a wonderful experience for API consumers. Think about scenarios where we host things in cloud. Getting things from cloud costs money. So if you minimize round trips and minimize data transfer just by using a tool, a piece of tech, I think this is powerful. Think about Facebook. I mean, all the things that we're scrolling down in there and looking at. Wouldn't be possible. I mean, it would, but not without a lot of tremendous work. I mean, you have news, you have ads, you have friends, you have stories, and all of those are brought together at once. And I think it's the best example of where GraphQL comes into the scene and how powerful it is. So when to use it? It depends. When you have a small project and you just want to play, when you have complex projects, and if you really want to have an aggregation layer on top of your existing APIs, and when you care about consumer bandwidth, or when you do not control the client app and you want to empower your consumer. But the problem is GraphQL better than REST? It depends. If you have a specific scenario and you're willing to give the control to the client, well, yes, it's okay. But how about querying the database? It will save you performance stuff. Nope, it won't. You'll need to fine-tune everything yourself. Bear in mind that GraphQL doesn't reach the database. It reaches the server and gets you back the data that you went to database and brought to the server. So basically what it touches only the server side, not going further to the database. From the server side to the database, it's your job to fine-tune everything to have performance. Problems. single endpoint, only post requests. Well, and you kind of need to forget everything about HTTP because you won't have caching. Okay, they try to solve caching with different things by using data loader to solve N+1 problem, but it's not enough. I mean, caching headers were there in order for us to help us or to increase the perceived performance. But think about it. The name that you define and the server side, you're not doing anything than to cache in memory by creating dictionary with responses and by searching that dictionaries with responses. And in summary, GraphQL is a new tool for our toolbox. Do not go there and say, okay, this is cool, this will save me a lot of trouble, I'm going to go and implement everything with GraphQL. Indeed, anything that can issue an HTTP request can consume a GraphQL API without any issue. Because you see, as you saw, there is Postman, post requests. And because it leverages only post as a verb and the single endpoint, it's not easy to follow. Without that visual representation, you won't have anything. You have no caching using headers, but it gives you a lot of flexibility and is super suitable for aggregation layers in case you need those. But you need to be aware of technology in order to be able to discern when it's okay or not. Okay? A few resources, I will make these available afterwards. You should go and have a look at hotchocolate.io. That's a friend of mine that does a different implementation of GraphQL. And also, you need to be aware that there is an initiative to make GraphQL over HTTP by using verbs. It's not standard yet, by using verbs and leveraging status codes and headers and everything that we were used to from the REST world. So there is no server bullet, neither gRPC, neither GraphQL, neither REST. Choose the right tech for your specific problem. And in order to do that, you need to know what's available and what are the downsides or the drawbacks of picking something or something else. I think I'm out of time. Thank you. I will get back to YouTube on the chat to answer if there are any questions, or you can DM me on Twitter. Thank you. It was nice to be here. See you.
Okay, we're back again, and thank you, Irina, for this excellent talk on GraphQL. And now for the next speaker in line, Daniel Costea. This is probably the first and probably also the last time I will introduce a talk on a .NET conference inspired on a 19th century German philosopher, but I'm very curious of what this is going to bring. Daniel, I believe you're doing a lot of things in Romania. We are also trying to do over here in the Netherlands with the .NET user group, organizing all kinds of conferences, and transferring knowledge is the core to what you're doing. So I'm very curious and anxious to see what you're bringing us. So take it away.
Thank you. I'm a senior .NET developer, and in my day life, I'm happy to work with .NET Core technologies almost exclusively. That's why I'm calling me lucky. And I recently got Microsoft MVP award on developer technologies. In the left time, I like to play with IoT and machine learning, and to contribute to open source projects on GitHub. We as developers have to keep an eye on the future, because the new programming paradigms are going to change the way we code. Just to take a look on C# language, which started primarily as an object-oriented language, and how it embraced some other paradigms like functional programming in the latest major iterations. I'm talking about machine learning paradigm. Traditional programming is all about getting input data, apply some rules on that data in order to come up with an output as an answer. On the other hand, in machine learning paradigm, the data and the answers, or labels if you like, go in as input, and the learned rules come out as an output. Isn't it wonderful? We are so into this, we don't even realize it. We put our intelligence in code, and that's pretty static, pretty rigid. Why not rely on the machines to create intelligence? In the end, is not this more human? Coding or teaching, if you like, is not more human than learning is. Failing, succeeding, and repeating until we learn the rules. And this is not static at all. We as developers have to be prepared for this new paradigm because it will change the way we code. Let's be prepared. But why this talk? Disclaimer, I'm not a data scientist. When I first have to deal with machine learning, I soon realized finding the right trainer for building the model is not the hardest part. As a proof, very soon automated ML was released. The hardest part is to get everything ready for building the model, and that's data. Because machine learning is as good as its data, that means bad data set drives to a bad machine learning model. Therefore, a good data set is better than a smart algorithm. In other words, your model cannot be better than your data. So be very careful when you are preparing the data, because you are encoding in the DNA of the data, your biases. Well, we are .NET developers. So what's in this machine learning for us? Is Microsoft ML.NET another framework? When thinking of data science and machine learning, Python programming language is making the rules. We know that. In addition to that, the existing frameworks like TensorFlow, Keras, Torch, CoreML, CNTK, you name it, are not easy to integrate with .NET projects. So worry no more, ML.NET is designed for .NET developers. And as a .NET developer, you have access to entire life cycle of a machine learning model. You can prepare data, train your model, validate, evaluate, and in the end, consume the model. Let's see the ML.NET architecture. From bottom up, ML.NET supports x64 and x86. I'm very curious when support for ARM will be released because I'm, as I said, working with IoT, with Raspberry Pi, and I would like to see this on IoT devices as well. But I was told it will be soon. ML.NET is built upon .NET Core and .NET Standard, therefore inheriting the ability to run on Linux, macOS, and Windows as well, of course. And is designed as an extensible platform, therefore you can consume models created with other popular ML frameworks like TensorFlow, Onyx, CNTK. Microsoft ML.NET is more than machine learning. It includes deep learning and probabilistics, and you have access to a large variety of machine learning scenarios like image classification, object detection, which are deep learning. What about the tools? We have a full arsenal here. Is the API, primarily used by .NET developers, but we have the CLI, which is very good for DevOps. And we have a UI model builder, which is good for breaking the ice. Well, let's take a look on the ML flow. For example, it's loading data, visualize, analyze, then prepare the data, in the end predicting data. And let's start with loading the data. Well, let's take a look on the data, on the anatomy of a data set. And notice here, we have some columns which are called features, but because not all the features are born equal, we have one which is more important, and that's the label or the target feature. This feature is used to mark reading an observation with a label to give the meaning for those data. What we have here is a data set for multi-classification, and we are trying to predict some classes, some categories. So we have first to label this data. We are not talking now about this labeling process, which is very time-consuming. But since we have the data set ready, we can start by loading it into the memory. And for that, ML.NET allows us to use some alternatives like data loader from database or from text files, of course, from binary files, images, and even from in-memory, enumerable collections. But since we have the data, we want to visualize. In ML.NET, the native object to keep the data, it's data view. A data view, it's a data set represented in memory, like a table with rows and columns, pretty much similar to a SQL view, but pretty much similar to an enumerable because it's lazy loaded. Let's not forget, at the end, all these machine learning entities like transformers, loaders, trainers, estimators, predictors are all working with data views. So, a few details about this data view. It's lazy evaluated. It's in-memory, immutable, so you don't have to worry about modifying the data. It's cursorable and heterogeneous. Another thing, it's schematized. So we have the schema with this data. The columns have names, type, and annotations. And it's composable. And that's maybe the best part. New data views are formed by applying transformations on the other views. We have here an example of loading data from a CSV data file. But another alternative in analyzing, in visualizing the data is data frame. What's data frame? Data frame is very new. It's part of Microsoft Data Analysis. It's an in-memory representation of structured data and is stored as a collection of columns and rows. What do we need this? Because it offers flexibility in browsing the data, in doing transformations on data. This is actually similar to Python pandas. Data frame, for example, exposes APIs like operations, computations, joins, merges, and we are able to prepare the data for the building the model. Once the data is ready, we can convert it to collections. We will see later how this data frame works and how it can be used to see the data. But why do we really need this data frame? Because we can easily see how many observations we have, how many features, the data types, if the features are numerical or categorical, and which is the label feature. The data set can be used for various scenarios. In our case, we will use for multi-classification, but we can use for regression if we choose another label to predict, for example, a value, a numerical value. So, being able to see the data, we can decide if the columns make sense for our scenario, if the values make sense, if the scale is right, or if we have missing values, which can be a big problem. This is how it looks, but we will see later in our demo. And let's see how we can switch from data frame to data view. I have mentioned before, but now I have a visual representation. So we can load the data either in a data view or a data frame, and later to convert in an enumerable and read in data view, because at the end, we need the data to be in a data view in order to build a model. We have another way to take on to get a snapshot on the data, and that's the preview mode. So we can call preview method on a data view, but that's not recommended for production. and I find data frame more useful for what we need. And let me introduce Jupyter Notebooks. Maybe you have already heard about Jupyter Notebooks from Python World. Jupyter Notebooks is an excellent read-eval print loop toolkit, which is now available for .NET. I say .NET because it's C#, F#, or PowerShell. So let's say we are now able to play with the data using the Jupyter Notebooks, and that's wonderful. Well, in Jupyter Notebooks, we can use some special commands for loading the dependencies, for looking at the data, and we can send the data to print the data. But it's not only something like console write line. It's a much more tool. It's we are able to see the data as, for example, as HTML using the Pocket View API. Think about Pocket View API like a razor. But we are not relying on the Razor engine. So we can write our code in C# and that it's rendered to HTML text. And we have Xplot, which is a data visualization library, which prints text, HTML, SVN, and charts. Let me introduce now the demo scenario, which I have used. We have a system where we are reading a few values from the sensors. For example, temperature, luminosity, infrared, distance, and the time when we have created the reading. These are features. And we have another feature, which is a special kind of feature. It's target feature named source. The source can be a flashlight or a lighter or the daylight or infrared, which better describes our reading. These are the categories we are trying to predict. Of course, first we have to acquire this data set, labeling the readings, train the model, and then later to predict the values. I have did already this data set. I have created this data set. So now for our demo, we will only use it. Let's take a look on this. And first, let me introduce the Jupyter Notebooks platform. We have here a very interactive way of mixing code with descriptions and with charts. Jupyter Notebooks consists of cells. Some cells are code cells, other cells are markdown cells. So we can keep running one by one these cells in any sequence we want and see interactively what happens. For example, now I have loaded Microsoft ML, which is the library for ML.NET. Of course, we already have some other libraries loaded. It's a meta package which is already loaded with the Jupyter Notebooks for .NET. And having this, we need to load some classes which are our entities. For example, I'm keeping these entities in a models.csx. This is a C# script file, but let me show you how it looks. It's C#, of course, but it does not support namespaces, for example. I hope this is only for now, because if I able to put here namespace, I can reuse this class for my Visual Studio project. Otherwise, I have to keep 2 copies of these entities. But soon, I was told it's soon. Then I'm loading the ML.NET context. I will not get into too much details on how to work with ML.NET because it's not the scope of this talk. The scope of this talk is to exemplify the way we are analyzing the data and the ways we are preparing the data. So let's load the data set, then build the model, and then evaluate in order to get some metrics about the quality of the model. Let's see what's the accuracy. Accuracy of this model is now 9267. It's not bad, I have to agree, but we can do more. This model is built without too much effort. I have just choose some features which make sense for my scenario, and trainer for multi-classification from the ML context catalog. And that's it. I have resumed to this because first I want to see what I have and then to try to improve. So I get 92.76% accuracy. I have even a prediction here, but now I'm interested in this quality metric. And let's visualize the data. So I will run again. Soon I hope we will be able to include notebook sessions in another notebook session, but that's soon, I was told. And let's load the data. We can see here the data, but it's not very useful way of looking over the data because it's limited to the first, I don't know, skip some records, take some other records. So it's limited. But let me present you the data frame. Data frame, it's a better fit to analyze the data, to visualize the data. And if we are planning to, let me skip this code because I will tell you in a bit what's this. Let's load the data frame, and this is our data. It's ugly, I have to agree. We can do better arranging this. But in fact, this is raw information of collections of columns and collections of rows. But we don't like this at least not presented in this way. So we can do better. For example, we can use an object formatter which is intercepting an object when we are trying to displaying it, and it's arranging the data and show it. Let me show it. Now it looks much better, and with a little effort injecting here some JavaScript code, I have managed to make it even browsable, so we can go easily from one end to another and to see how our data look. But that's not all, of course. We can modify this data, and at the end we can convert it in a data view. Let's go back to the demo, to the presentation, and let's see how we can analyze the data, because the data is huge. The larger the data, the larger the chaos. So we have to aggregate data in order to get the meaning from it. So let's review, let's revisit the flow. We are loading the data in a data view, split the data in testing data and training data, create an enumerable, and then visualize. For example, for numerical features, we can use numerical distribution chart. For categorical distribution, we can use another kind of chart, but we will see them in a bit. For example, numerical distribution, it's numbers. We can see in this chart where are values located. It's a range, of course, between, in our case, between 0 and 160. But as you can see, the most values are at the beginning of this range. It's good to see this in order to get some conclusions. What is the range of our data? What is the distribution? How our data looks. For categorical features, it's not about numbers, it's categories. So we can see this distribution in an interactive way. We will see in a bit in Jupyter Notebooks. So we can see simply how many readings we have for a flashlight, how many readings for a day, for lighter, for infrared. In this way, we can see if the distribution is calibrated, is balanced. If we have too many in some, in just a few in some other categories, we might want to consider to merge some of them if it makes sense. Then we have box plot segmentation, which is very good to see how is these distributed features, how are these distributed features relating to each other. We can see easily in our diagram the distance, it's a larger range. Hour of day is a low range, temperature is a low range. We have a lot of outliers here for temperature, but mostly it's a low range. And we realize very soon the impact of these features will not be equal on the quality of our model. And we have another kind of chart. I like this more because it's telling us how are the features correlated with our features. And we might want to reduce the dimensionality of our data set by removing some features. How we can do that? For example, watching these correlation metrics, we can get to the conclusion. Two features are very highly correlated. Then that's kind of redundant to keep them both. So we can decide to remove one, and therefore we can reduce the dimensionality. Okay, let's go further and see the interpretation of these correlation metrics. Near -1 and 1, it indicates a strong relationship. Closer to 0 indicates a weak relationship or 0, no relationship. And that's telling us if we can get rid of some features. Let's analyze the data. Let's load the models, the data set. Let's split the data into training and testing data set. Let's extract the values for each feature. And let's see some numerical distributions. If we are looking at all these features together, it's confusing, but let's disable and look to them one by one. So we can see here the temperature, but we can see the luminosity, and we can simply analyze the data by numerical distribution. Then we have categorical distribution. And we can see if our data set is balanced. We have 240 readings for flashlight and only 105 for infrared. It's not bad. Could be worse. What happens if we have too little? We have to get more data for the data set. And this is the box plot segmentation, where we can see how is the data distributed for every single feature. And now the correlation metrics. Let's take a look on luminosity and temperature. For example, the luminosity and temperature are not correlated. I don't have a highly correlated feature, but let's suppose we have one with almost 1 or almost -1. -1 means the features are highly correlated, but in inverse relationship. So let's suppose we have one of these. We can decide to simply remove one. So far, I think you realize you don't have to be a data scientist. We can simply rely on what we see and on some numbers to decide what features are good for us, or if we need more data, or if our data is not good enough. But now let's prepare the data. Preparing the data, we have to be very careful and to invest the needed time preparing the data, because if you decide to save time preparing the data, do not be surprised if you have to pay the price later. I like to call this data preparation debt, like technical debt. Be careful on it. So we can filter the data to see if we have duplicates, for example. We can see that using data frame to see if we have irrelevant data or structural errors or typos. For example, we might have two categories. For example, Netherlands and Netherlands. Obviously, it's the same category, but it's a typo there, and we might have to align this. Well, what about the experimental errors and the outliers? Outliers are not necessarily bad, but it's us to decide if they are bad or not. For example, having this scenario, I'm reading the luminosity from a sensor, and I know the luminosity has to be between 0 and 100. If I'm getting their values larger than 100, then it's a reading error. And in IoT, this is not very unexpected. So it's me to decide to limit the upper value to 100. For example, I might want to replace all the values above 100 to 100. Well, having the data set, let's presume our data set is ready, but the data is not yet cleaned. We have to remove the bad data, and the left data has to be split in two. Usually it's a ratio like 4:1 in the favor of training data. So the testing data, it's kept away. It's not used for anything in our model builder. It's just kept away for testing the quality of the model later. Well, let's take a look on the machine learning pipeline to have the big picture here. So we get the training data, put the data in the pipeline, obtain a model, and then we can use the training data in order to measure the quality of the model using, for example, cross-validate. There are more ways of validating the data, but the cross-validate is very, very common. So doing the validation, we are able to see the quality, the numbers of our model. And we have another way of measuring the quality of the model by evaluating the model. For that one, we have to rely on testing data set, and we can do in more ways, for example, to simply evaluate, but we can do using the permutation feature importance, which is another technique to measure the importance of a feature. Let's see this a little bit later. And of course, we can read this in some charts. But let's get into some details. Model validation. Well, cross-validation partitions the data into a number of equal partitions, for example, 5 or 10, and the results for each partition is a train test dataset object. A model is trained on each of these partitions, and using the specified machine learning algorithm estimator on this training data set. And then we get some metrics and we do an average. In that way, we know the validation accuracy. We can compare later with other model versions and decide which one is better. And this is how it looks. We have a macro accuracy, a micro accuracy, logarithmic loss, and logarithmic loss reduction this is per class. What about permutation performance? Permutation feature importance. We can measure this and decide if one of our features is not bringing value. And we can decide to simply remove it. In our scenario, it's very clear temperature and luminosity are having the greatest impact. Infrared a little, but then distance, hour and day, we can simply remove if it will not have a great impact on the model quality. But why is that? Why is that, for example, hour and day not bringing value to our model? Well, it's maybe because when I have read the values from my IoT device, the hour of the day or the day of the year simply did not change anything. But for example, if I am to decide to do this outside in the winter, my values are simply giving some other meaning to the reading. I might decide to assign another label. So it's for our scenario, the hour and day are not bringing values. Let's evaluate the model. I usually made a confusion in between these two, validate and evaluate. But it's a very important and critical difference. The validation is done on the training data set and the evaluation is done against the testing data set. So having the model, we want to measure how it would perform in a real world scenario. That's testing data set. We have already the micro accuracy, macro accuracy, and the other. So we might be pretty familiar with this. And we can easily decide if our model is better or worse. For example, micro accuracy, the closer to 1, the better. The same with macro accuracy, but for logarithmic loss, the closer to 0 is the better. So we might want to follow these numbers, all of them. But let's say, which is the most important? In a multi-classification task, micro accuracy is preferable over macro accuracy because you might have many more examples in one class than another class, and the micro accuracy is capturing these. And then it's the confusion matrix. The confusion matrix, it's giving us a visual way of evaluating how the model is performing in real life. For example, using the testing data set, as I have mentioned before, we can make predictions and compare the predicted results to the actual results. For example, the flashlight is predicted as flashlight for 66 number of cases and as a daylight for one case and another case for lighter. That means it's not perfectly accurate, but it's 97% accurate. It missed in 2 cases. It's not bad, but we have get to use with this. In machine learning, we are not working with exact values. We have to sacrifice the accuracy for, let's say, for the benefits. For example, for the intuition which this machine learning is bringing us. We are using the machine learning to model the human intuition, for example. We are trying to learn, to extract a pattern but we're not expecting that pattern to be absolutely precise. But in the jungle, if you see a shadow fast approaching to you, it's pretty enough to know it's 86% is a tiger in order to run like hell. You don't want to be 100%, right? Okay, let's prepare the data. Let's see the demo for data preparation. And we have here something which I have used to improve my model. I have normalized the data because previously I have realized my data, my features are not calibrated. But normalizing these features one by one, I'm rescaling in between 0 and 1, for example. In that way, I can get something like this. All the features are now calibrated, and in this way, I can be sure the impact of every feature is equal on the model. Then, let's see the validation. Okay, so I'm calling cross-validate. Against the training data. It's taking a little bit longer because it's running the model builder with every single fold in the cross-folding. So we have 96. Okay, let us show this in a more user-friendly way. Okay, I didn't paste this in a friendlier way. Okay, we have here 0.96, the quality of our model. And then we have the permutation feature importance, but let's evaluate the model. The evaluation goes against the testing data set. We can see here the confusion metrics as well. And we get here 94% the accuracy. Let me show this in another example, which is cleaned up by all these measurements. But the pipeline is the same. So what do we have here comparing the first time we run this model builder? We have the custom mapping, which gets a date time and extracts the date and the hour. And then we have the normalization, which calibrates the features. And now let's measure this. So we have 95 instead of 92. Well, this is not yet the best because we didn't yet decided if we keep hour and day. We have realized the impact of the model quality. It's not good. It's not important. So we decided, for example, to simply remove this. Okay, let's run again, but this time without the date and day and hour. And we have 96. So we started with 92. We tried to add more features to prepare to re-engineer the features. Then we get to 95, but still we can get rid of some features which are not important, and we end up having 96. It's not bad. And I didn't try yet to try with another trainer, but it's fine. This is what we can do using the visualization and data preparation, using all these charts. The data prediction, it's I will stay only a few seconds on this. It's only about getting the model either by loading it from a previously saved version or by from memory, and predicting data using some input data and outputting some predictions. Well, we are closing to the end of this presentation, and I would like to offer here a lot of references if we want to jump on this machine learning. I think it's from my perspective, machine learning, it's a must to improve our horizon of .NET developers. And I want to tell you, I like a lot the roadmap of ML.NET, the past and the future. The ML.NET community is rising, and any contribution is very welcome. I think it's wonderful we can help the shaping of this framework. And of course, I hope these instruments will save your time and help you build a good machine learning model, starting with the data, of course. Thank you very much.
And we're back. And that was a very interesting session about Jupyter Notebooks. I am quite new to machine learning, so they look kind of powerful. I need to dive into that more. But the next session from Jonathan is about building your own API gateway, which is something which sounds like a lot of people need to do that. So
I don't know, but yeah, we'll see.
Well, welcome, Jonathan, and take it away.
All right, thank you very much. Thank you for that introduction as well. So yeah, what I'm gonna talk about in this session, I'll do a brief introduction of both myself and the company I work for. And then I'll dive into what is an API gateway in the first place. So why are we even talking about this? Then I'll discuss why we wanted one and why we thought that was a good idea. And then I'll dive into how we got started, how we set up our API gateway, and I'll dive into the code as well. And then I'm going to talk about some of the things we learned along the way as we tried to build this up. And then finally, I'm going to have a small sneak peek at something that's coming and that we're looking at right now as something that we might invest in the future. And then finally, I'll have some links to some resources on how you can get started with the stuff I showed you. So let me start with myself. So I'm Jonathan. I'm a solution architect at R&R Workforce Management. I officially started working there on the 1st of January of this year. But I've been actually consulting for them since probably 2011 something. So I know the company for quite a while now. I've been on and off there as a consultant, and now since 1st of January I'm actually working for them. But I have a lot of experience building software, mostly with .NET, and I have done various projects for different companies throughout my professional life. So, but what's R&R Workforce Management? Let's talk a little bit about that. So, we are a software as a service vendor located in Veenendaal in the Netherlands. We do workforce management, which basically means that we provide our customers with a product they can use to essentially plan their people as smartly as possible. So we have a lot of things to make it easier to plan staff. And we started out in the retail sector and mostly supermarkets. So you see a couple of our customers at the bottom. So Jumbo is a large supermarket chain here in the Netherlands. Edeka is a large one in Germany as well, and we're expanding into Europe at the moment. Plus is also a large customer for us. And we've also been expanding more into the hospitality sector. So we have an ice cream firm that is also using our product at the moment. So we have about 1,100 shops at the moment. So mostly those are supermarkets, but there are some others as well. And we get about 4 million requests per day on our platform. So we're doing some pretty heavy stuff, I guess. We have large databases and all that kind of stuff. So it's a very serious platform, and a lot of work has been put into that over the past couple of years. So this is a little bit of an architectural diagram of what our system looked like. This is a little older picture, but I think most of what's here is still there and it's still relevant. So we have the most important thing is basically the 5 colored boxes here, which are our core, provide the core capabilities of our product. And there's some stuff surrounding that to do interfaces with external partners and stuff like that. And so at the moment, all those servers are basically deployed on IIS, and our front-end application is talking to them. And that is something that's been bothering us for quite some time now. So that's why we came up with introducing an API gateway into this picture, basically. So what is an API gateway in the first place? So for me, at least, it's mostly about having that single entry point for clients. So you can have multiple different clients. So you could have a mobile client or a desktop client, or maybe even something else. But you want to have that single place where they can go and get their data, rather than having to know the endpoints of all the microservices that may be behind that gateway. So you get that single place where you can where traffic is basically flowing into your application landscape. And the most basic thing it can do is just route requests to downstream services. So a request gets to the API gateway, and that is then forwarded to something that's behind the gateway. But you can do additional things there as well. You can do things like protocol translation. So you could translate from a REST JSON-based communication mechanism to something like SOAP or something else. And you could do that in the API gateway. So the external clients have the still talk the same protocol, but then internally you can switch to something else, maybe even gRPC or something. You could also log incoming requests, for example, and you could perhaps use that to replay those requests on like a new version of the service you're trying to deploy, or various other stuff. And you can also do authentication and or authorization there as well. So that gets handled at the front gate, basically, rather than having to do it in each and every service that's downstream. So that's what an API gateway can do. Another topic that often comes up is called API management, which is similar, I guess, but it's a little bit different, at least for me, because when I think about API management, it's more about exposing APIs more as a product themselves. So rather than having your own front end and on top of your API, you're actually selling the API as a product itself. And usually API management products have things like exposing developer documentation, so people can easily get started using your API as well. And they also usually have something like API keys and throttling the requests that flow into your APIs. And you can even do things like throttling requests for specific API keys or specific customers that are using your API. So they are related, I guess, and there's some overlap there. But we were mostly worrying about the API gateway side of things, and we aren't actually exposing APIs currently to customers or anything. So that's why we mostly focused on the first part. So why did we want to introduce an API gateway in the first place? So the most important thing for us was we wanted to revamp our authentication and authorization systems. And currently we have that pretty much baked into each of the services that I showed you in the architecture diagram. So if we want to change that, we need to do a big bang release and release all those servers at the same time, because if you switch out the authentication, it's going to be hard to do that one service at a time, and because there is nothing in between, right? So that's our primary motivation for doing that. But we also wanted to have more flexibility in deployment patterns and doing things like blue-green deployments, canary releasing, A/B testing, and stuff like that. And it's also a lot easier to do if you have the gateway in place, because you can route traffic to different versions of your service, for example, which is kind of nice to be able to do. And one other thing that also drove this is that we want to enable having different technology stacks for the downstream services, so the services that are actually behind the API gateway. So we're currently thinking about moving from .NET Framework to .NET Core, which is something we can't currently do because that would require the authentication mechanism to be replaced. But once we have that API gateway in place, we can actually start transforming up downstream services to .NET Core one by one, rather than having to do them all at once. So that's our basic reason why we started doing this. So then the question was, of course, how are we going to do this? There's a couple of products out there that do this kind of thing. So you have MuleSoft and Apigee, and there's Kong as well. I've seen a demo of Kong a while back. Most of them are fairly expensive. I think Kong is actually open source and available for free, but if you want the good stuff, you have to pay anyway. So the core of it is open source, but there are some things you might want to add to that, and then it gets a paid product. And we were also fairly confident that they didn't have something that would allow us to still use our current authentication mechanism. Which we want to replace, but we need to provide that transition period. And we were fairly confident that those products didn't necessarily implement the mechanism we're using right now because it's fairly old and dated. So another thing we could have done is to use some kind of cloud service like Azure API Management or the AWS API Gateway or some of the other cloud vendors that have these kinds of products. And again, I think most of them wouldn't support our authentication mechanism, so that would be a challenge. But also our current production environment isn't necessarily born in the cloud, so it doesn't really make sense to put something that's running in the cloud in front of something that's running on-prem. So for now, at least, that didn't sound like a valid route for us anyway. So what we ended up is, then we need to build one ourselves, right? So, but building an API gateway is a lot of work, and we didn't want to spend too much time on this. So that's when we found an open source library called Ocelot, which is available on NuGet, and it provides a lot of the basic functionality you would need in an API gateway, and it just runs on top of ASP.NET Core. And then you can just focus on building the tricky things and only and do all the standard stuff that you get that from Ocelot. So we looked at that and we were like, okay, this is pretty cool. This can probably do what we want. So we only need to basically restore our custom authentication mechanism, plug that into ASP.NET Core somehow, and then we're off to the races. So what does that look like in practice? So on the left, we have our current situation. So we have the service, which runs on ASP.NET Web API, which is ASP.NET full framework. And then on top of that, we have we're using cookies. So we have some kind of cookie authentication handler that does all the authentication stuff. And that same handler is plugged into each of those services. So I'm only drawn 3 here, but there's actually like 7, 6, 8, or 8. I don't know. There's quite a few of them. So that's how it is currently. So what actually changes when we put that API gateway in place. So for now, at least, our downstream services will still use ASP.NET Web API on full framework. For the time being, but we're looking to enable that to go to ASP.NET Core. And then in the API gateway, we were going to build something new. So we wanted to use ASP.NET Core there rather than starting again with ASP.NET, even though Ocelot can run on ASP.NET full framework, but we didn't necessarily want to do that. So on top of that, we plugged in Ocelot. So that's not something we needed to build. And that provides all the routing capabilities and stuff like that. And then we have we need to re-implement the cookie authentication basically. So we already declared that as legacy because we want to get rid of it, but we need to have something in the meantime. And then we would need to have something that actually transfers the authentication information, so the security context basically, to the downstream service, because the downstream service will still need to do things like authorization. Which the API gateway cannot fully do at that level because it doesn't have all the information it needs to do the authorization checks. So, and then finally, we also needed some place to store our routes. So we need some way of configuring the gateway so that it knows, okay, this route is going to the downstream service. So we need to store that somewhere in a configuration file. So let's look at some code to see how we've set up the basics for the API gateway. Let me switch over to Visual Studio Code. This is our API gateway project. There's a couple of things here. So we have the API gateway itself. I've built an echo service, which basically just responds with the headers being sent to the downstream service, essentially, and it just replies them in the JSON body, so we can actually see the headers going to the downstream service, which is nice for testing and demoing and stuff like that. And then in here we have all the stuff for that legacy cookie authentication mechanism, which I won't bore you with because it's not very pretty code, but at least it works. Right now, let's have a look at the API gateway. So what's a little bit different here is that I've actually merged basically the startup CS and program CS you have with a regular ASP.NET Core app into a single file. I don't think there's actually it needs to be that way. It's just that was what was in the documentation for Ocelot, so that's what we started with. But I think you can just extract them out to separate files again if you want to. So in here we're using the host builder to start our application. Then we set up our configuration system. So this is just a regular ASP.NET configuration system that we're using, but we're extracting what's necessary for Ocelot to use into a separate JSON file, separate from the other configuration settings. And as you can see, for development, we're also reading a ocelot.development.json file so that we can include that into the JSON as well. So that's it for that. Then we configure the logging, which is just standard stuff. We're using Serialog as our logging framework here, but that's not really interesting. Then we have the configure services, which is what you normally put in your startup. And here we see that we do add Ocelot. So that's what adds all the necessary dependency injection services for Ocelot into the dependency injection container. We're passing in the configuration that we set up previously. And then we have a couple of delegating handlers, and we'll dive into those a little bit later on. But these are literally delegating handlers that you can inject into an HTTP client in .NET Core, and they allow you to transform the outgoing message before it's being sent to the downstream service, as well as transform the response into whatever you want to do. So we'll see a couple of these later on. And then we set up a course because we needed that as well. And then here we just use the authentication mechanism of ASP.NET Core. So we say add authentication, and then we have our legacy cookie authentication mechanism plugged in here so that just works. And then finally, we're also doing health checks so that we can check if the API gateway is up and running, that it can access whatever it needs to access. More on that later. And then in here, we're configuring the ASP.NET Core middleware pipeline. If you've seen the session by Steve, he dove into this quite a bit. But what's really, there's nothing fancy going on here except for this. This is where we actually plug in Ocelot into the middleware pipeline so that it can handle the requests coming into the API gateway and send them to the downstream service. Which is quite nice. So let's have a look at the configuration then. So this is our development JSON file. This is just for demoing and purposes. So Ocelot works with reroutes, although that has recently been renamed to routes. And this is essentially a route. So what you're saying is, okay, on the API gateway, if you go to this particular endpoint, then send that request to localhost port 5003 over HTTPS and send it to this path on the downstream service. And then you can configure additional things. So in this case, we're not doing any authentication for this particular request. So everything that gets sent to the API gateway is just being sent to the downstream service, and nothing fancy happens. If we look at this route, this is a little bit more complex, and this is where we're using /scheduling, and then everything that comes after /scheduling. So if there's anything else that comes after that, you can actually use that variable in the downstream path template as well. So in this case, I'm just putting that on a query string parameter to the downstream server, so we can actually see what the request path was. And it's going to the same service, and I've set up that legacy cookie authentication mechanism here as the way to do authentication for this particular route. So only requests on this route are actually being authenticated by the API gateway. And then I can plug in the delegating handlers as well. You can have default delegating handlers, which are essentially that are applied to every request. And you can do named delegating handlers as well to use them only for particular routes in this case. So let me just run this so that we can see what's going on. So I've set up the API gateway on the left, and then I'm going to run that echo service on the right. Let me just get rid of this. Right, so the API gateway is running and the echo service is running as well. Now let's go and grab our example requests. So this is using a Visual Studio Code extension, so I can actually send requests from Visual Studio Code directly rather than having to use something like Postman or something like that. So that's nice. This first one is going to that realization endpoint, and remember that doesn't do any authentication, it just forwards the request to the downstream service. So if I send this, you'll see on the left that's the API gateway, on the right it's the downstream service. And what you see is just all the headers that I've sent the cookie header as well, is just being sent back and is echoed by that echo service that I've created. The echo service is just reading all the headers on the request and then sending those back. So this is just really forwarding a request to the downstream service, nothing fancy. Now let's have a look at this other request, which is actually doing authentication. So if I send this request now, it's going to fail with an unauthorized, and that's because that cookie here has actually expired. So it's no longer valid, and the API gateway detects that it's not valid, so it's sending us 401 unauthorized. So let's have a look at generating a new cookie, which we can fairly easily do here. I've set up a command line tool to actually generate the cookie, and it's copying that to the clipboard. And if I put that into here, it's just for testing purposes, really. And I now send the request again. We should see that it's actually authorized now, and it's not sending that cookie header along to the downstream service, so we don't see a cookie header in here. But we do see an authentication header, and I'll talk a little bit more about that in my next couple of slides. So that's the basic setup for our API gateway, and it's all just basically ASP.NET Core with Ocelot plugged in and a bunch of configuration. Nothing more fancy is going on here. Right. So let's dive into the lessons learned, because what have you actually learned when we're building this? So the first thing, and it is probably known to everybody, or at least I hope so, security is pretty hard. So it's pretty hard to do this in a really secure way. When I initially built this, I was thinking, okay, let's just assume that whatever is behind the API gateway is going to be considered as a trusted subsystem. That isn't what we want to end up with in the long run, but for now, in our transition period, we deemed that would be fine to just accept anything that's coming from the API gateway by the downstream servers, and it's going to be just fine, right? So my initial idea was, okay, we eat up those cookies in the API gateway, and we translate that to a set of headers with all the claims that we need to do the authorization part in the downstream service. So we just get a bunch of headers that we can read, and then we can reestablish the security context from that. Pretty easy, right? Now, I hope somebody already can think of a possible security issue here, because what could happen is that the client would actually send that X role header as well, along with valid cookies. You would still need to have valid cookies. But then it would send to the downstream service both the header value from that set of cookies, as well as the header value that's being supplied by the client. So essentially, you get an escalation of privileges here, because now that user is suddenly an administrator, which is obviously not what we want. So how did we fix this? What we did is we introduced a certificate in the API gateway. So we gave the API gateway a certificate, and we used JSON web tokens instead, rather than having those separate headers. And then the downstream service only has to look at what's in that JSON web token, and can verify that it's actually coming from the API gateway and has not been tampered with. And then it can ignore all the other headers that are being sent along, or at least not for authorization purposes. So that was something we built, and it's not that hard really to build. We only had to do a couple of things. So I already mentioned that we had those delegating handlers, and that's actually where the magic happens. So let's have a look at this one, the authorization headers delegating handler. So this is a delegating handler for the HTTP client that you can use, and we're also able to use dependency injection here. So we get we can all get all the things from the dependency injection container, and then in here we have the send async method, and that's where the actual magic happens, right? So this is just before the request is being sent to the downstream service. We get to this method. And what we're doing here is we're reading the claims principal that's already been authenticated by that legacy authentication mechanism that we plugged in. So we have the claims principal, so we already know who the user is. And if we don't do anything, because then there's nothing we can forward, right? And then basically we're just creating a token. We put in all the claims of the user for now, but we might want to do things like claims transformation or stuff like that at some point. But for now, this is fine. And we make sure that the token is very short-lived, so it's only about 30 seconds at the moment. And we sign that token with the certificate of the API gateway. And then the downstream service can actually verify that the token it receives is coming from the API gateway. And that makes it a lot more secure than what we had initially. And then all we needed to do was use the security token handler and write a token, and we add that as a header to the downstream request. So that was pretty much what we had to do, and all we need to do is configure this delegating handler to be used when the request is being authenticated by the API gateway itself. All right, so let's continue on. We had another interesting problem that we ran into. We were using Windows authentication when doing requests between services. So some of the services call into each other directly or indirectly, and that was using Windows authentication to make sure that the request was being authenticated, rather than having all those cookies and stuff. And what's interesting with how Windows authentication works is that the first request that comes to the downstream service is going to get a 401 unauthorized, because you're not sending any authorization information along with the request. So you're going to get a 401 unauthorized, and it's going to have a header called www-authenticate. And that's going to basically tell the browser, but there is no browser here, but it would tell the browser to say, okay, prompt for credentials using this particular authentication scheme. And then another request would be sent, which contains the necessary authorization information. So the downstream service will then send an authorization header along with the request, in this case NTLM as the authentication mechanism, and as well a token that is NTLM compatible with the NTLM protocol. And then that would get sent to the HTTP client in the API gateway, and then it would be sent to the downstream service. But what's interesting is that the HTTP client seems to cache that authorization header. This was something that kind of caught us off guard. We weren't necessarily expecting this to work like that. I think it's actually a bug in the HTTP client, at least in .NET Core 3, and I think they fixed it for 5. But what would happen now is that once one of the downstream services has communicated with the other downstream service through the API gateway, it's gonna all the other requests, subsequent requests, are going to fail, or they're gonna basically inherit that NTLM token, which is obviously not what we wanted. Luckily, we had something in place in the downstream service to make sure that we not only needed Windows authentication, but something else. So it would actually fail in this case. So that's why we even saw this was happening. So yeah, this was a bit of a tricky thing, and yeah, we think it's a bug. But for now, we've worked around it. And basically, what we did is we removed a couple of headers on the incoming and outgoing request to make sure that that is working. So again, we used a delegating handler to do that. So let's have a look at that delegating handler. Here we go. So this is another delegating handler that's plugged in, and what we're doing here is that if the request going to the downstream service has an authorization header, which with a scheme of negotiate or NTLM, both could happen in theory, then we remove those that header entirely. We just set it to null, so it's gone. Then we send the request to the downstream service. And then on the return, if the response contains a WW authenticate header with negotiate scheme or the NTLM scheme, we're also removing that header from the response, and instead we're returning a forbidden, because it shouldn't be possible for outside clients that go into the API gateway to use Windows authentication. It shouldn't be possible to use Windows credentials when you log into our application, for example. So we just return a 403, and that's how that works. So again, very simple concept, really just tinkering with the pipeline essentially. All right, let's continue on. Another thing we realized is that we needed some way of doing the configuration, and we needed to do it, make it easier and faster as well. Because of course, in production, we're not just running on one server, because well, that wouldn't scale very well. So instead, we have currently 4 servers running in production, and we deployed the API gateway to each one of them. At least that's the deployment model we're choosing for what we're going for right now. And we needed to make sure that the configuration on each of those nodes is exactly the same, right? So it needs to be exactly the same. Otherwise, we would get we could run into issues depending on which node the client actually gets sent to. So we could have used our deployment tool to do that and just make sure that it's deployed to all the servers as usual. But that would require us to do a deployment of the API gateway every time we needed to make a change, which seems a little bit wasteful. And we were also a little bit concerned that there might be a short delay between when each of the nodes is actually getting the update. So then it would still be possible to have a short period of time in which the configuration wasn't consistent across each node. So we also solved that, and for that we're using console. Console is a lot of things actually. It's almost like a server's mesh, I guess, but that's not what we're using for now. We're just using the key value store part of console. And that allows you to basically store the configuration in console. And console is going to ensure that it's going to be synchronized across all the nodes that are part of your console cluster. So in this case, our four nodes, and it uses very particular algorithm to make sure that that's actually consistent and it's maintained and persistent and all that kind of stuff. So that's what we put in. You might have seen it already in the code I showed you go by. So let me just briefly show you what that means. It's very similar to what we have right now, and it doesn't really make sense on a one node machine, but just for demo purposes, I've gone ahead and done that. So I've actually ran a console in a Docker container earlier, so it's already running on my machine. I can actually show you here in my browser that we have a console running here, and I can do key values. So I've already put the configuration, and it's exactly the same configuration that I was using in the configuration file itself, and I'm already using that, put that in here. So it's the same set of routes that we have, so we can do the same test basically. And then in the code, we had to do some other things with configuration. So if we go here to this section, you can actually see that we're telling Ocelot to add support for console. Ocelot has a separate package which depends on the console client library for .NET. And then you can tell it to say, okay, load the configuration from console instead of from the file. But that would still require you to have some kind of key with which you load the configuration from console, and you also need to know how to connect to console in the first place, right? So how does that work? As you can see here, we're only doing this when it's not in development to make it easier to develop locally. But for production, we're actually using Ocelot. And let me look at the Ocelot JSON, because that's what we're using then as well. And in here, you can see that we're using the configuration key. That's what we specified here. And then we have the, sorry, not sure what that is. And then we have the host and port for where we can find a console, so we can actually connect to it. In this case, it's running on localhost on port 8500. So let's restart our API gateway, but now in production mode. So the easiest way to do that is to kill the current instance and say ASP.NET Core environment is production, like that. It's going to start up, but now it's loading our configuration from console. You can actually see those polling. It's actually actively polling console if there's new configuration. And now if I do the same set of requests, I'm gonna, they should still work. So they're actually working right now. But if I change the configuration here, so I can break this and say, and now we should, if I save this, and now it's instantly synced across many nodes, right? Except I only have one in this demo, but you get the idea. And now I get a four node found, and it's instantly available on each of the nodes with the new configuration. So that's pretty nice as well. And we're already using console for other stuff now as well, to make it just easier to configure things and changing configuration on the fly, which is quite nice actually. All right. So our last lesson learned, I guess, is that observability is very important if you're doing this. Because we had one big question actually once we built this and we were testing it out in our test environment and it was all working. And we were like, okay, how is this going to perform under load in production, right? We had no idea. And the only real way of finding out how it's going to work there is to actually put it into production and testing it live and see what's going on. But that's the important thing. Then if you do that, you need to really know what's going on in production. You can't just put it there and pray that it's going to work just fine. So, and we've been a long-time user of New Relic, which is a observability platform, basically. And we've been using that for a long time. And just when we were initially building this, they shipped a new feature called distributed tracing. And what that does is it allows you to visualize all the requests coming into your application or into your services. But it can also trace those requests across multiple services. And with the API gateway put in front of it, we're going to have that situation. All the requests are going into the API gateway first, and then they are transferred to a downstream service. So I had a screenshot here. In this case, we're looking at the health endpoint. And here you can see the trace of what's actually going on. But it's also calling into console to see if console is available. And that's why you see that stream get. We don't have any observability in console itself at the moment. I don't think we really need that. But if this were to call into another service that's also being monitored by New Relic, then you would actually be able to dive in there as well and see what that's calling, et cetera, et cetera. So having this in place is I think, extremely important if you want to try this out in production. We also made a dashboard where we can see how things are going with the rollout and stuff like that. At the moment, we're not actually putting anything behind the API gateway. It is running in production, but it's not actually handling requests that are actually going to any of the downstream services right now. But we are planning on doing that pretty soon. But we did some experiments, some early experiments earlier on as well. So we made this dashboard, and you can see things like, okay, to which services is the API gateway currently calling? You have that service map on the right. And then we can also see requests on each host and the response of the request and the timings and all that kind of stuff. So this is actually, I think this is really important if you want to really be able to do this live in a production environment. I can't show you a live demo. There is not much code in here as well. It's just one thing. You might have seen that actually if I go to the program CS here. As the first thing, we're setting our application name for New Relic, and all the rest of the stuff is just handled by the New Relic agent that's installed on each of our production machines. So we don't need to do anything else to make this work. It's just setting an application name, and it just works like magic, I guess. But that's kind of nice. So I'm going a little bit quickly, but let's talk about something that we're looking forward to. We have there's a new project announced by Microsoft called YARP, which stands for Yet Another Reverse Proxy, and it's built on top of ASP.NET Core, just as Ocelot is built on top of ASP.NET Core. It has a very strong focus on performance. They're actually saying that they have a performance that's similar to something like Nginx or other reverse proxy systems, basically. And there's a preview available since the 21st of May. And they actually shipped preview 2 yesterday. That came out yesterday. I've already tried some things with YARP to see if we could replace Ocelot with YARP, essentially. They are very similar in what they're trying to achieve. It's just that YARP is really early days at the moment. It looks promising, and definitely in terms of performance, I can already see it's faster than what Ocelot does currently. So for performance reasons, it might be interesting to switch over to that. But there's a couple of features still missing that we actually need to make this work. So there's some work there to be done, but I think it's interesting, and I think we can actually fairly easily transition from Ocelot to doing YARP once that's available and stable and ready for production use. So finally, let me point you at some resources. We have the Free Mammals website. That's actually the owner of Ocelot. You can have a look there at https://freemammals.com/ocelot. You can find out that there's not much on the website itself, but you can find out more about how it works, and it points you to the GitHub repo and the docs and all that kind of stuff. There's also a Microsoft doc on their architecture center. They have all kinds of architectural documentation on different patterns you can apply in your applications. And one of them is about API gateways, and they're also doing that with Ocelot as a way of actually implementing it. So definitely check that out. And as for YARP, which is what I just mentioned, they are up on GitHub, github.com/Microsoft/reverse proxy. So definitely, if you're interested in this kind of stuff, definitely jump in there, try it out, or try it with Ocelot first if that's your thing. I think having that API gateway in place is really going to enable us to move faster and really be able to do things gradually and in a safe manner, and rather than have to do big bang releases, which is not something we like to do with that many customers on our application. And so with that, I think I'm done. Unless there are any questions already. I can't see the questions right here, but maybe somebody can tell me.
Hey there, we're still on .NET Core Summer Event, and this is the last session of the day. We just saw a great session by Jonathan. He was talking about building an API gateway using Ocelot, which is an open source tool. Pretty cool. And the last session of the day, I want to introduce you to Anthony Giretti. How you doing?
Hi everyone, how are you doing? I'm good,
Great.
and you?
Yes. Okay, so you're going to do the last session. It's about gRPC, so I'm pretty stoked about that. So yeah, the floor is yours. Take it away and talk about gRPC.
So first, thank you for the opportunity. And now I will introduce myself. I'm Anthony Giretti. I'm a Canadian, French, and Italian developer. I have been living in Canada, especially Montreal, since 2014. I'm a senior developer in a company named eShop, and I'm also a Microsoft MVP. And today, I will talk about gRPC in the .NET world, especially ASP.NET Core 3.1. And we'll see all you need to know. Let's go. What we will see today, I will introduce you what is gRPC in general and how it's working on ASP.NET Core 3.1. In the meantime, I will introduce you something a bit different, but same. In the meantime, is gRPC Web. How gRPC Web is working in ASP.NET Core 3.1 as well. Then we will see how gRPC and gRPC Web are working in Azure, and more for the conclusion, what is gRPC versus REST API, and why we should or not use gRPC in the .NET world. And then we will end with a little demo. Let's go. So what is gRPC? gRPC is RPC framework remote procedure call. It's not a Microsoft, it hasn't been designed by Microsoft, but by Google in 2004, and they open sourced it 10 years later in 2014. RPC is not a new framework. It hasn't been designed by Google. Google has only designed gRPC, a new way to make RPC calls between a machine to machine. So how does it work? It's based on HTTP2 only. It doesn't work at all on HTTP1. We will see a bit later why it can only be with HTTP2. Messaging, how does it work? It's not JSON like Web API or XML. It's based on protocol buffer. Protocol buffer are contracts equivalent to WSDL for WCF, and they allow to translate message in binary. JSON for Web API, but it's binary for a gRPC. That makes it very performant, 25% more performant for a same payload compared to JSON. RPC are designed for server-to-server calls, so it hasn't been designed for browsers, and it's not compatible for browser. You might wondering why. It's easy. It's a binary serialization. A browser doesn't understand bytes. That's it. It's not supported by Azure App Services and IaaS because HTTP2. I will give you some explanation a bit later. But it doesn't mean it doesn't work at all on Azure, only Azure App Services and IaaS. How does it work? Finally, gRPC services are working with only one verb in HTTP, post only. No get, no put, no delete, etc., etc. Only post. The content type is application-gRPC. They work with classical headers like classical HTTP request plus some specific headers named trailers. What are trailers? Trailers are custom metadata in the headers. That's it. Very important thing to understand. This is the basic. gRPC always return HTTP status 200. Okay. So you might have many questions about this. How does it work? Yes, this is normal. Only passed with HTTP 200. Okay. But how we handle errors? We have gRPC status that are mapped in the headers if you want to understand what's going on if there is an error. So each error has its status, gRPC status. The only way to get something else than 200 OK is a server error. So since the server handles gRPC request, it will always return 200 OK. The binary response is always a binary response, and it's not human readable. So you cannot debug it very easily. What are gRPC status? The first one is OK, and its number, the associated number is 0. Then you have 1 to 7 to 17 errors. For example, canceled, unknown. If you want something that looks like REST call, we have not found, which status is 5. Permission denied, it's like forbidden. We have also internal, like internal error, 500, for example. How gRPC is implemented in ASP.NET Core 3.1. What we see in green, these are Microsoft implementation based on Google and community implementations. gRPC Core API, gRPC Core, gRPC tools, and Google Protobuf have been designed firstly by Google, and after it has been open sourced, it has been maintained by the community. And Microsoft in green has designed their own packages to build a great implementation of gRPC in ASP.NET Core. How can we create a gRPC service in ASP.NET Core 3.1? You need at least Visual Studio 2019, and you need a gRPC template. Finally, it's an ASP.NET Core with some more packages dedicated to gRPC, but it's an ASP.NET Core application, nothing less, nothing more. And it's only compatible with .NET Core 3.0 and ASP.NET Core 3.0 minimum. You just need to type gRPC in the search pane, and you will have the template available. gRPC is based on protobuf file for designing your service. How does a protobuf file looks like? You need to set a syntax, Proto3. This is the latest syntax available. Proto1 and Proto2 are deprecated. You have to use Proto3, but unfortunately with Proto3, there is no message validation available. So we don't have validation like data annotation, for example, for ASP.NET MVC, Razor Pages, or Web API. How we have to write it? There is a section name service. You name your service and you define your methods with the keyword gRPC, the method name, the message, the incoming message. You might wondering why there is an empty request here. It's because in gRPC implementation, you have to put an object, even if the message is empty, you have to set up an empty message. So an empty message, then uncompiled, an empty class. This is mandatory. Then you set returns keyword and the message that is returned to the client. There is no convention. There is no guidelines for gRPC. You have to find yourself your own strategy to name incoming payloads and your output. So I decided by myself to name all my incoming objects, to suffix them with request, and for output, suffix by reply. As you can see, it supports a lot of types, everything, strings, int, and repeated is simply an array of enum. gRPC and protobuf supports also as well enums. Number here are the position in the serialization process. That's it for that. gRPC in ASP.NET Core 3.1. Once you design your protobuf file, you have to compile your application in order to generate entities, messages in gRPC world, and your service method to expose. What you have to do once compiling, my own service, for example, and my own service gRPC.cs, are two separate files. Why? The first one contains messages, the second one service methods. Once you see them in the .NET Core app folder, it means everything went well. You can now write your services based on this auto-generated code. How we write a gRPC service? You have to inherit from the base classes that has been generated by protobuf compiler. Protobuf compiler is a compiler that transforms protobuf file to C# entities. How does it work? You name your service, you inherit from the generated class, you can build, you can add a constructor. It's definitely compatible with injection dependency. I will show you an example after. You have nothing to do. It's an ASP.NET Core app, so you want to inject anything. You just have to register your instance, like a web API, for example. And then you have to write all your method with override keywords. That's important because the generated code generates virtual methods. Your message is there, your incoming message, empty request, for example, and server context is the HTTP context in the gRPC world. That's it. But it's not only an HTTP object. It contains an HTTP request. You can get it, but you can find all metadata for gRPC plus the HTTP request. That's the server call context. On your right, you see anatomy of the project. You have a proto folder. You can add your proto file there. And in opposite to web API, there is a service folder that you can put your services right there. So this is the default template. The default template is not my own gRPC service, it's Jupyter service. But this is exactly that structure when you create a template. So there is always your program CS and your startup programs. File, sorry. How to configure your gRPC service? Instead of web API or MVC, you just need to add gRPC. For web API, it's add controller, MVC, add MVC. For gRPC, it's add gRPC. That's it. Endpoints. You have to define your endpoints. So it's very similar to ASP.NET Web API. You just need to use map gRPC service and reference your service right there. And if you can't reach because you don't, there is an issue with to find the endpoint. There is a default endpoint named map-get, and there is a message by default written by the ASP.NET Core template right there. How to consume a gRPC service in .NET Core 3.1. So because it's not compatible for a browser, you can only use it in an ASP.NET Core application server side. So it could be an ASP.NET Core MVC app, a Blazor app, you can as well. For example, a console app. I will make my further demo with a console app. You need to click on your project, right-click, service references, and add by clicking your protobuf file. You just need to fill the path of the protobuf file, and that's it. Just after, you need the same thing as the server part. This is the client part. You need to compile, and as a server, it will generate a class that contains messages, we can say entities, and services, plus for the client, an HTTP client in the second file. So, like the server, it's compiled by protobuf compiler. It's included in Visual Studio. You don't need to install it by yourself. How can we call sorry, a gRPC service from a .NET client or .NET Core 1 and 2? Because it's different with .NET Core 3. You need to install a package named gRPC.NET.client, and it's totally generic. You can call any gRPC service with that client, even if it has been designed in Java, PHP, Node.js, or Python. You need to instantiate a channel, set the address, and then pass the channel object to your client. And you can call your method like this: client await client who is async, and the empty object. If there is any issue, you can catch it with a gRPC exception. gRPC exception is an exception with metadata like trailers for gRPC. So additional data to debug your exception. How does it work in .NET Core 3 client? It's different. It has been designed for .NET Core 3 especially. This package is named gRPC.NET Client Factory, and it supports injection dependency. So I have set up an injection dependency system in a console app, and you can use a gRPC client extension method. And it works like this, as the same as previous. So you can do the same job, but it's only designed for .NET Core 3 client. What can we do with gRPC in ASP.NET Core 3.1? We can authenticate, definitely. Not by cookie, because it's not compatible by browser, but it supports GWT. It doesn't support Kerberos, because Kerberos is not compatible with HTTP2, unfortunately. We can make crude operation, create, retrieve, update, delete, but you have to design yourself your methodology, how I will name my message, how I will name my methods. This is up to you. It's different than REST. You have get for getting data, put to update, delete for deleting data. We can definitely add logging anywhere. There is no global exception logging, for example, like a middleware in ASP.NET Core MVC or Web API, but you can configure interceptors. It's like an attribute, but it doesn't work like the same. You can audit and monitoring your app, but with application inside. But the thing you have to know, it's hard to debug. Do you understand why? because it's only a post that returns 200 OK. So you have to click on each call and see if there was an exception within. So it's hard to debug, but you can use it. gRPC supports health check, integration tests with, how can I say it? What's the name? Test server, sorry. And unfortunately, there is not native validation, as I said before, but I have designed a package named Calzerari gRPC.NET Client Validation based on Fluent validation, and through trailers, you can get error details within a collection of errors. So that's pretty useful because you cannot use a data annotation with gRPC. So if you want to try it, you can download that package. It's fully documented on the README on my GitHub. Next. We talk about gRPC. So it was designed for server-to-server calls, but I said gRPC is not compatible with browser. It's not totally wrong. It's not totally true because Google has decided to find a way to make it available and compatible for browsers. So Google and Improbable have worked together on a solution named gRPC Web. What is gRPC Web? It's a JavaScript library. The issue was how we can transform binary payloads to a readable payload for humans and browsers at the same times. They design a new way to transport data, gRPC Web or gRPC Web text. gRPC Web content type is base 64 encoded. And gRPC Web text is a text encoded, so it's full text. Why? Why these two of them? The first one is base 64 encoded. It's more performant. The second is fully text. But the second one, in opposite to the first, is compatible with streaming client to server. So it's not possible to stream in gRPC because gRPC design base 64 encoding. It's possible by text. So if you want to make streaming calls, you use gRPC Web text content type, or you can use gRPC Web base 64 encoding. But gRPC works with HTTP too. So what we have to do, you have, if you work with gRPC Web JavaScript library, you have to set up a proxy between your browser and your gRPC server that transform HTTP2 request to HTTP1 request and vice versa. So that's the purpose of that proxy. And now we will see an interesting feature in ASP.NET Core. Not right now, just after. Just before, I will introduce gRPC Web library. What is gRPC Web? It's based again on protobuf file, and you will use once again protoc to compile your protobuf file to TypeScript or JavaScript. If you want a TypeScript client and messages, you have to download a particular plugin. I will show you in the demo. And then you will be able to generate entities. What does the plugin? It does write type definition for your service and type definition for your entities. If you use JavaScript only, you will just have these two files, country pb service.js and country_pb.js. How we can write a client in TypeScript or JavaScript. It's a bit more complicated than just a web API call, a classical web API call. You have to use gRPC unary. Unary is like one request, one answer. So like a web API call. So fully stateless, you send a request, you have an answer. There are many methods, gRPC streaming or bidirectional streaming. I won't make a demo right now for that. I will just keep it as simple. You have to define your request object, your host, and not like a promise. It's not then method. You have to use on-hand method. This is similar. Syntax is just different. And you can deconstruct your response and get status message, errors, message, trailers. If the gRPC code is okay and you have a message, you can deserialize it from base 64 encoding or text, depending your content type you chose, and read the answer. It's a bit heavier, but it works fine. gRPC Web in ASP.NET Core 3.1. Since January, James Newton-King from Microsoft has proposed an implementation that avoid users to design and set up a proxy between your browser and your ASP.NET Core application. Finally, the proxy is within the ASP.NET Core application. So you just need to download gRPC ASP.NET Core Web. This was the preview version on my demo, but now it has 2 weeks ago, it has been released on a stable package. And it allows you to discard the proxy. You don't need a proxy anymore. That's great. How does it work? You just need to add on your current gRPC application, use gRPC Web. What does it do? It's simple. If it detects a gRPC text base 64 or base 64 of text within the header, you will understand, oh, you don't want binary. Okay, I will answer you by a text or base 64 encoding. That's great. You can mix a gRPC service and a gRPC web service. And even if you have enabled gRPC web on your service, it's compatible at the same time with gRPC and gRPC web. So it doesn't alter the behavior of your application. It just adds a new feature, a new way to call your service from a browser. Don't forget to set up your CORS policies or any origin, any method, but you can just set post, any headers, and you have to accept expose header gRPC status and gRPC message to make it work. gRPC Web in .NET Core, yes, you can use it not only within a browser, but even a client-side application, server to server. It's compatible as well if you don't want or if you can't use HTTP2 in your infrastructure. We never know, but it's possible. You need to download gRPC.NET Client Web, and you can write your client like this. So it's not the same client, not at all. You have to instantiate a gRPC web handler and select gRPC web text or gRPC web. You have to instantiate a new HTTP client handler, and the rest is similar to the .NET the classical .NET client. And the consumption is exactly the same. And if you have an exception, you can catch it with an RPC exception. It works as the same. The client is just a little bit different. Why? Because the first one only handles HTTP2. This one handles HTTP2 and HTTP1. That's the reason. gRPC and gRPC Web in Azure. Unfortunately, as I told you, gRPC is not supported in Azure App Services. Why? Because implementation of HTTP/sys, it's a server very similar to IIS, designed only for Windows, and it doesn't support HTTP2 and trailers. Trailers in HTTP2, but it works in HTTP1 because HTTP1 supports trailers. gRPC is supported by Azure Container Instance and Kestrel in self-hosting in VMs. gRPC Web is supported by everything in Azure. Azure App Services, SCI, IIS, Kestrel, etc., etc. gRPC versus REST. I introduced you gRPC, but what are the real difference between a REST API? As you can see, stages codes are different, so handling errors is not the same at all. Serialization is binary versus JSON. Or if you are using gRPC Web, this takes us base64 encoding. gRPC works only with HTTP2, gRPC Web HTTP1 and 2, versus HTTP1 and 2 for ASP.NET Core. HTTP2 is supported from ASP.NET Core 2.2. Once again, you have to generate code versus no code generation. So some people don't like the WCF concept, auto-generate classes, and support definitely. Doesn't support browser, sorry, definitely. Why using or not gRPC? gRPC is gRPC because it's binary serialization, but as well HTTP2. HTTP2 provides a lot of performance benefits like streaming, bidirectional, client to server or server to client. It's convenient by this way because unidirectional, bidirectional streaming. You can do a lot of things that you can do with an API. HTTP2 is more performant versus HTTP1 because the connection doesn't close as soon as the request is done like HTTP1. So the browser can reuse the same connection. So you save time to open a new connection. Specification is very strict. There is no debate anymore on RESTful convention. Should I use put? Should I use patch? Should I use get, delete? What should I do? Verbs, URL formats. You don't have to manage it. gRPC does it for you. Once again, code generation and no code generation. People like code generation, people don't. It become more and more mature, but for me, it's not enough mature. For the first reason is the validation. There is no native validation, so you have to write it yourself. Or you can use my own package. So it's might be embarrassing if you cannot use any packages that does validation. Let's go to a quick demo and see how it's working. Okay. How does look like my service? Let's go to my country service. As you can see, it supports injection dependency. It supports authentication. It's deactivated for now. You write and you override your whole methods. Okay, you write your own implementation. That's it. The service is simple. So you can definitely inject any service, like any project in ASP.NET Core. How you register it, it's absolutely the same as a web API. It's, I repeat again, it's a simple ASP.NET Core application. You can set up your token authentication here. You can set up your entity framework DB context. This example is a bit weird, but It's just in-memory setup. I could have set up a started task. I just wanted to keep it simple. I have activated interceptors. What does interceptors? It catch all exception within an binary call. So if you want to catch and handle errors specifically in a bidirectional call, like not a unary call, but a streaming call, you have to implement the streaming server handler methods. Let's see there, all available methods. Async unary, async server streaming, async client streaming. And then you can catch your error as you want. RPC exception. If it's not an RPC exception, it might be an SQL exception. If it's not neither RPC exception or SQL exception, it's an exception and you can log it. Don't forget to throw an RPC exception. You have to respect a rule is to send 200 HTTP 200 OK, and it's verified by RPC exceptions that ensure you return in the meantime of the error HTTP 200 error. And you can set up a message in the trailers and the gRPC status. Cancel when you don't know what happened, but you can definitely set up another error and set, for example, internal as you watch. Program. No, it's not the right program. The program is quite the same as any ASP.NET Core application. You can set up Azure Key Vault. I deactivated there. It's quite the same. Protofile. This is my protofile right there. The namespace here is when you compile your protobuf file, the generated class will belong to demo gRPC protobuf. If you don't set it, there is no particular namespace. No, it's mandatory, sorry. It's for the client. You don't have to set up a namespace. For the server part, you have to set up a namespace. So I think we are ready for the demo. Just before I will show you the client. The client is compatible with Poly. So I've made a demo. I will show you how Poly works with gRPC. As you can see there, I manage server errors and gRPC errors. Remember, if the servers encounter an error, the request won't enter in the gRPC pipeline. So I will have regular HTTP errors. If the request is handled by the gRPC pipeline, I might return many errors, 16. Here is my function in Poly. I will add it to my client right there. And I will execute it. First, I will start the server. Okay, let's start the server. Entity framework is well initialized, and the server is ready to respond to any request. Now, let's make a call. We will use gRPC, but I have also gRPC web client. I will make you a demo if you want. Let's start the client and see what happened. Oops, request failed with internal retry. Once again, free time. Ooh, what's going on? It's a fail. Okay, let's go to the server to debug. Oops. I stop my server. I'm debugging. Oh, there is an error. Okay, let's fix that. Now let's restart the server. Server is ready to answer. And the client now. Yeah, he found countries. Canada, Maple Leaf country, Japan, Rising Sun country, Australia, Wallabies country. Our client works fine. We can make the same demo now with gRPC client, gRPC web client. Let's do this. Okay. I can choose my mode, gRPC web or gRPC text. This one is compatible with streaming, this one not. Let's use text. And start client again. And it works like a charm. So I think I'm done. Yeah, just a little precision. The gRPC status management is a bit weird. Why? Because when a request succeeds, the status, gRPC status is within the body, not the headers. But when the request fails, the gRPC status is within the header. Why? I don't know. I have asked to Microsoft, and the answer was it has been designed like this by Google. Okay, fine. In a browser now, I made already the demo. I called my own URL right there. Headers, post, 200 OK. Look at the request URL that has been generated right there. Status, all origins, etc., etc. Forwarded by .NET, Microsoft, etc. So it really looks like a web API call, but it's not. Let's check the answer. And the answer is text. And as you can see, the gRPC status is right there. So that's it for gRPC. I hope you enjoyed this session. And if you want, you can find all the references, the whole documentation, the huge documentation of gRPC right there. You can join me on Twitter, on LinkedIn, or by email and ask me the PowerPoint if you want, and you will be able to check the whole documentation. So that's it. Thank you very much, and hope to see you soon.
Bye.